Everyone who's tuning in from across the world, you're very welcome. I am the co-creator of the Filecoin Green project, and as Jamie said, I have a couple of other hats that I wear, but obviously I'm deeply passionate about this specific project. So I'm going to just get right into it because we just have such a packed day. It gives me huge pleasure to introduce the man behind the magic of Filecoin Green. Please put your hands together for the wonderful Alan Ransell. Alan can be a diva at times, so his rider didn't have the green M&Ms. All right, put your hands together for Dr. Alan Ransell.
Awesome. Awesome, thank you. Thank you for coming. As Angie said, I'm Alan. I'm the team lead for Filecoin Green. And I spend a lot of time thinking about these two questions, right? So how can we take crypto projects, make them verifiably sustainable, and how can we take the world of Web3 and use that to upgrade sustainability claims? People often think of these two questions in separate buckets. And I'm going to make the point today that we should really think of them as two sides of the same coin that are mutually reinforcing, and we should build a community around solving both of these problems at the same time. So there are two meta points that I'm going to talk a little bit about at the beginning and then come back to. One of these points is that there's a lot of uncertainty in all of these systems, and we should take that as an opportunity to overestimate our impacts, and then we should be really rigorous about showing our work when we make these public claims. The second point is that fiat and Web3 are actually inadequate to counter environmental challenges. We're going to come back to that. This first point, overstate your impacts. The justification for this, of course, is that we're out of time. Right, so on the left you have this graph showing global temperatures for the past 1,000 years. They've been in this relatively narrow zone that civilization as we know it has been developed in. And it's only been in the past 100 years or so that temperatures, because of human activity, have substantially deviated from that narrow range, right? That's a spectacularly dangerous thing, and the time to kind of quibble about what is the minimum that we can do to make these net zero claims or whatever, that time is over. We should really be looking at this from the point of view of how much can we do with the resources that we have available to catalyze a more sustainable alignment between the economy and the natural world. The second point, fiat on Web 2 is inadequate to counter environmental challenges. That's ultimately because environmental accounting needs what Web 3 is offering. A clear, sort of quick way to see this is that one of the foundations of Web 3 is to move from location addressing to content addressing. And so with location addressing, you type a URL into your browser. That resolves to an IP address. That IP address ultimately tells you where on the network the resource that you're looking for is. Right, so if someone, so you have to hope that whoever is maintaining that resource in their walled garden, right, keeps that resource at the same place on the network. And if they move it or if they change it, you might not be able to find it. You won't be able to tell whether they changed it, right? Whereas with content addressing in Web 3, you search for a resource based on the fingerprint of that resource. And so wherever it is on the network, if someone can find it and give it to you, you can't just get it and be sure that you have access to it as long as it's somewhere on the network. You can also verify that it is what you were looking for, right? And so that's extremely powerful. You get this verifiability because this is all organized around the fingerprint of the resource that you're looking for. And you also get interoperability because rather than having all of these different data structures exist within these walled gardens that these companies and projects have to put a lot of energy into maintaining separate from everyone else's walled gardens and everyone else's data schema, you're able to verify that the resource is the resource that you were looking for relative to all of the data structures that exist in humanity's knowledge store in the web. And so that interoperability and verifiability are really what we need in order to upgrade these environmental claims and track how environmental impacts are flowing through the economy. So I'm going to talk some about Filecoin Green specifically and what we're working on to make Filecoin itself verifiably sustainable, and thinking a lot about how we can use Filecoin to upgrade environmental claims more broadly. So Filecoin uses electricity in order to store files and prove that they are stored over time. there are two major components to the energy use of Filecoin. The first we call sealing. This is when you are setting up a proof system that's going to allow you to prove that you are continuing to store that data over time. So that sealing step takes some electricity, and that's a big part of our model, and we want to account for that. Then you also need to store the actual data over time. And so that's another component of the electricity use of Filecoin. What is really special about this system is that because your chance of winning a block reward is proportional to the capacity that you're committing to the network, we have a proof on-chain of how many resources every individual node in the network is contributing over time. So it's not that we just see storage providers when they win a block reward or when they make a transaction. We actually see over time, every time they add a sector, right? So we actually know this storage provider is contributing, this many gigabytes of storage to the network, and we see how that changes over time. And we have proofs verifying that publicly. And so what we did was we took all of that information, we talked to a lot of storage providers, and we turned that into a model, which you can see if you go on GitHub, or if you just go to filecoin.energy. You can see for the network as a whole how much electricity is being used. You can see the upper bound, the lower bound, and the estimate. And if you type in a miner ID for an individual Filecoin storage provider, you can see this graph and other graphs showing all the data that went into that for that specific miner ID. So that gives you this granularity that is backed by these public proofs of resources committed to the chain. And so how does the electricity use of Filecoin stack up compared to data centers? This data, there are a lot of caveats to this data. I'm using 2020 numbers here for global data centers because this information is hard to come by and it isn't published super frequently. But when you look at Filecoin storage today, there is about 0.87% of global data center storage capacity. All of the data in data centers all over the world is 0.87% of that is stored on Filecoin. And Filecoin, we think, uses about 0.67% of all of the energy used by data centers around the world. And so when you look at this, the data storage component, which is a major component of energy use, is comparable to data centers around the world. That sealing component adds a little bit, but as you can see from these numbers, it's in line with what data centers use. Also, as the network grows, it's gotten more efficient over time. And so if you compare these numbers now to a few months ago, so a little less than 4 months ago, about 3.5 months ago, the power intensity of the network has actually decreased. So it's about 5% more efficient than it was. And we expect that to continue over time. And so what this means, right, once we have this really granular level of data that is connected to these public proofs of resources committed to the network, we can do all sorts of things with that. So one of the things that we can do is take location data. Jim Pick is this great developer in the community who's done a lot of work mapping storage provider nodes to locations using IP addresses. We can take that data and combine that with data from this model that I mentioned, this dashboard. And we can use that to get a snapshot at any point in time of how the Filecoin network is using electricity in power grids all over the world. So this is a map contributed by another amazing community member, smartb.eth, in which he took those two data sets and combined them, right? And so you can go to this URL and you can see how much electricity is being used by storage providers in the Filecoin network all over the world. And so the other thing that we can do when we have this really granular level of data is we can connect Filecoin storage providers to renewable energy. This is a schematic of how renewable energy markets work. You pull data from the power grid. You pull electricity from the power grid. Electricity and data, I think of those as pretty tightly connected. You pull electricity from the power grid, and a lot of people are putting energy into that power grid. Some of them are renewables producers. Some of them are other producers, fossil fuel producers putting electricity into the grid. And you go to a renewables producer and say, I want to buy electricity from you. And there's this accounting system of energy attribute credits that is overlaid on top of the power system, allowing you to agree that I'm going to use renewable energy from this particular provider, right? So what that means then is we're able to take nodes in the Filecoin network and connect them not just to renewable energy in general, but to specific renewable energy providers producing energy for them over a specific amount of time from a specific source, so solar or wind or whatever that source is. And you're going to hear a lot more about that in discussions today from Doug, who's speaking next, and from Beltran, who's speaking later in the day, talking about this global renewable energy marketplace using Web3 native tooling that they're developing at Zero Labs. So what we're able to do, so we've taken the Filecoin network, and we and the Filecoin Foundation are working really hard to connect nodes on the network with renewable energy over time. And so here's an example of what that looks like. On the left is a graph of the amount of electricity used by this particular node in the Filecoin network over time. Then on the right, that's connected to a REC certificate or an EAC certificate that shows, okay, this node purchased solar energy, or wind energy, I think in this case, from this particular provider that was on the same power grid during this particular time interval. Right, and so we're able to make that data publicly available, and we're working on Web3 native tools to make that available for any Web3 project that you want to have this sort of deep level of granularity and verifiability connected to. So we're also working to help build solar capacity over time. So this is the roof of Descent Hosting. Hida is you're going to be hearing from him later. He's in the audience. They are, I believe, one of the largest Filecoin storage providers in Europe, if not the largest. The Filecoin Foundation gave them a grant to put solar energy on their roof and make the data from those solar panels publicly available over time. So this is not just there's a certificate linking the energy consumption of this particular Filecoin storage provider to solar produced somewhere else, but we're actually going to be able to show, they're building the APIs for this right now, in real time, in a publicly verifiable way, what the energy use of all this hardware is, how much electricity is being produced locally, and match those up, and then see what's coming from the grid, right? And then also use EACs to cover energy coming from the grid. And now when the sun is shining, they're getting 100% of their electricity use covered by solar panels on the roof of their building. So we're really excited about opportunities like that to produce more solar in addition to just purchasing solar from other projects. Another thing we've done in this space is Protocol Labs has put money into a fund recently, $35 million into building new solar capacity in the US. And so we think based on that estimate, we think that this is going to build approximately 3.5% as much solar generation capacity averaged over a year as the network consumes in a year based on current electricity consumption of the network. And we're excited through all of these different avenues, right, to see how we can use the resources that we have at Protocol Labs and within Filecoin to catalyze the energy transition to renewable energy and catalyze a more sustainable alignment between our economy and the natural world. So if you're interested in this work, please visit our website. We have a website now, as of a few hours ago. We have green.filecoin.io, where you can check on a lot of the projects I just mentioned here. If you're interested in building in this space, we really want you to build in this space. So, please, the Filecoin Foundation is giving out grants to build, ideally open source Web3 native tooling in order to do things like take all of this energy data and look at emissions based on the location of energy use in the grid, or whatever other tools you want to build. We want to support you in building them if it's aligned with this mission to improve verifiability in environmental claims in a Web3 native way. You can also join our monthly meetups the first Tuesday of every month, and there's more information on the website. Please use the Filecoin.energy dashboard. There's an API associated with it. You can get stats from any storage provider using that API and incorporate that into your project. And if you want to sign up for updates, you can go to tinyurl.com/filecoin-green-updates. And I want to come back just before I close to these two meta points, which are that we should overestimate and show our work, and fiat plus Web 2 is inadequate to counter climate change. I really want to say, firstly, on this overestimating impacts, that doesn't just go for electricity use. So when we are matching Filecoin storage providers to renewable energy, we're not using the estimate, we're using the upper bound of the electricity use that this model spits out. And our thought there is, we'll match to the upper bound, and if you want to make renewable claims using less renewable energy, we'll provide pathways, and you can develop pathways to prove what your actual electricity use is. But until we see the proof, we're going to use this upper bound, right? But we shouldn't just overestimate impacts in the context of electricity use, because there are a lot of other things that we need to do in order to better align our economy with natural systems. This is called the planetary boundaries framework. This is a set of variables that we can measure in the world that have boundaries on them. So as long as these variables are within a specified range, the global systems are stable and sustainable. And what you see is we've violated those boundaries globally in a few different areas, like biodiversity loss, like plastics pollution in the oceans, like chemical runoff from fertilizers. And we need to get those back within safe ranges for the sustainability of everything we do, right? And so blockchains emit a lot of blockchains emit amounts of CO2 that like dominate their environmental impact, right? Depending on the chain, depending on the consensus mechanism, along with e-waste. And we should measure those things, but we should also build tools to track how all of these other impacts flow throughout the economy, right? Because the people who are going to adopt those tools first and make sure those tools are really good are in the Web3 community. And if we have the best tools here, and other people doing sustainability accounting see that we have the best tools here, they're going to start using our tools, and that's going to improve sustainability accounting across the entire economy. So we are broadly in Web3 a community of people who strongly believe in the power of building new technological tools to solve really big problems. And that, to me, means that we shouldn't see any of these planetary boundaries as out of scope as to what we're doing. Then the second question, let's come back just really quickly to answer why fiat plus Web 2 is inadequate to account for environmental challenges. So this is from the executive order that just came out. You probably saw this week. The White House ordered the executive branch to do a series of reports on crypto, right? And so if you look at this report should specifically address potential uses of blockchain that could support monitoring or mitigating technologies of climate impacts, right? So they want to know. They want to know why do you need Web3 to do this? And the one answer, right, is what I mentioned at the beginning, right? So environmental accounting needs what Web3 has to offer, and that is this verifiability and interoperability. But an even stronger claim that I'm going to make on closing that I think we should think about and develop is that fiat is computationally incomplete. It's incomplete in a mathematical computational sense for modeling and therefore taking action to reduce and mitigate environmental externalities. What do I mean by that? I mean, fiat can add, fiat can subtract, right? If you have money A and money B, you put them together, you have money A plus B. That's not how environmental externalities work, right? So an example of this is land use. You have plot A, plot B. There's the value of plot A, value of plot B. You put them together, you have the value of plot A plus B is A plus B, right? But those plots of land might have very different capacities to support biodiversity. Land that is contiguous over a large section of undisturbed wilderness, for example, is much more valuable to the biosphere than land that's split up into a bunch of little patches, right? So that's what I mean by fiat is computationally incomplete to model environmental externalities, right? So you fundamentally can't reduce the health of an ecosystem to a price signal. And that disparity, right? The disparity between what's actually happening on the ground in these systems versus what is happening in our models of these systems that we are using to govern them matters. And when you try to do that with just fiat and you layer a Web 2 accounting system on top of that, what do? Well, at the end of the year, you try to figure out what were my impacts, and you produce a report that maybe you produce it at the end of the first quarter of the next year. That means you're working with data that's a year old, right? And so when we're making these transactions, and we need to track what those environmental impacts are in real time, or as close to real time as we possibly can. And you just can't do that with fiat by adding this accounting layer on top of it, but you can with Web3. You can do this with programmable money. You can make models, you can make those models more robust over time, and you can use them to track environmental impacts. And you can talk to scientists who are working on these models. When they come up with better models, you can implement them and show how those impacts flow through your entire economy. And so what we need to do to solve this problem, we need to do to solve these two problems that are sides of the same coin, we need to build those sorts of tools that are general enough to decarbonize the entire economy, and we need to apply them first in the industry that is the fastest moving in the world, that is going to be the quickest to adopt these tools. And that is how we decarbonize crypto and decarbonize the world. Thank you.
Awesome. Thank you so much, Alan. I'm sure you've got a lot of questions, but save them. Alan is going to be hanging out for the rest of the day. We'll have a couple of breaks and things, so if you have anything you want to dive into, don't worry, you're going to get the chance. We won't hold that back from you. We're going to dive straight into our next presenter. We're on a roll here. Please put your hands together for the wonderful Doug Miller. Doug is the Deputy Director at SEBA and the co-founder of Zero Labs. Doug.
I need the clicker. Alan. Thank you. Cheers. Good morning, everybody. It's a pleasure to be here today in Austin and from Washington, D.C. I guess I'm just waiting for the presentation to come up. But today I'll be talking about three things. First, kind of double-clicking on what Alan was talking about in terms of what are clean energy markets and how do they actually work. Secondly, I'll be diving into how does the blockchain sector set up to serve as a new source of clean energy demand? In other words, how can we position the crypto sector and blockchain sector to power more clean energy facilities around the world? And then lastly, what is the role of blockchain as a source of solutions in the clean energy sector, kind of providing some more context on the points that Alan brought up today. So first, to dive right in, let's do a little bit of a 101 on what clean energy markets are and why they're so important. Before doing that, I'll just briefly introduce the organization I'm here representing. So the Clean Energy Buyers Association and the Clean Energy Buyers Institute. It's a family of two organizations. We have a mission to achieve a 90% carbon-free U.S. electric grid by 2030. Extremely ambitious. And what this entails is not just bringing more wind and solar online, but also making sure we bring in battery storage and other sources of clean power so that no matter what time of day you turn on the switch, you know that you're sourcing your electricity with clean power. And we also represent the world's largest community of clean energy customers, companies who buy clean power and then companies who provide the solutions for clean power. So Alan talked a little bit about clean energy, and I just want to double down on this because this is something that can be quite complex, and I want to try to make it really clear for folks how these markets work. So right now, if you're a company and you power up your operations, you're using the standard grid mix. And in the standard grid mix, there's a whole bunch of generators that come from a whole bunch of different sources, whether it's coal, gas, nuclear, hydro, wind, solar, et cetera. And you don't really know what's powering your facility. And that's because our grid is like a big soup of electrons. And so essentially, with the status quo, were there no market for clean energy, if we just accepted the status quo, we'd have to depend on policy outcomes to move things faster. So luckily, about 15 or so years ago, we started creating these things called voluntary clean energy markets. And so what that does is it allows companies to take a proactive measure to buy clean power. But because we're dealing with an invisible product, how in the world do you actually do that? And it gets quite complex really quickly. So to create a clean energy market, what we have to do is we have to essentially tag all the clean energy facilities, like the solar, the wind, the hydro, all the non-polluting sources, put them in a database as it is today, and then every month say how much did each of those facilities produce, create a REC, a renewable energy certificate, like what Alan was talking about, that represents 1 megawatt hour of clean electricity. And then each of those facility owners of the clean energy facilities can sell those. Essentially becomes a new source of revenues. It makes clean energy more profitable than it otherwise would have been. And then there's a whole market of companies who buy these certificates to then say, ultimately, I'm 100% clean powered if their electricity use equals the number of certificates they have in their accounts. But as Alan was talking about earlier, the way this is all set up is a situation with walled gardens, systems that don't talk to one another. So you can probably see kind of where I'm going with this conversation. But at the end of the day, how this works is that let's say you're a particular company, this little blue person here, there was a wind facility that was tagged, there was a certain amount of megawatt hours that were confirmed it produced, a certain amount of then renewable energy certificates, and then this particular company bought them, and they know that even though there's this big soup, they can control what comes to their office, they bought a property right over the greenness of the electrons that went into the system, again, providing that incentive to help displace coal, gas, and other polluting sources from the grid. And so this is at the bones of how voluntary markets work, and it's the way that you can take a measure beyond, it's a way to vote with your dollars rather than just voting with your votes for having different outcomes on where our electric goods go. And so to date, there's pretty much there's been one standard set of things companies do to procure clean energy. Essentially, the way the global clean energy system is designed, the way I was just explaining it, it incentivizes annual clean energy purchases by companies. Essentially, household brand names you can think of, they buy clean energy once per year based on their annual energy use, based on where they're consuming electricity around the world. And essentially, they're incentivized to buy wind or solar once a year. And that's just how it is. But we at SEBA know that we need to do much more than just putting more wind and solar on to achieve a fully decarbonized grid. We need batteries. We need solar and wind, not just in places like Texas. Texas has been leading the way in a lot of ways in this front. We need it all across the grid. So we know that there's this notion of next generation procurement. And this is, you probably have seen some pieces from Alan and the Filecoin community about wanting to find ways to maximize the carbon impact of your decision making, so that you're not just dealing with this annual product that is not granular enough, wanting something a bit more granular. And so at SEBA, we realize that there's this issue where wind and solar is not being deployed consistently. We don't have enough growth in important technologies like battery storage because there's no market for it yet. There's no way to tag them in the way that I just explained. And there's no way to actually grab the real-time carbon data so that you know where you're buying clean energy actually has the biggest bang for the buck in terms of carbon mitigation. And so at the Clean Energy Buyers Institute, we have a new research initiative with leaders from across the space globally to solve two practical problems. How do we capture more types of data in these renewable energy certificates so that we can create more types of options for companies to move the grid in a certain direction in a more holistic way, not just more wind and solar? And then how do we make sure we have the right data so that we can actually fill in those new data fields on the certificates so we can make these new options possible? There's a lot of text here, but the main point is there are lots of things that companies want to do beyond the annual solar and wind purchase. For example, companies want to buy clean energy matching their actual time-based use of electricity. They want to, if they're consuming a certain amount of electricity right now at 11:25 Central, they want to buy clean energy at 11:25 Central. So that's one type of procurement option that's not standardized yet that we want to enable. Another is buying clean energy from the most carbon-intensive grids. For example, the biggest bang for the buck right now in the US, I believe, is the US Midwest and buying wind from the Midwest. So even if you're not located, say, in the Midwest, you might be somewhere else, that could be the biggest carbon bang for the buck. Similarly, you might want to buy more carbon-intensive products based on the time of day to send different demand signals so that we can power on solar or wind rather than a gas plant at a certain time. And companies are also trying to figure out how do they cover their supply chains, both upstream and downstream. How do they make sure the products they're powering their products and services with are clean? And how do they enable their consumers and users to source from clean energy? And so with this initiative, we just launched this. It's an open initiative, so anybody who's interested in participating to inform where this market should go, essentially informing the user stories we're developing for different types of clean energy customers, certainly welcome you to participate. We have our first workshop for clean energy buyers coming up later this month. So this is the end of the brief 101 on clean energy markets. So now let's go into what is the role of blockchain as a source of demand in the clean energy sector, before we then go into the solutions. So the crypto industry, most people know about it, or a lot of people know about it for just a couple of reasons, one of which is the energy consumption issue. I think it's really important to reframe this topic because everything we do in our world consumes energy. And the opportunity here is not to critique one source of energy use versus another, but to use it as a force for good to create those demand signals and buy more clean power, and pointing back to those images earlier, start to displace coal and gas and other polluting sources from the grid. And so there's a huge potential here, given the energy consumption of the crypto sector, to essentially become one of the largest types of buyers in the world, and to take a proactive stance and live up to a lot of the things the crypto and blockchain sector says that they're trying to do. This is an easy way to make have a positive impact on the globe. And so for those who aren't familiar with this, less than a year ago, was involved with launching the Crypto Climate Accord, which is an initiative that says, as an industry, the crypto and blockchain industry, let's develop new technologies, new solutions using decentralized technologies to decarbonize the entire sector. So let's make the crypto blockchain sector green and build some awesome new solutions to get there, along the lines of what Alan was talking about before. And provide a couple examples. The one that Alan was talking about in terms of the Filecoin Green is phenomenal. It's the leading showcase right now for enabling the individual parts of a network to procure clean energy and prove it. But what's exciting is that this is expanding quickly into other parts of the crypto sector. So we know that there are Bitcoin miners, for example, who are looking at pursuing a similar solution, but in their case, it's looking at Bitcoin mining pools. So it's a way for pool operators to either cover the energy use of their entire pool with clean energy, to say we're a green pool, or provide a service for those miners to actually procure it and prove it for their own needs, whether it's for ESG investors and so on. Also, previously, 2 separate blockchains covered their entire global energy use per year with clean power, the XRP Ledger and Energy Web Chain. And what I've just talked about is on the supply side of the market, those who actually generate the cryptocurrencies themselves. And then if you look at the demand side, there's actually a lot of interest from those who invest or hold crypto. So what's exciting is that there are various crypto wallets and exchanges that are looking at how do we either cover the historic energy use of our crypto holdings with an equivalent amount of clean energy, essentially to send that positive demand signal to the industry. And then those who are looking to automate clean energy purchases based on the estimated energy use of crypto transactions. So anytime you make a transaction, it triggers a clean energy purchase, you get the proof. So it's some really exciting stuff that's emerging. Now let's go into some examples before I wrap up and potentially have some time for questions. So when you think about the role of blockchain and decentralized technologies in the energy space and to promote new tools for clean energy procurement, essentially the problem that it's really tackling is that with these certificates, it's one product, and somebody needs to communicate to several parties that you, in fact, are the one who own that product, and that product came from a legitimate source. And right now, the way that information is tracked is across several organization systems that don't talk to one another. And so I think at the core of the value of blockchain-based solutions in the clean energy sector, it's solving these problems where we have multiple parties who all need to know the same information about one specific thing. In this case, the status of the ownership of a certificate. Because from there, you can create tools to embed this into any application. And when I think of, this might sound a bit simplistic, but when I think about, I'm often not talking with crypto folks like those in the room today. So when I think about blockchain-based solutions in the crypto sector, I think of an analogy of other things that we embed into apps. And I see blockchain and based solutions as just another layer in the technology stack of a clean energy application. For folks who are currently making transactions in the energy space, they're probably using Wi-Fi networks, Bluetooth to make the phone calls they're doing, HTTPS to run their websites, cloud storage to save components of their solution. And I see blockchain as one component that could be added to solutions to, again, verify the state of a given thing, whether that's a renewable energy certificate or something else in the clean energy space. So example one. So Energy Web is a leading global nonprofit. I used to work there before joining SIBA. And what they're focused on is creating digital identities for any energy customer and device. So that if it's essentially this notion of a single sign-on for you or me as a customer, or our electric vehicle, our battery, our solar panel, you name it. And the idea is then with one thumbprint or one digital passport, you can plug in as a customer into any any app or service on the grid, and then the grid system itself knows who you are, and it reconciles all these issues that today live in different systems that don't talk to one another. Another exciting example, and it's one I'm involved with as a co-founder, is Zero Labs. So what Zero Labs is doing is tackling some of these next generation procurement topics that I brought up earlier in terms of where clean energy markets are going, solving specifically for the challenges of small customers who don't currently have a pathway to buy clean energy because they're too small to matter. And then more specifically, companies that have a large user or customer base where all of those users or customers use very little electricity for the actual transactions or their use of an app, but in aggregate can become quite large. So what's interesting about what Zero Labs is doing is building tools where you can aggregate really, really small uses of electricity, make it in a size that's interesting to clean energy sellers, enable sellers to digitize their supplies, match, and then using blockchain deliver proof of the certificates having been made available and canceled in the respective tracking systems. So it's essentially a way that from that complicated schematic I showed earlier for the whole life cycle of these certificates, Zero Labs hides the solution hides that complexity from the consumer. They just simply get a proof that they bought a certificate that was real, and they can send this demand signal in the market. And I think what's ultimately really exciting too, as we think about the future of clean energy procurement, it starts to automate clean energy purchases into the background of our apps. You don't have to actually do anything other than just saying, yes, I want to participate. Another exciting solution in this space for blockchain-based tools is a group called FlexiDAO, a startup out of Europe. And what they're looking at is this notion of 24/7 time-matched clean energy, the point I brought up earlier. They're particularly working with corporations who say, as a corporation, some have a goal to say, I want to match the time of use electricity with a purchase of clean energy. And what they do is they use blockchain-based solutions to essentially show that there's been a reconciliation between the monthly data that become available for RECs and then the minute-by-minute energy use, where they can essentially use blockchain to show that all of these issues have been reconciled and delivered to the end corporate customer. The proof, because those companies want to be able to say that they're buying, they're buying clean energy 24/7, and this is a topic that big, very notable companies like Google and others are prioritizing. So it's a really interesting space, and they're also tackling a lot of practical data challenges for how do you get that granular data. There's going to be some more talks about this later, and this is a bit outside of the clean energy space, but it's you can think of it as a brother in the climate solution space compared to renewable energy certificates. There are groups looking at digitizing carbon offsets and carbon removal. Carbon offsets essentially are a way to erase the carbon emissions of an action you make, versus carbon removal is with removing carbon from the air as it is. And so carbon offsets are an existing space. They have a certificate system just like RECs. Carbon removal is a new space that isn't standardized yet, but it's exciting. And both of these markets very much can use all the same things I was talking about today in terms of creating digital representations of the certificates, canceling them so that you know that nobody else owns the same certificate. And then there's some really fun applications to create more demand in this space. The last example for now, and this is not a technology solution, but it's in terms of lots of times technologies, of course, follow guidance and standards. And so there's a lot of exciting work by groups like RMI, where I also used to work, and they are looking at how do we redesign carbon tracking of our supply chains. Right now, if you're a company, you're trying to figure out what's the carbon impact of your supply chain, it is a mess. How do you know you bought steel from one company, rubber from another company, software from another company? How in the world are you supposed to come up with the carbon emissions from the top down? The idea here is to start tracking from the ground up, kind of in the same way that EnergyWeb is looking at the energy system, capturing the users from the ground up, so that essentially over time you can build it up and you can see exactly which components of the system consume or pollute a certain amount of carbon, so that it's then easier for you to make different choices and reduce the carbon across your supply chain. And what's interesting here is that this is another great example of using blockchain in this space. You have that stamp associated with each part of the life cycle of products as they go from the original form up to its end use. It hopefully will help make it really easy to figure out how much carbon you're responsible for and can cover either through clean energy and/or offsets and carbon removal. So with that, thank you very much. Anybody who's keen to engage in the first initiative I talked about in terms of shaping the future of clean energy procurement and the standards and where the rec goes, because it is going to change to a certain extent, please reach out. We'd love to have a conversation and get you involved in these workshops we have coming. And then also keep an eye out on some of the solutions I was talking about. There's some really exciting work. And thanks again for having me.
Well, that's embarrassing. Okay, so if you are watching the live stream and you've got questions for our speakers, then you can tweet at Filecoin Green or use the hashtag Filecoin Green, and our wonderful social elves will find your speaker, ask them the question, and get back to you online with an answer. We're going to do some furniture shuggling for the moment, so hang tight, have a wee chat with your neighbour, say hello, introduce yourself. We'll be back in a couple of minutes to start the next panel. Thanks.
Sold my dead bird to a blind kid? Lloyd, what do you... Petey didn't even have a head. Harry, I took care of it.
All right, thank you so much, everyone. If you want to grab your seats again. Okay. Moving on to our next session. We are kicking off with a big panel of kind of all stars from the sustainability space. I'm going to hand you over to our amazing moderator, if they're ready. Are we ready? Perfect. Okay, please put your hands together for Michael Casey from CoinDesk.
I don't know how this works. Is it on? Yes. Great. All right. So welcome, everybody. Happy to be here. I'm I'm Michael Casey. I'm the Chief Content Officer at CoinDesk. Just to give a little bit of background, I sort of have been engaged in the sustainable blockchain space for a while, though, because before joining CoinDesk, I was at MIT at the Digital Currency Initiative, where I worked on some solar initiatives in relation to funding distributed solar projects in Puerto Rico and elsewhere. So it's always been a passion of mine. So I'm very happy. Thank you, Mark, for dragging me back into this space. Also, just as a plug, the Money Reimagined podcast that I do weekly with Sheila Warren, formerly of the World Economic Forum, now of the Council for Crypto Innovation. We founded a body called the Crypto Sustainability Impact Accelerator, or CSIR, at the World Economic Forum to really sort of bring multi-stakeholder arrangements together to work on the kinds of solutions that are being discussed here today. So that's my own little pitch. Follow up on those things. It's all in a good cause. Why don't we just go down the line, you guys? Harrison, introduce yourself. Tell everybody what you're all about.
Sure. Yeah. Good morning, everyone. Harrison at Coinbase. I do a lot of sort of impact stuff and venture stuff.
Adam?
I'm Adam Wiedemann. I'm with Microsoft's blockchain group. I've only started there recently, but the group has been for a long time building out the blockchain infrastructure to start putting more data on chain. And so conversations like this are ones that we are really interested in.
Hi all, I'm Alex de Vries. I'm the founder of Digiconomist, and you probably know it from the Bitcoin Energy Consumption Index.
Steve?
God, I'm John. So this is the first meeting of the Alan Ransel, Doug Miller fan club, I think. And I'm very pleased to be here. I'm Stephen Haft, and I work at Consensus.
All right, there you go. It is an all-star panel, guys. Alrighty, so I just thought maybe we just started off on some high-level stuff, and then we can drill down into use cases and the like. But Alan pointed out the EO, the Biden EO, and I thought it was just like a nice way to start here, right? There seems to be, and I was very pleased to see it, an acknowledgement that this isn't just a threat, that there is actually something really constructive that can be done with blockchain technology. So I suppose my challenge to all of you was like, okay, so the administration wants solutions that are climate friendly. What do we tell them? Like, what is the message to the world right now about how blockchain can be constructive rather than this sort of horrible threat that everyone seems to talk about? Why don't you give a shot at that quickly, Harrison?
Yeah. You said sort of something really interesting in our green room, as it were, that we can't just lead with sticks, we have to lead with carrots. And I think that there's an opportunity here to bring carbon on-chain, which is a lot of the work that I focus on, to sort of create a secondary market, and instead of being punitive, more of like a rewarding system. And so creating incentivizing more clean energy or different sequestration methods or that sort of thing.
Yeah, great.
No, I certainly agree with all of that. Additionally, part of the challenge is how do we bring about transparency? And although that seems really easy, like, oh, well, we'll just put all the information on the blockchain. As it turns out, there's a lot of company secrets that they don't want on the blockchain, specifically around their manufacturing processes. And so how do we both be transparent as well as preserve confidentiality? There are absolutely ways to do that, but they are non-trivial. And so a lot of our focus moving forward in this next year is how we make that a reality.
Thoughts, Alex?
Yeah, I think that when we're talking about blockchain, we need to keep in mind that we're not talking about the Bitcoin blockchain necessarily. That's what a lot of people think about when we mention the word blockchain. They all think, hey, Bitcoin and Bitcoin energy intensive, bad. So how can we possibly use that for doing something good for the climate? But the thing is, most blockchain platforms don't run on the same energy-intensive mining algorithm that Bitcoin is using, so it's not fair and representative for the rest of the space. So I think that is a good one to start with. And let's keep in mind that we have more sustainable ways to do blockchain than Bitcoin is doing, and we can leverage that to do something good for the world.
Well said.
Nicely done. It seems to me that the challenge is
not just that the technology does what it can do, because we in this room are not the technology, we are the stewards of a technology. And so the question is whether we as stewards are doing our job to help administer this ecosystem that we would like to define as a trust layer for the planet. Are we doing it in a trustworthy way? And it seems to me that we need to aspire to live up to our obligations in the space, and to do that, you know, I like the thought of going back to fundamentals. We're very much Ethereum focused at consensus, as I think everyone in the room knows, and we share roots there. And but in the root sharing of it all, in 2015, when Ethereum was created, that very same year, that very same summer, the Paris Accords were created. And I believe, and you're going to accuse me of over-intellectualizing this, but I don't think so. I think roots are important. Much like the French Revolution and the American Revolution shared ideas that came from Locke and Rousseau, I think we share ideas of transparency and the end of financial duplicity and things. Very much our technology and the Paris Accord share those ideas. And so I would say that the charge is for us as stewards to restore an alignment that I think has genuineness from those early days of blockchain to restore going forward that alignment with the ideals of the Paris Accords, and take that seriously as stewards.
Great. I've just changed my structure of where this conversation is going to go. Thank you very much, Steve. I was going to do softballs to you all and get you a chance to say, here's what Coinbase is doing, here's what Microsoft is doing, et cetera, et cetera. But no, we're going to do the how do we be good stewards conversation. I think this is an excellent place to start, because it feeds into some of the stuff that you talk about, Alex, like what is the right blockchain, how do we deal with energy consumption, how do we get the right balance, right, between what is this doing good for the world, the ultimate solutions, and then the fact that, you know, there's a lot about our space that isn't necessarily driving society in that right direction, right? So it's just a call to action, you know. So yeah, Harrison, I mean, you guys, you've got a broad portfolio of ventures. You're one of the biggest players in crypto. You, in some respects, are you have a moral obligation to set the standard here. You're Coinbase, right? So how do you take that message, and how does it feed into how you go about where you invest, what you do as a company, and just as importantly, what you signal to the outside world as your responsibilities and obligations?
That's a fantastic question. Our climate practice is pretty nascent right now, which is me and maybe 2 other people, depending on how you count them.
Might need to be bigger.
It might be 3 or it might be 1.
Depending on how we spend our days. So at least from my perspective, it's all about like what are the highest leverage things that we can do. And there's so much excellent work being done in the space. I mean, I'm repping Toucan shirt, you know, and like they're bringing carbon on chain, and one of the foremost players there. And I think a lot of our focus right now is just empowering other people to, as you said, like become stewards and create the right incentive mechanisms to create carrots, not sticks. And I hope that with the executive order, like we'll have more of that. It won't just all be completely punitive. And I keep coming back to that because, you know, I got my start in blockchain analytics, and I'm kind of afraid of that. But you know, it's yet to be seen.
Well, you can be sure that the administration, the regulator, is going to demand, right, that there is standards that are being set here. It's not just going to take, you know, at blind faith these, you know, utopian promises, right? Yeah. So I think that's a really, it's almost like it's keeping us honest, right, which I think is important. Adam, yes, I mean, again, you guys have got, how do you think about this from what you invest in and what projects you develop?
Sure. So, I mean, this is something that Microsoft is very committed to. We have a $1 billion fund specifically to invest in sustainable practices for carbon capture and carbon reduction. And so we are very committed to this, and I love the urgency in this room around it, because that's uncommon, and I feel like I found my tribe. But independent of what blockchain you're running on, as Alan brought up, those chains run on something. And if I were to put my Microsoft glasses on, we would hope that it would run on Azure. And to that end, we've been making strong progress towards our goal of being completely running off of renewable energy in all of our data centers by 2025. That's only 3 years away. So there's a lot of work that we've got to do to get there. But we are aggressively moving towards it. And so that's the first part. How do we make what we're doing today in crypto more sustainable? But beyond that, how do we really take a data-backed approach to tackling Scope 3 emissions? Right? Scope 3 emissions, which is, for those who don't know, that's everything upstream and downstream of the thing that you're actually producing, right? And so, are we responsible for devices and energy uses once it's in a consumer's hand and out of ours? Well, yes, we are. But the only way that we can take a practical approach to that is by having some very mature data practices with respect to understanding what the actual impacts are of the decisions that we make far upstream, right? And knowing those now so that we're able to predict and appropriately make decisions that have a benefit downstream.
Okay, I really want to get to Scope 3 emissions because I think it's an interesting, not only just an important challenge, but I think it also, in some respects, speaks to some of the stuff that Alan was talking about, the sort of the sheer impossibility of measuring these ecosystems with these outdated tools, right? So that once you talk about the different stages of a supply chain, the world becomes incredibly complex. And so we'll get to that. But let's stick with this for the moment. Let's get to the blockchain, which blockchain, what type of consensus algorithm conversation, because Alex, that's something that you've brought a lot of attention to. Would you've been a very outspoken critic of Bitcoin and its energy consumption. What should the community be doing in response to that? How do we deal with that? I mean, I don't personally think Bitcoin is going to go away anywhere. And in fact, there's an argument to say that if we were to shut it down in one place, it would simply move to an even dirtier place, right? And you mentioned Kazakhstan, that may be an example of that, right? So how do we deal with this, right? And with this conversation of carrots versus sticks, what's your take on, let's start with proof of work and then we'll bring Steve in to talk a little bit about Ethereum and its migration. How do we deal with the Bitcoin problem as you see it? And I mean, some people would argue it's not a problem, but you can take that from there.
Yeah, it's a very complex matter because ultimately in Bitcoin we're talking about the energy-intensive mining process, and the thing there is that that's something you can participate in anywhere in the world. So we saw that previously a lot of that activity was taking place in China. China last year said, okay, we don't want this in our country anymore, and these miners are responsible for the revival of some of these idle coal mines that we have. So we're done with it. We're going to kick it out. And then the next thing we see happen is that a lot of those miners are indeed migrating to places like Kazakhstan, but also here in the US. And as a result of that, we even see the carbon intensity of the network going up even further. So you can say, well, banning crypto mining in one place is probably not the right solution, but then you can really wonder what is the right solution. And it's really tough to come up with an ultimate answer because of what I just said. It's something that you can ultimately do in every household. Everyone can put a Bitcoin mining device in their own house. And I wish you good luck with cracking down on that if you're a government. Are we going to raid everyone's homes? I don't think so. So it's really tough, and I think one of the first steps that we need to take is we have a lot of approaches to measure the carbon impacts of these systems, and I specialize in that, but a lot of people don't realize that in order to hold people accountable, we also need to have carbon accounting standards, and we don't even have those at the moment. There is no carbon accounting standard for this space, and we just heard Scope 3 emissions, but what kind of emissions are we supposed to allocate to whom? That's still a question that is unanswered. So I think a logical next step would be to start developing these frameworks and make sure that we can hold people accountable, and yeah, we should be taking it from there.
Another shameless plug, that was actually the motivation behind CISA that I founded the WEF, thinking that we do need to form these standards, right? And we need everybody at the table. It just can't be the crypto community. You've got to have energy companies and everybody else. And so I think that's a really important point. Like this base understanding about what we're actually measuring and what we're taking on. But let's stick with this, Steve. You know, as a member of the C-suite of Ethereum Inc. Sorry, that's a joke. Consensus. You know, obviously the migration to proof of stake is a critical part of I think, you know, the Ethereum community's efforts to
I'll answer it. I'll answer
yeah,
it
go
before
ahead.
you ask it.
Okay, go ahead.
The answer is it's not enough.
Okay.
And that's the most important point I can urge my colleagues who have any relationship. Filecoin has a wonderful relationship to the Ethereum community, is that proof of stake isn't enough. I talk to my colleagues on the engineering side, and they say, they speak as engineers, well, we've fucking solved it, right? I mean, what else do you want?
Right, yeah.
And in the carrot and stick of it all, we've just heard from the stick, because as close to the stick as exists in our space is Digiconomy.
It is.
and he is the measure. And now this UCL thing has just come up, which is interesting. And we've taken the time to rerun those UCL numbers, and they're interesting numbers. I would say, I'd say this. Number one, proof of stake is not enough, it's just the beginning. Number two, we need to take pages from each other's books. I take a page from the Microsoft book. I think Brad and Lucas deserve a tremendous amount of credit, and I do think it actually probably starts with Bill Gates, who, for all the goodies he has in the world, we can actually give him a little more credit even than that, which is to say, I think the leadership to declare Microsoft that we are not just going to clean up our current footprint, but we are going to clean up our historical footprint, I think is a movement that I think should be credited probably as, to some degree, starting at Microsoft, and needs to permeate everywhere, including the crypto community. So proof of stake is just the beginning. I think we have to look at what we've wrought and take responsibility for it as, quote, stewards, and address it. As a company, we're going about it in a variety of ways. We have the full intention, and I expect we will achieve it, of operating on a carbon zero basis starting this year, or carbon neutral space is the best we can achieve, I think, starting this year. But over time, especially thanks to proof of stake, I think we can get there. We've run the UCL numbers. Interestingly, I know that was a sort of blip in the press. I think they actually proved 99.5, that we're going to get to 99.5 if we use their numbers, which is great, but that's going to leave 0.5% of friggin' Netherlands. So we still have something to do on a go-forward basis. We are working with the UNFCCC, and weirdly enough, the Paris Accords are based in Bonn. Welcome to the New World. And we work very closely with them in a variety of areas where we think blockchain can make a difference. One is in greening the green bond space. Green bonds is a source of cheap financing, was $500 billion in financing last year, $300 billion the year before. It's not greening anything. So our goal is to work on, as you know, we do a lot of work in the sort of fintech space. One of the fintech projects is going to be to work to see what we can do to help green the green bond space. Another project that we're working on is we have built a carbon credits on blockchain trading system. Toucan was mentioned. Toucan is a terrific organization. I can say that Toucan got its first money from the Blockchain Social Impact Coalition, which Consensus helped to launch. I was actually on the hackathon committee that gave Raphael his first money. Toucan became Toucan. It's great. So you figured out how to move what is a data-based financial asset, a carbon credit, and move it over onto our ledgering system, which is a great beginning. We're looking to sort of now automate the trading side of all of that, and thirdly, we're looking to play our part as Ethereum Inc. Nice joke, but the truth is Joe Lubin, who I have the privilege to work with, sees his role both in a business and a movement of sorts, and obviously I take that pretty seriously. I think we have the opportunity to go from laggards to leaders in this space. Precisely this year, because you can't clean other people's houses till you cleaned up your own, and I think after POS, we have an opportunity to be the leaders for the first time. We need to be.
You're doing a good job of, again, making me rethink my direction of this narrative here every time Steve is like,
and you're freaking MIT, man. I'm barely got out of high school.
That's right. Can't keep to the script. And the thing that suddenly got my attention there was you referenced Microsoft and its own corporate commitment, right? And if Paul Brody, who was going to be here, were here, he would be jumping up about this, right? Because Paul talks about how much treasury money is sitting at responsible companies like Microsoft and Apple and others that is absolutely committed to these zero carbon targets, right? They don't know whether to put it. They don't know how to put it. They're desperate to find assets that can return this need. Good. Well, let's hear from you at the end. We'll get some questions. That'd be great. And so and I think one of the things that Paul has been interested in exploring is how do we take the flywheel effect of speculation and energy that really is DeFi and crypto, right? It's about making money, and how do you sort of align that with this huge investment possibility? Because we need trillions of dollars of investment to get the world into a safe space. So thoughts on that? Like, how do we take crypto, what crypto is really good at, a bunch of things, but what its first use case is speculation, right? It's done a really good job of driving speculation. How do we align that with investing in what we need as a planet? Go for it, yeah.
I think that's a great question also. You have a knack for asking tough, good questions. I'm talking to a couple folks who are more on the Web 2 side of things, and when you bring the carbon markets on chain, of course there's upgrades in market efficiency and that kind of thing. And a lot of the solutions are around how do you sort of almost leverage the current price or the future price of carbon to then fund the carbon initiative to go get the credit and that kind of thing. And that's something that I'm still kind of sitting with because, as you said, sort of on the speculative angle, I mean, that's effectively just trading carbon futures leveraged. And who loses out on that? So that's definitely something that we need to think about a lot more as an industry. I mean, I think there's too much speculation in DeFi, I guess. Mm-hmm.
Well, I suppose maybe to you, Adam, how do we make real assets on chain investable, right? As opposed to speculating on carbon credits and the like. Like the idea that we'll take, and we saw some presentations before about provable renewable energy and the like, right? Some of the work that you guys have been looking into, how do we take these things and make them investable?
Ooh, that's a hard one. That's I don't have a great answer for that. I can tell you some of the things that we are investing in that are real. Things like investing in hydrogen backup for all of our data centers, right? And that's a thing that, from an investment standpoint, if you were looking for the biggest bang for your buck early, that one won't do it by itself. It requires a large investment to get to the scale where that can be sustainable long term. So it's things of that nature. We're invested in in low-carbon avgas. We're invested in carbon capture technologies, right? All of these things need to come together in order to bring us to a lower carbon future, and all of them need to be jump-started. And so that's something that we are actively investing in, and none of this is secret. This is all on our website. But yeah, those are things that we need participation from the community at large as well to help push them forward.
I mean, everything needs to come together aspect here, right? You can do all very well to be focusing on making proof, bringing Ethereum into proof of stake, for example, but in the meantime, what's happening in the rest of the world and how do we pull it all together? Steve, yeah.
If I may, I think Doug pointed us to something very much, as he does, in the right direction, which is real-time monitoring of energy use. It is a perfect, I mean, even people who know just a little bit about the blockchain, and it's, ask Sheila knows well, the relationship, and she knows a lot about it, the relationship of blockchain to supply chain. Anybody who knows anything about blockchain understands that we could be the architect of real-time data around energy use. We don't have to create the ESG movement. The ESG movement is here. It may not be everything we want it to be, but it's already leagues ahead of where it was a few years ago. So if you combine the current momentum toward ESG with real-time data, not the once a year that Alan was talking about, the once a year offsetting, but if it's done real time, you've really transformed the place in a huge way that takes us way further toward 1.5 than we are now. So I'd say if I were going to focus investment in one area, it would be on real-time verification and reporting of energy use using Web3, and then leave the forces of business and, it's interesting, the Coinbase answer was, could we productize this? Well, that's the right answer, because everybody needs to do the thing they do to contribute. And if Coinbase could productize it, and Consensus could build some infrastructure, and Digiconomist can keep us honest, and Microsoft can show the corporate world what a serious commitment looks like, we're each doing the thing we do to get us there, and I think we can make a big difference when to meeting again next year and sort of looking at what we accomplished in 22.
Is your chance?
Yeah, I want to get back to something I heard previously. Like, a key question is, how do we make something real on top of a blockchain? And I previously worked at a audit and consulting company, and a lot of the initiative I saw coming by was like, can we do something like carbon credits on top of a blockchain? That's something I used to hear a lot. And well, the reason why that's being thought about is in the context of carbon offsets. Carbon offsets are unfortunately quite often counted more than once, once by the seller, once by the buyer. And if you have this double counting going on, people sometimes think, hey, double spending, that's something I heard in the context of blockchain. So maybe that can help out. But one of the key challenges we saw there was that, okay, you can do carbon credits on top of a blockchain, but ultimately, who's going to check that trees are being planted? Like, who's going to tell the blockchain there are that many trees being planted in that area? You're going to have to rely on some kind of trusted source of input for that, which, by the way, as auditors, we thought that was great because that was our core business. But I think this is a very key question you should be thinking about, and it can even make you wonder, like, okay, what is still the added value of a blockchain if we're going to rely on auditors? Yeah, that's another good segue, because it's often referred to as the last mile problem, or the garbage in, garbage out problem. The on-chain data is trustworthy, but how do you bring off-chain data in? But there's a lot of work going on in this space, right? There's a lot of trusted computing stuff. There's like all sorts of satellite imaging solutions. There's all sorts of things, and I do think personally that, yeah, props to your prior profession. Auditors are going to play a key role in this, but they've just got to become up to date
on what is needed by a decentralized distributed system. But maybe to you, Adam, because you are looking at things like Scope 3 emissions and the like, and measuring supply chain impacts. How do you deal with the problem that Alex was referring to there? Of okay, we got a really good double spend check here, but how do we know that the data is to be trusted?
That is the hardest problem to solve, right? I can't say that we have a solution for it yet, but what I'm hoping is that by having actual transparency to it, then we can bring the liability for that audit higher up in the chain, up to a place where A, they can afford to have those audits, but also they can perform those audits in a manner where the liability for the liability for negative impacts of those audits, right, aren't actually masked by the folks who are paying for the audit. So, generally speaking, that's what we hope, but it is not an easy problem at all.
Any thoughts on this, Harrison? I mean, I was struck by, in a completely different context, the fact that the hacker of the DAO was caught 6 years later, right? And one of the messages, Laura Shin, I don't know if you've read the book, but I'm not sure that Joe is necessarily advising people to read her book, Steve, but
He did in Denver.
He did? Oh, good for him. Good for him. It is a great book. But she the work that she did afterwards just demonstrated once again that ultimately on the blockchain there's nowhere to hide. And to me that strikes me as possibly an answer to this problem, right? Because you will get caught eventually. There is a transparency and a traceability that makes it harder at least to hide. So I don't know if you've thought through any of that and how you go about what your strategy is with regards to the data problem.
What I keep coming back to, and we've talked about sort of like verification, like how do you make sure that the tree's been planted and haven't been cut down once they have been planted. But the thing that I keep coming back to is that so many of these solutions are effectively trading on the future price of carbon to finance the current sort of reforestation or afforestation project. And in some respects, I mean, blockchain is magic internet money, and so they could just fork Ethereum and after the DAO hack, but you can't do that with the climate. So, it's an incredibly hard problem. No thoughts.
Yeah, but one thought is satellites, of course. I mean, if you choose in 1962 could see a single missile on the Cuban island, then satellites today can count trees, and it's just a matter of connecting to the data. I think I could be incredibly naive. You're all way ahead of me in like science class, but I have to believe this is possible.
Well, the organic industry had a similar problem. How do you validate that something was grown organically? And what they ended up doing was exactly what Michael was alluding to, where with enough data, you can prove it. And so essentially, rather than relying on audits of the field of all time to make sure that there's no chemicals there that shouldn't be there, which there are audits, the majority of the data comes from how much water was applied to those plants and what was the amount of produce that came out, right? And with fertilizers that shouldn't be there, you can see how those things don't add up, right? And that is absolutely going to be true in our industries as well, right? With enough data, we should be able to correlate whether people are actually following these practices or not.
Yeah, it's that whole sort of almost ecosystem-wide big data approach to things that sort of, if we're focused on the end point, it can be gained, right? But once you've got a bigger picture, it becomes much harder to hide. So I think we open up to questions. Is that the plan here, Angie? What's our ghost toilet?
Yeah, we've got a little bit of time if you're 10 minutes.
10 minutes, yeah. I think we're wrapping up in 10 minutes, right? So,
Thanks, Pete.
You wanted to offer up some idea, yeah.
Quick question. I grew up in Austin, grew up in the oil and gas family. I'm one of the few oil and gas people that believes in climate change. So 100% believe in sustainability. I'm one of the founders of Pump Check Power. We are a power provider here in the ERCOT market. We recently just spun out a company called Crypto Power, the first and only power provider powering the blockchain. Outside of what the blockchain does stabilizing the ERCOT grid, a question I have to you guys is of how you view sustainability. I just helped a mining group basically build a mining facility at a natural gas plant. They are essentially taking the CO2 produced from that gas plant and recycling it to cool their operations. So I think from a standpoint of, I love green energy. I totally believe solar, battery, wind in the right markets, nuclear long term. But our approach, my question is, in terms of not demonizing fossil fuels, how can large operators look at natural gas or some type of fossil fuel situations and approach them with sustainability solutions?
Anybody want to take that?
I'm not smart enough to come up with a constructive answer.
Wildly unqualified.
The thing is, when we look at Bitcoin miners and there's so many different examples of how they're using energy, and one of those examples is the one popular one recently is they've been using gas that would otherwise be flared, and they're saying, okay, this is good for the environment, we're reducing emissions that way. Well, that's certainly not true, because you're still combusting the gas to generate electricity, so ultimately the efficiency of that should be more or less the same. But you can still make the argument that, well, in any case, whether we're going to flare it or we're going to combust it for generating electricity for Bitcoin mining, at least the impact is the same, how we're not worsening any impact. And you can actually think of that as a great argument, but the only issue is that we're also seeing a lot of initiatives right now to just completely prohibit routine flaring. There is a zero routine flaring initiative hoping to end flaring altogether by 2030. New Mexico recently decided just last year to prohibit flaring as of 2026. So companies are going to be required to capture the gas instead of flaring it. And if you're capturing it, you can also use it to displace some kind of other fossil fuel source. So in that case, you're not making things worse, but you could have used that captured gas to make things better. So it's really difficult to there are so many different examples, and this is one where you can make that argument. Okay, at least it does no harm, but if you look a bit further, then it still doesn't look too great.
If I can go rogue for a second, Doug is still in the room. Green hash rate solution. Can you just take 1 minute and describe what some Bitcoin folks are doing around what they call the green hash rate solution?
Sure. Can you hear me okay?
He's still got a mic.
Yeah. Oh, okay.
Make sure he gives it back. Hey, Paige, get it back from him before he goes.
So, essentially the idea is to help Bitcoin miners power themselves with renewable energy certificates, and then use that as a way to establish a green credential for themselves as a miner. So the miner can say, I am renewably powered, I should get this credential that's assigned to me, and then if you look at a Bitcoin mining pool, you can say, okay, what proportion of the miners in this pool have this credential assigned to them? And it could be that the entire pool is green, in which case you could say, all Bitcoin mined from this pool are green powered, and maybe you attract ESG investors, et cetera. Or it could just be individual miners, and they just want to show the proportion of that pool that's verified green, where what that then means is if you're buying clean power, the scope 2 carbon emissions, the electricity use is 0 for those miners. So they've gone from whatever the grid mix is to 0, and that's the carbon mitigation.
Which is a carrot and a stick. It's a carrot because I get to say I meet proof of green. It's a stick because I'm not going to buy or interact with coins that don't get the proof of green stamp. So it works on both levels.
The one thing to add to it too is why it's so exciting to look at crypto solutions for this is the whole mantra, of course, is verify, don't trust. Right now, the way the sector works is companies say, I'm 100% clean powered, and it's in my books, but you can't see my books. This is a way to use the space to actually confirm they are 100% covered, we're good to go, and then it actually verifies it. It's not just taking somebody's word for it.
So I'm just going to again use my moderator's prerogative here and just to say a couple of comments because I've thought and written quite a bit about this. I think the gas flaring thing is you're absolutely right. There's really no net gain, you're still ultimately still producing that gas. So the question is, how do we actually make net renewable additional energy solutions become attractive to Bitcoin miners, right? And that takes investment, and we know that solar isn't going to be as efficient as some of these things. But it doesn't mean that there isn't a math model out there that could make this work if there were to be, various other incentives. And so grid managers and other policy managers in energy, I think, have a real opportunity here. And Texas has done some interesting things. I'm not sure they've gotten it quite right given the problems they had a year ago, but there is some really interesting models, right, where Bitcoin miners are paid to turn off their mines when there is a spike in energy. So the management of the duck curve problem and all these things, the role that Bitcoin miners could play in all that, to be partners with local energy producers and think about this from this ecosystem perspective, right? This is about all the different pieces coming together rather than, I think these pools being provably green is great, Doug, but there's also the other side of it. It's like, how do we actually work together collectively? Because Bitcoin isn't going away, right? So taking it out of Kazakhstan, incentivizing it into these models, whether it's, local small hydro farms or wind farms or whatever it is, there's the capacity now to actually earn money in the most remote places. There's business opportunities that come with that, with Bitcoin, and there's models that can be built around it. So I think there's a higher level conversation that needs to happen rather than just the technicals. Amanda, you had your hand up.
Oh, yeah. I guess before Ethereum 2.0 comes in place, before Ethereum 2 comes in place, what are your thoughts on other ways we can make NFTs more sustainable? Is it carbon offsetting? Is that enough? Other thoughts on that?
Yeah, we haven't mentioned NFTs.
I run MetaGood, which has on-chain Monkey. We are all on-chain in a single Ethereum transaction, which is slightly better for the environment. We're still running on ETH, so we're trying to think of, as we work with other collections, what else can we be doing to be more sustainable as an NFT collection?
Yeah. Maybe.
In 1 minute. The thing with NFTs is that they're an application and you have a choice where you want to build that application. So you can either run it on Ethereum or you can run it on some other platform that's already running on proof of stake, like Ethereum is planning to do. And even if you're building on Ethereum, you can be like, okay, they're going to switch to proof of stake pretty soon. So instead of trying to avoid Ethereum, maybe we should, for the well-being, try to do carbon offsetting, at least if Ethereum really, they do have to succeed in making that change to proof of stake happen, but that could be a somewhat intermediate solution for the coming months. And then there's also an option to use layer 2 solutions. There's Polygon, which still works together with Ethereum, so the carbon footprint is still a thing, but less of an issue than it is if you're running on Ethereum directly. So there's a choice you can make there.
Steve, final word. We've got the countdown clock.
Oh, great. Yeah, no, just one quick thing for you specifically, Amanda, that when we built Palm, launched the Palm NFT blockchain, first of all, it was built on IBFT. It's a conversation we can have, but a pretty clean chain, the Palm network. But we actually, I think of Coinbase as being a sort of first cousin to Andreessen. And Andreessen has a project called Patch. And we integrated Palm with Patch, so we're belt and suspenders. We not only work on a clean chain, but we offset through Patch.
We're exploring that too.
Credit to AH.
Okay, on that note, I think
you.
we've run out of time. Thank you very much for this tremendous panel. Round of applause. Okay.
Awesome. Thank you so much, everybody. Thank you so much to Michael for being an amazing moderator as well. And a quick plug for one of our talks later. We were talking about verification and kind of figuring out how many trees are planted. Well, the fabulous folks at GainForest are solving that problem, and they will be talking later this afternoon. So there you go, little segue. Yeah.
Fantastic. I was one of the judges of that hack in 2000. That was the one that
Oh, amazing. Yeah.
GainForest is still going.
They're still going. There you go. Okay, we're going to take a quick break. So grab some snacks and drinks and things, and we'll meet you back here in a little bit. Thank you.
Hi, everyone. The break is over, so I would like everyone to come back to our seats. Yes, that'd be great. We have a jam-packed schedule, so if everybody could make their way to their seats now. Yes. Hi, everyone. We're getting back to our seats now. Okay. Wrapping everyone up. If everyone could get back to their seats, that would be great. Hi, everyone. My name is Ori Ayodele, and I am the newest member of the Filecoin Green team. So I am the Filecoin Green program administrator. So nice to meet all of you, and I'll be working with all of you guys in the near future. And I wanted to present Olia Erzak, and she is the CEO, co-founder of Frost Methane, and she will be talking about offsets and how they're a critical, complex tool.
Excellent. Hi, everyone. So with all of the really great things we heard about procuring clean electricity, you might be wondering, why would you want an offset, right? So I think a lot of you run data centers, and so you may have poured some concrete for your data center, and in your area, there may or may not be any like zero emissions concrete available. You may not be able to pressure your upstream suppliers for your computers, right? You don't know what electricity they were made in. So there's kind of a whole bunch of embodied carbon, which is not electricity related, where offsets might be a pretty good fit, right? So I think everybody here knows that offsets is when you have some part of your footprint that you don't control, but there's somebody else that can reduce some greenhouse gas emissions in some other area, sometimes of the world, sometimes in a completely different sector, and they would not do that unless there was money that came from you to sponsor that. And so that's where offsets are really nice. And the reason that I'm familiar with them is that I worked at Google, which was one of the first places of the large tech companies to go carbon neutral, so they've thought a lot about offsets. And also I run this company which mitigates methane, and what started the entire thing is these crazy methane vents in Siberia that formed hills and exploded. And it's like, cool, well, if you want to mitigate that source of methane, like what are your choices as like somebody that wants to do this project, right? And the beautiful thing about carbon markets is that you can develop a methodology in order for this kind of stuff to count and stack up against all the other ways in which you can mitigate climate change. So that kind of led me to diving pretty deep into what's the infrastructure of carbon markets. Okay, so everybody, obviously there's some gaming, there's things to be improved in the carbon markets, but the reason that they're worth fighting for is that you've got this beautiful, elegant situation where you've got thousands of entrepreneurs anywhere in the world that can compete for who can mitigate climate change the cheapest. And I feel extremely strongly about the cheapest because the world has other competing priorities. And the less we spend on that, the more there is for the other things, and the more likely it is to pass politically. So I think that that's the kind of one of the best global ways of taking this into account, taking externalities into account in the economy. Okay, so real quick, why I think it's great, the cost, which I mentioned before, innovation. So when you find this weird methane source in the Arctic, right, you can go and have a methodology and get paid and scale and stack up against all the other ways of doing that, right? Your alternatives in the absence of that is to convince a government to do this or start a nonprofit for every type of thing. And then it's to some extent, how well are you advertising as opposed to how low cost, high quality is this thing? It's kind of mostly global. There's some really low cost ways of mitigating carbon in the developing world. And we don't want it to go the way of Europe of hey, let's shave all of our trees, right? Develop and then replant some of them if we still have the native species left. Some amount of fairness, right? So there's countries that are responsible for the carbon that exists in the atmosphere right now, and those are typically the countries paying for this to happen somewhere else. Better data, there's a whole bunch of emissions that are not currently measured, right? So methane, really just recently started getting measured, and we're still being surprised, right? You see sometimes these large step functions in, turns out rice produces a whole lot of methane, right? So sometimes when these methodologies, when you try to mitigate something, you measure something that maybe wasn't previously measured. And of course, externalities. So common criticism, right? Gamings, right? Was that tree actually going to get cut down? So we'll talk about that later. Overhead, the cost of validation. So who does the project developer get the money, or do the people validating and the brokers get the money? And a lot of folks say, well, why should Google or other large corporations be offsetting rather than reducing their emissions? And it turns out that sometimes you just don't have control over your supply chain. All right, so if some of you are going to be offset buyers, here's the type of things that you should think about to evaluate them, right? So first, additionality. If you didn't pay them, was this going to happen anyways, right? Was that forest going to get cut down, but then you paid them and got protected, and how do you prove that, right? Permanence, which is, this is more important for stashes, so carbon, soil, and trees are sort of stashes, and then you have higher order gases, which are typically destructions. And so is this going to be there for the next 100 years? And 100 years is something that's used in the carbon offset space pretty frequently. And if it isn't, is there a legal system where you can get your money back for whatever got destroyed eventually? Leakage. So leakage, a little bit different than with gases. It's let's say you have a piece of forest and you posted armed guards around that piece of forest, and now it's going to be protected. Great. But what was the underlying reason that people were trying to cut it down, right? Was these farmers that needed more farmland, at which point, well, they didn't cut down this piece of forest, they'll just go and do it right next to that. And in that case, can you prove that you mitigated the core of why that forest was going to get cut down, as opposed to just posted some armed guards and pushed the problem just a little bit down the road, right? So that's a really big one for leakage, which again is a problem in some types of offsets, but not in all of them. Folks like the gold standards look a lot of other benefits. Is there biodiversity increase? Is there empowerment, so on? Secondary invalidation risk is not relevant to voluntary markets, but it is to some compliance markets, which is how well was the validation really done. And of course, you have to look at some unintended consequences. Were people displaced as a result of this project? What are the chances of gaming? Are there predictable amounts of it, and so on? And there are both independent rating agencies now that are starting to pop up, like Silvera from London, for example, that are trying to say, well, okay, there's some imperfections in the existing way of validations, but could we tell, could we do an independent kind of validation of what are the chances of these risks. And then there's brokers that you sort of trust to have an extra layer on top of the normal infrastructure. But there's kind of a question of like, wait, why do you need an extra layer on top of the infrastructure? In some sense, should the infrastructure already handle this? So what does the infrastructure look like? Okay, so you've got the registries, right? There's basically 4 of them, and they all kind of coordinate with each other. The registries, the project developers, so project developers is kind of like us. Validators are, let's call them auditors on steroids, right? They all work together to develop a new methodology. So somebody comes up with whatever crazy way of mitigating climate change, and then all of these 3 things work together in a very well-defined way to develop a methodology. And a methodology is to say, well, how do you measure this thing? But also, like, we're frost methane. If there was an evil frost methane, is it possible for an auditor to tell the difference? All right, and so that's the thing, and also how do you do this where you don't kill the project on just validation risks, right? So there's this balance between them. If it's small distributed projects, you want to do some statistical sampling. If it's one large one, you can just go out and measure, so that's really easy. And then the registries also certify the validators, right? Because everything here really depends on the quality of these auditors. So then you've got a project, right? So the developers get the project done. These guys audit it. Between 6 months and 2 years, I think, are the typical audit cycles. Once it gets audited, everything from the last audit can be sold. So here this produces offsets, goes into the registries, and buyers can change ownership, right, because it is held as an asset. Or they can, when they use it, they can retire the offset so that nobody else uses them. And because there's a small number of registries, so I know here we're all about decentralizations, but in this case there's 4 major ones, and so they coordinate with each other to avoid double selling. Compliance market, so California Cap and Trade pulls from the 4 major voluntary registries, for example. So because there's such a small number, it's possible to do the coordination in standard offline ways to make sure that that doesn't happen. Okay, so that's kind of what it looks like. And so if there's gaming in the market, we either messed up on the methodology or we messed up on the audit. And then there's a whole bunch of other crazy things, which feel free to ask me about in the Q&A. All right, so one last thing you need to know about the infrastructure is everything in the carbon markets works on a 100-year global warming potential. Why 100 years? A bunch of places that's the longest contract that you can make, right? And so for forestry, if you need to not cut them down for 100 years, well, that's a contract, right? And then the way this works with non-CO2 gases is you basically look at everything under the curve for whatever gases and then do the multiplication, right? So in this case, this graph is normalized to 1 ton of nitrous oxide, but essentially everything here is equivalent, and so that's kind of what the multipliers look like, right? There's also HFCs that would be way off the graph, so they're not here. All right, cool. So is somebody was supposed to show me time? Left, Jamie? Okay, cool. Okay, so one quick example, right? So let's say a forest was protected, right? Very, very common. So then, like, was it in danger? Did you address the root cause? So somebody mentioned about, like, counting the trees from satellites, which is great, right? That's a great first step. But was that forest going to get cut down in the first place, right? What's the counterfactual? That's the stuff that's really, 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 really hard, right? What was the root cause and was it addressed? Right, and then if it gets cut down in the future, are you in a country that has a legal framework where you can say, hey, I want my money back because you cut it down, right, or not? Is it a divorced forest, or did you plant a bunch of eucalyptus outside of its native environment and now it drained down your water aquifers and the local farmers are like kind of pissed off, right? What happened with the local community? Was there displacement? Is it prone to wildfires? How is that being taken into account, right? And managed forests can handle wildfires better than non-managed forests, so this could be a good thing. This is not at all to deter you from forestry. These are just all of the tools that all of you can build to help that particular methodology be better, right? And right now, like a tree is worth, like the timber or the farmland that it could be. So putting an explicit price on forests is a really, really good idea, but it's tricky for all of these reasons. And there's a program called Red Plus that, to some extent, helped address this by saying, look, if this thing is at the level of a country rather than an individual landowner, then you've got somebody you can sue, get the money back from, right? There's legal framework. It's a large enough area that leakage issue I mentioned is just not a problem, right? So there's lots of innovative solution. NCX is doing a really cool thing for like timber, for example, right? So there's lots and lots and lots of initiatives that are trying to figure out how to get that to work. And by the way, just saying, oh, well, we're going to plant new trees instead of protecting an existing forest, that doesn't help you that much either, because if you displaced farmers, well, those farmers went somewhere else and maybe cut down a native forest. So like, it's not, there isn't like a particularly easy solution, but there's tons and tons of tools that you can build. So that's kind of great. I wanted to have a good example of the carbon market like watchdog infrastructure working. So this was a UNCDM methodology like early carbon market, so kind of like late 2000s or so. So there was a program where refrigerant was being manufactured. There was a particularly high value HFC product, that global warming potential, right? So like blows everything else out of the water. And the old plants produced quite a bit of it, and the new plants didn't. And with the additional revenue of the carbon offset markets, the old plants became super profitable, and essentially they were the ones producing all the refrigerants, and the other ones weren't. Good news is, there was a watchdog organization, noticed the pattern, and the methodology was removed because they decided that they couldn't rewrite the methodology in a way that would, allow catching of this pattern. And so they're like, okay, anything that we can't like validate that there's no gaming, it's out, right? And there's a lot, like oil and gas, for example, doesn't fit into a lot of carbon offset markets. Anything that can like produce the emission and then have the cousin mitigate it, like all of that is out. And then I wanted to contrast this to this one company, Renewable, for example, but there's others that are, there's all of these old window air conditioners that get thrown away. If they just get hacked to pieces, everything goes up in the atmosphere. But if they don't, like this company and others, are paying the technicians that are taking it apart for scrap metal to also drain the coolant, and then they go and destroy it in a centralized facility, right? So something like this, right, you can imagine that the validation looks wildly different, but you can also see that the amount of, like people wouldn't, the cost of a new air conditioner, like nobody would be buying new air conditioners and then draining that fluid out of a new air conditioner, like until the price got to a certain point. So you know exactly what are the parameters at which you have to worry about this or not. Okay, so what are things we can do? So methodology improvements, methodology updates that are more frequent would be, you know, a really good way of keeping up to date with this, right? Because, for example, maybe you don't want to buy a new air conditioner where the price is like, you know, whatever, at $15 a ton, but at $200 a ton, maybe you really, really do, right? So I think these frequent methodology updates to keep up with other regulations, essentially, and like the prices and so on would be really good. That watchdog organization, some exist, but I think having much more to do aggregate evaluation of these methodologies would be pretty important. The true verification cost for this methodology, for example, carbon soil stuff is outside of Nori, like not particularly accepted, partially because you can't measure that really well, and so you've got companies that pop up to make that possible. Same with like small projects versus large projects. There's lots of small projects that just can't participate. So there's some innovation on that. Doesn't have to be perfect, right? There's some gaming, like if we try to make it perfect, it will be pretty hard to get anything done, right? There's some gaming that happens in the stock market too, right? So I think we just need to figure out what amount we're willing to put up with and then just buy 10% more offsets. And then I think it would be really interesting if there was other things that were explicitly traced, right? So the stuff that Alan talked about earlier, like the biodiversity and you know, the land use and a variety of things, are those benefits something that we can explicitly track and maybe track as a specific offset class eventually. I'd also love it if we were explicitly tracking risk. So for example, if there was, you know, like we're pretty sure it's good, it's got all of these benefits, it's super cheap, but maybe there's like a 5% risk that it contributed to something else. It would be really nice if that was like explicitly traced, and then you could like make real trade-offs between like, oh, well, it's got 10% risk of invalidation, but it's a really new tech, and like it's got a chance to come down the cost curve, and like the methodology is getting improved, so I'm willing to buy it in order for us to have more data on that methodology, right? So those would be things that you could do, but right now that is, you know, it's either validated or it's not, right? So it's kind of, the trade-off is made for you implicitly. So that's why there's like a bunch of other markets on like CO2 drawdown directly, which are like, well, that's the golden standard, that's the only thing we trust. So yeah, I think I was kind of hoping to have more time for questions, but I guess 50 seconds, so I'll take one question. But feel free to catch me in like a happy hour.
Yeah, thank you so much for framing a lot of this in terms of here are the issues, and that's like an entry point for people to start building tools to address those issues in the Web3 space, right? Because I think there's so much going on things like governance and public goods that are right sort of spot on, sort of applicable to these sorts of questions. If people know a lot about Web3 but not a lot about offsets and want to read up on these sorts of issues more, where should they go?
That's a really good question. I've been looking for one really good source, and I can't say that I have one, but they should email me for the specific question and maybe for their sub-questions. I'll have a resource. And I'd love to also point out the fact that there's a lot of infrastructure already available in the carbon offset market, and a lot of it is good. Some methodologies are fantastically well thought out, right? There's like 100 of them or so. So I'd say for people that are building stuff, I'd also encourage people to see what's already there, right? The fact that there's a small number of registries is really useful, so anybody making their own market should really figure out how to work with that market, otherwise the double counting will happen, like one in crypto, one not in crypto. And the validations and the methodologies and the way that's done, some are fabulous, and that should just be, we should just take advantage of all the really, really, really good thinking that has already been done. So lots of issues, lots of incredibly good thinking, so yeah, I think I try to balance those two. Thank you.
Thank you, Oya. And now I'm reintroducing Alex DeVries, founder of DigiEconomist, and he will be talking about assessing crypto asset sustainability. So welcome, Alex, back.
Okay. So, when we talk about crypto asset sustainability, a key question that we need to ask is how do we measure that? And secondly, what are we even measuring? Because sustainability by itself is a really broad term and it can talk about a lot of different things. When we talk about crypto asset sustainability, one of the first things we typically look at, and one thing that we see a lot of headlines about, is the energy consumption of the Bitcoin network. There are two main sources for that, so you can find live data about the energy consumption of the Bitcoin network on either my own website, the Bitcoin Energy Consumption Index, or you can find it through the Cambridge Bitcoin Electricity Consumption Index. Both have different methods, and I don't want to tire you too much by the technical details of those methods, but I do want to point out that if you look at these two different approaches, if you take the total numbers over last year, per my own energy index, Bitcoin was consuming 134 terawatt hours of electrical energy, and per Cambridge, that number was 104 terawatt hours of electrical energy. So I think ultimately the difference between the two methods isn't that interesting. I think the key thing is if we're looking at the energy consumption of the Bitcoin network nowadays, we got a pretty good idea about those numbers, and we can use those. But then the question is, okay, and what then? Because that's just Bitcoin. There are more assets like Bitcoin out there. The biggest one, the second biggest one that's using proof of work mining like Bitcoin is Ethereum at the moment still. They haven't completed their switch to proof of stake yet. And after that, you have crypto assets like Dogecoin, Litecoin. They significantly consume less energy, but at the same time, it also scales along with their market capitalization, because ultimately what we see in a lot of these assets is that their energy use is just related to how much the miners are earning. So simply said, the miners, if in these systems, if the value of the asset is zero, they're going to be making $0, and they're not going to be able to pay for the electricity bills. So the higher the asset value, the more electricity and the more hardware they can afford. This is a bit of an exclusive image, so I did the calculation based on my own energy index approach and the Cambridge approach for the top 10 largest crypto assets that are making use of proof of work mining. Note that the site is a logarithmic scale, so otherwise the smallest one wouldn't even be visible. But with this image, I wanted to show that if you're applying this approach, the ultimate result is that you can conclude it doesn't really matter which proof of work asset you take, they're all equally impactful. The market capitalization moves exactly in line with their percentage of the respective power demand. But then what? We got an energy consumption estimate. We can do it pretty easily. But in order to give that some meaning, we need to know where's that energy being sourced from? What is ultimately the carbon emissions related to the energy that's being used? That's a tough question. Because mining is somewhere you can do anywhere in the world, and we don't know which miners are located where. Now, the good news is Cambridge provides us with a lot of data about where miners may be located, and they seem to be doing quite a good job at providing those locations. So we can use that to evaluate, okay, if this is where miners are located, what does that then mean for the power that they're using? And if we look at that, we see that historically there's been a lot of fluctuation in the power sources of the network. A key reason for that is that up until last year, a lot of these miners were located in China. And within China, they were moving around. They were moving from the north of China in the wintertime, the dry season, to the south during the summertime and during the rainy season, so they could take advantage of cheap hydropower and then migrate back to the north and use coal during the winter months. And it's nice to see that that migrational pattern just shows up when you look at the data over time. We can see the summer periods with a lot of hydropower. We can see the winter months with a lot of coal-based power. But then last year, and I addressed this earlier today, China said we had enough. They found that these miners were responsible for the revival of some idle coal mines, and they just didn't want this crypto mining industry anymore. They wanted to comply with their climate targets, and they just kicked out this industry. The ultimate result of that was that a lot of these miners migrated to countries like Kazakhstan and the US. And the interesting thing there is that even though we don't perceive China as a very clean country, the Bitcoin miners over there were doing quite well because they were getting a relatively high amount of hydropower. But when they were forced out and they had to migrate to the US, they now got into a situation where the grids are more reliant on coal and natural gas, especially in the US. The primary energy source is natural gas. So what we see is that the average electricity mix is also changing. The majority of the network was already powered by fossil fuels, and that majority increased, mainly due to hydropower being traded in for natural gas. And another issue is that even though we see the share of coal going down, you would think, okay, that's great. But unfortunately, the Kazakhstan coal is probably one of the worst sources of coal in the entire world, because in Kazakhstan they primarily rely on hard coal, which is the worst type of coal you can be using, and they have a really inefficient way of processing it. So ultimately the carbon emissions of that can be 50% higher than what would be normal in the US or in China. Altogether, that means that also the carbon intensity of the network has been increasing for the Bitcoin network over the past year. And ultimately, this means that the entire network has a carbon footprint of, we estimated, 65 megatons of carbon dioxide per year. This was a couple of months ago, by the way, so in the meanwhile, the energy use of the network has been going up. But this data is based on August last year. And back then, this is the quantified footprint. What does that mean? Well, 65 megatons of carbon dioxide, it's more than what a country like Greece is responsible for every year. It's also more than what we're saving from deploying electric vehicles around the world. So we're talking a pretty substantial number here. It's around 0.2% of our global carbon emissions. And of course you can say, okay, well, there are bigger things, but it's definitely not an insignificant amount. And the interesting thing about this map is it also shows where those emissions are being sourced from. So we see, like I just said, Kazakhstan and the US are really driving this number. And also within the US, we see that states like Texas, Georgia, Kentucky are key drivers for carbon emissions of Bitcoin miners in the US. And that's all because of the reliance of natural gas and coal within these grids. One of the reasons why Bitcoin mining is so popular in these states, I think it's good to point out that Kentucky last year introduced tax breaks to lure these miners to their grid. And they literally said, you know, we have an obsolete coal industry and we kind of like to have a buyer for that. And Georgia is actually moving in a similar direction. They are also recently talking about introducing tax breaks for miners. And Texas has been very welcoming to these Bitcoin miners as well. I think the governor said, okay, this is going to fix our grid. Well, like I said at the beginning, when we talk about sustainability, we also need to talk about those kind of things. So we can't just talk about the energy use and carbon emissions. We also need to talk about things like, hey, the system is using highly specialized equipment. If you're mining Bitcoin, you can't just do that with any laptop. You need a very professional mining device. And you're going to need a lot of chips to create that machine in the first place. We're already dealing with a global chip shortage. So we're going to be using some capacity that we could also use to do other things. I can't quantify the impact of it. Just want to point out that we're in a global chip shortage. So if we're putting chips into highly specialized machines that can't do anything else but mining, we lose capacity for other things. And the other thing is that these machines tend to become obsolete pretty quickly. The only thing they can do is mining, and they are in use for as long as they are profitable at their task. So while they're making money, that's great, they're running. But typically, in a period of 1.5 years, they get to their break-even point. And then the question is, okay, what are you going to do with your device? Are you going to store it, hope that the Bitcoin price go up? Or the only alternative is throwing it away because you can't repurpose the device. They're using highly specialized chips. So also the e-waste output of this network can ultimately be as high as, well, my home country, the Netherlands, at least in terms of small IT equipment, which is an additional issue on top of the energy use. It just comes on top of it. The energy use is not just emissions. It also means that in a lot of cases, these miners can overload a local grid. We have seen that in so many cases by now that all these miners are looking for cheap energy, cheap electricity. They all want to get the same cheap sources because they all have the same biggest expense. But it's driving them to the same locations and it's overloading those grids. So that's why we see on the right side numerous examples of grids that have been facing, in the worst case, power outages as a result of all these Bitcoin miners coming to their grid. And it's a big issue because ultimately, if people are left in the dark, you're not left in the dark when everything's fine. You're left in the dark when there is a peak in demand, which happens if either it's 40 to 50 degrees outside or minus 20. So this can actually put lives at stake as well. And this is just, again, on top of all the other things. It's all the things that we need to consider when we talk about crypto asset sustainability. Now, the good news is, I've been talking a lot about Bitcoin and its proof of work algorithm, but there are other solutions to running a crypto asset nowadays. So Bitcoin isn't entirely representative for what's really going on in the space. In fact, I would expect that most projects nowadays, and especially the new ones that are being launched, they don't use proof of work to bootstrap anymore. They will typically run on proof of stake or something else. And the nice thing about proof of stake compared to proof of work is that whereas in proof of work, you have this really massive lottery going on with all these devices just constantly running, trying to guess a winning number and hoping to guess one right so they can get to create the next block for the blockchain and get a reward for that. In proof of stake, you don't need that. The only thing is, what you need to do is, you need to get some coins, you need to put them up as collateral, and the protocol will randomly assign the right to create the next block to the blockchain to one of the people who put their money at stake. What you need is coins and a device with an internet connection. You don't need to have your machines running 24/7, and the amount of machinery you have running will not change your odds of winning. So the nice thing about that is that it takes away the hardware-based competition, and it can tremendously reduce the amount of energy we require to run this type of systems. I wrote at the top here that if Ethereum succeeds in changing its algorithm from proof of work to proof of stake, which is what they're working on, they could save up to 99.99% of their energy consumption, which is a pretty massive amount. It's just 1/10,000th of what they're currently requiring. But it's a very difficult thing to estimate still. Ultimately, we don't know how Ethereum will really look like once it switches to proof of stake. How many nodes will be active in the network, what will be the hardware requirements, how will that develop over time, because as the network grows, the hardware requirements might also grow, and the energy consumption might grow, unless Ethereum also manages to implement sharding. It's a very fun discussion you can have on that, but there's just a lot of unknowns to such a prediction. And moreover, we still see a lot of differences even within the crypto assets that are based on proof of stake. So at the bottom here, I got a report from the Crypto Carbon Ratings Institute that was published several weeks ago, and they looked into, okay, how much energy do these proof of stake based blockchains really require? And they took a hardware-based approach, so they just checked, okay, what do we need to really be able to run a node in these networks, and then use those hardware requirements to come up with an energy estimate for these networks. And what you see is that if you look at this metric, the electricity used per transaction, you can see that some systems are a lot more efficient than others. It ranges from 50 watt-hours per transaction to less than 1 watt-hour per transaction. Now, just to give this a little bit of a meaning, if we would look at the energy use of a payment provider like Visa, the energy consumption per transaction would be around 1.5 watt-hour. So some of these are doing really well, but if you look at Cardano, they're doing almost 30 times that. So you could be wondering, hey, if we're switching from our current system to Cardano in this case, we would be increasing our total energy use by 30 times, which would still be pretty bad if you think about it, because ultimately it's a significant factor. It's just that with proof of work being around, it tends to take away the focus from that, because it adds such a large amount on top of that that we forget that proof of stake by itself isn't always perfect either. And I think this was one of the points that was raised during an earlier talk. If we move to proof of stake, we're not necessarily there. This is the last bit. And it's difficult to solve, because ultimately this is blockchain. Blockchain relies by design on the replication of data, replication of processes. If we're doing things in a single server, if we're moving that stuff to a blockchain, what happens is we're going to need multiple servers. And I don't know how many there are ultimately going to be, but it's going to be more than if we just take that single server. And there can be a benefit from not having to rely on that single server, because that's also blockchain. It takes away the centralized single point of failure, but at the same time, adding that trust through distributing data comes at a price, which is typically a reduction in efficiency. So we always have to think about, does our use case really warrant that we put stuff on a blockchain, or should we be, are we fine with our current system? Do we trust the people that we have? Because trust actually tends to be more efficient than whatever we can do on a blockchain, unfortunately. But again, I just want to stress that doesn't mean there's no good blockchain use cases. It just means that we have to be really careful in considering our options here. I haven't said anything about Filecoin. I have 1 minute left. I would assume that Filecoin is probably somewhere between this type of proof-of-stake networks and ultimately proof-of-work networks, because there is an incentive to employ solid-state drives. But the energy consumption of that is going to be less. So the ratio hardware to energy is going to be very different from what we see in Bitcoin, probably low on energy and relatively high on the hardware. We only just have seen the first steps to evaluate the energy consumption of a proof of storage-based network. And I think it would be a next step to also look at what can we measure in terms of electronic waste output ultimately, because that's also part of the questions that we need to ask. I think I have 30 seconds left, so I shouldn't add any more points. I'll just keep it at that. Maybe one question.
On the previous slide, the watt hour per transaction, is that calculating also all the validators, all the set, or the single node that validated the transaction?
What we typically do is we take the total energy consumption of the system and then we divide it by the number of transactions that's being executed in total. So okay. Everything added up together. For Bitcoin, these numbers are a lot higher. Then we're not talking about watt hours, but we're talking about kilowatt hours. A single Bitcoin transaction, well, if you look at my data today, it will say it's equivalent to 2,200 kilowatt hours of electrical energy consumption, and per Bitcoin transaction also a carbon footprint of more than 1,000 kilograms. Might be hard to wrap your head around that, but that's more than a per passenger carbon footprint of a flight from Austin to Amsterdam.
Just ever so quickly, a related question. When you're calculating the carbon emissions for each of these networks, what type of emissions factors are you using?
Sorry?
The emissions factors. Are you using generalized, annualized emissions factors for each country where there are node operators? Or are you using something more granular, such as based on the locality of where those operations are taking place?
This is just based on averages. So indeed, we take the location and we just apply the average emission factor of a grid. You could actually argue that if you're going to look into this, one thing you should be doing is you should look in the marginal impact, because ultimately when you increase the demand on a grid, what's going to happen is some type of fossil fuel source is going to come online to power that. The marginal resources in most cases, especially in the US, is coal. So any increase in demand is typically going to be sourced from coal. Unfortunately, we can't really specify that properly, so that's why we had to go with averages. But even on averages, Bitcoin got less green over the last year. So if we would look at the marginal impact, the numbers would probably be even worse. Yes, a lot.
For Bitcoin specifically, they would be worse over the past year. But if you're looking at some of these networks, such as, say, Polkadot, that's the nodes are predominantly run in Europe, the marginal emissions factor for those grids is potentially much lower than here in the US.
It depends. I mean, in Germany, the marginal resource is still coal, so it really depends on where you're located in Europe. I think in most cases, the marginal resource is fossil fuel. The marginal emission factor is going to be higher than the average. There are exceptions, of course. You would have to check. That's difficult.
Great, thank you. Thank you, Alex. And then, of course, after these sessions, you can talk to any of the speakers by the pool area. So as we set up for the sort of next conversations, we wanted to thank everyone sort of in person and who has tuned in online. And I also wanted to introduce my colleague, Mark Johnson, for the Sustainable Network Operators. So yeah.
I'll follow the chairs. Work, proof of stake, anything else can leverage these components that we're building and decarbonize their network activity as well. We have already heard a tremendous amount from a number of important stakeholders, but the one stakeholder group we haven't quite heard from yet is the storage providers in the context of Filecoin and or mining operators within the context of most other networks. So I am joined here with 3 storage providers or people that are relevant to the storage providing ecosystem within Filecoin. And shortly, I believe we'll have another person joining this panel who is a traditional crypto miner in Brittany Kaiser from Griffin Mining. So just to kick us off, I figured I'd hand it over to you all to provide just an intro of who you are, your work, and if you could just start to explain how you're addressing or accounting for the environmental impact of your operations as storage providers.
Hey everyone, I'm Alex Altman, the COO of Seal Storage Technology. We're a storage provider here in North America with operations in Las Vegas, Nevada, and Montreal. Both of the data centers that we use 100% renewable energy. The one in Las Vegas is with a company called Switch that does 100% solar, and the one in Montreal uses hydro. And when we consider how to view our environmental impact, we looked at a number of different things in the market in terms of trying to figure out, should we go out and get a certification? Should we, if we were doing a certification, which certification would we use? And the more that we looked at it, it appeared to be a very disjointed industry. So we decided that what was best was to provide radical transparency in terms of what we were doing, how we were doing it, and then we also were looking for ways to do more than just self-reporting in terms of saying here's the emissions we did, or here's the energy usage that's tied to those emissions, and how we're reporting it. So what we're really focusing, again, is how to make that a more automated, trustless process using Filecoin, as well as some other technologies. When we looked at the industry, we saw that most people were reporting quarterly, biannually, annually. So it's kind of harder to make active decisions on how to decarbonize your company when you're reporting so infrequently. So we're actually also working to try and reduce that significantly to get to a point where we can do it weekly and then up to a point where it's actually real-time data, specifically with regards to energy usage.
Awesome. Welcome. I'm happy to be here. My name is Hidde Hoogland. I'm the co-founder of Decent. It's a data center slightly above Amsterdam in the Netherlands. We've been working with Alan from Filecoin Green for the last half a year to make our data center as renewable as we can. And we just finished installation last week of about 250 solar panels. You already saw on the screen an hour ago. We are offsetting about 40% of our yearly usage, and we are trying to offset even more. And the rest that we are purchasing is fully wind and renewable. So that's real awesome. We are in discussion with the roof owner to build even more solar, so we can go to fully 100% renewable.
Hi there, my name is Jonathan. I'm the MD of Holon Innovations. We're an investment firm in Sydney. We're at the start of our energy journey. We only just bought a solar farm last week. And as Alex said, we've been looking at the energy market and how do we become 100% verifiably run on green energy. And once you start talking to lots of consultants and experts, you realize it's really hard and there's lots of murkiness of the whole industry. That's why we bought our own solar farm, so we can point at that thing and say that's ours and we can decommission those credits. So yeah, our long-term plan is build out our storage and also make it 100% verifiably green.
That's fantastic. And it's obviously apparent that you all have a tremendous amount of experience and knowledge on how crypto and blockchain can be a real player in the renewable energy space. And it can help drive real objectable action towards climate change, right? Obviously, as Alex mentioned earlier, there's been a lot of attention put on these mining operators in the context of Filecoin on storage providers about the energy consumption profiles. But it's not all bad. There are obviously some great players in this space. And whether it's specific to your own operations or something else that you're seeing within the industry. Can you talk to all the innovation that you're seeing in this space on leveraging this technology to provide more publicly verifiable sustainability claims? And maybe first to start with you, because I know you're thinking about it more from an investment assessment perspective.
Yeah, so we're at the kind of the data collection stage at the moment. Sure. So we have 4,500 pieces of little hardware in the data center. They either do something or they don't do something, right? They sit idle or they're running some processes. At the moment, we are aggregating the data of like how much energy do they use when they're on a Zeus, how much energy do they use when they're on Hewlett-Packard, and we actually had 7 Zeus engineers in the other day to change BIOS settings so we can understand every piece of hardware within the blades that we actually use. I think us as storage providers, it's actually our responsibility to drive innovation, and I think we're going to see the same thing as the Bitcoin industry, right? Like, how do we make it more efficient, long-term, full stop, right? And the industry at the moment is not even set up for that. If you look at warranties from Asus or HP, you're not some bits of hardware you can't submerge. And if you look at the PUE, so we're actually in the most efficient data center in Australia. PUE is like 1.25, sometimes lower. If you know PUEs of DCs, some could be 2 or 2.6, the efficiency to actually cool the actual DC. So it's really interesting when you start working with Hewlett-Packard, you realize they actually have to change their warranties for you to submerge so you can actually get better computation power. So yeah, I think, I went on a bit of a tangent there.
No, that's perfect.
But ultimately it's our responsibility, and you need to look at it from the whole stack, right? From solar farm to the SSD and the hard drives running in your DC. Just be super focused on everything.
Yeah, sure. I really appreciate that, and that brings me to another question I had in mind, which is, the scope of the coverage. When you're thinking about the environmental impact of your operations, right? You all are obviously front runners in the space, putting solar panels on your operations, on the roof of your operations and things like that. But from a server rack or from a mining rig perspective, are you looking into the embodied emissions associated with those hardware components? Because that'll give you significant coverage from a carbon accounting perspective. And it's, as you were just explaining, Jonathan, it's very, very difficult to do. So, Hidge, if you could explain some of that in terms of what you are thinking about.
Well, for us, it's a different story. We are actually the owners of the DC ourselves.
Sure.
So we are fully capable of seeing everything that's being used, even to the electricity or the lighting in the office area. We can scan everything, show everything. And what we are trying to build right now is have an API connected from the solar inverter, which will show us exactly how many kilowatts we are creating and at what time every few seconds. Then we are trying to build an automatic API in a database where all the servers actively storing and sealing are sending their usage to, also every second. And we will link both of them to a database which Alan will control and live show it on the blockchain. So there is, we are ending the discussion. If people ask, how green are you, what are you doing, you just show them and end of story.
That's wonderful. I want to make a note there. Will Alan actually be controlling that?
Yeah, I'll be sending it to Alan, and he will send it over to his engineers probably.
That's fantastic. And what are you doing in this context? How is your operation moving towards a decarbonized future?
Yeah, absolutely. So what we're using in our data centers, again, we're using co-location, so we don't actually own our own data centers, but having mentioned the kind of renewable energy factor of those, we're putting in essentially smart PDUs, so basically just like a smart power bar that controls and shows us exactly how much energy is being used by each one of those ports on that energy bar, so that we can track specifically how much each component, what you guys were talking about before. It's really important to understand how these components all play into your energy usage, because that really is, at least from a scope 1 perspective, so a product perspective, not how much gas it took to move one hard drive or what the boat emissions were, but our actual scope 1, like what this product is doing, energy is going to be the vast majority of that. So understanding what the true scope of that is what the task is going to be. And apparently you and I had similar ideas from across the ocean, but we would like to put all of that data directly onto Filecoin and seal it because it's creating this chain of custody and historical immutable element to the data. I mean, for better or for worse, people can always look at it and say, this is how good or bad this group was doing, and they could take us to task and say that you've made these commitments, you haven't made these commitments. So I think that's a large element of what Web3 is doing for this entire industry, and you have to be able to identify the type of problem that you have with real unbiased data.
That's fantastic. You touch on really two crucial points I want to circle around on. That first one being that end-to-end audit trail of immutable and verifiable data. That is absolutely crucial, not only in the context of storage providers and or mining operations to showcase how they're moving towards a decarbonized future or a net zero goal, but also in the broader spectrum of corporate sustainability goals and objectives. We are building some of these components. You are proving them right now. Oh, welcome. Another panelist here. I will come back to you in just a moment for a lovely introduction and get you in the combo. But just to close on this point, building these solutions, these Web3 native monitoring and tracking tools that create end-to-end audit trails to prove sustainability claims, that is something that is far above and beyond what we currently have in the traditional Web2 space. And it's so great to see you guys already starting to build some of those and implement them into your operations. So now, ever so quickly, introduction to Brittany Kaiser here of Griffin Mining. If you just want to provide the audience a quick overview of what you do at Griffin and how you are thinking about the environmental impact of your operations.
Yeah, absolutely. So hi everyone, I'm Brittany Kaiser. I am chair of the board at Griffin Digital Mining. We started our Bitcoin miner about 1.5 years ago with the specific focus to be the first, not just carbon neutral, but carbon negative miner. So to really concentrate on our ESG strategy in terms of not just only using renewable and nuclear energy and not choosing fossil fuels or even a fossil fuel mix for what we're doing and how we're mining our Bitcoins, but also to be investing in carbon sequestration, carbon removal, reforestation, and all of the types of ways that we can go above and beyond our small carbon footprint and actually be negative as a strategy. Now, what we have also been doing is working with Energy Web and a bunch of other folks specifically to look at how we can become completely transparent, where we can track and trace where all of our ASICs are actually plugged in, how we can prove that we're actually using renewable and nuclear energy as opposed to fossil fuels, and how we can prove that publicly. So we're undergoing carbon emissions audits. We're going to be doing public ESG audits. We're about to list on NASDAQ, so we will make all of that information public and really to be collaborating with all of the top people in the industry to build these tools so that every other company can do this too. It's the only way that we're going to be able to prove to journalists and to legislators and regulators around the world that our industry is actually mostly full of really good actors that are trying to do the right thing, and that we can become a financial partner for investing in the large-scale development of renewable and nuclear energy sites and be a partner in helping achieve climate goals as opposed to an obstacle.
That's wonderful to hear. And a number of things that you just said piggybacked off of what Alex recently said when he introduced the term scope of emissions. And for those of you who don't know, there are generally 3 broad scopes of emissions. Scope 1 and Scope 2 being those direct emissions that are generated within the operational boundaries of your organization. And then the Scope 3 emissions, those supply chain emissions that are generated from your upstream or downstream supply chain partners. Unfortunately, those Scope 3 emissions are generally the ones that create the lion's share of the pie of your emissions profile, and they are the ones that are generally not accounted for. So could any of you, I know that you've done a lot of work in this space, but anybody else as well, talk about how you're thinking about specifically those hard to account for Scope 3 emissions?
Yeah, I'm happy to jump in there just because we're in the midst of our first carbon emissions audit. So that has been really interesting for us, really digging into the nuts and bolts of how our business model works. Obviously, there's other Bitcoin miners that, for instance, are completely vertically integrated where they own the facilities where their ASICs are plugged into. Not everyone does, so we use a lot of co-hosts like Core Scientific and Coinmint, and these are businesses that specifically host ASIC mining machines, and so they make the direct business decision of how they are building out those facilities, what materials they're sourcing, where they're sourcing it from, and so we're looking at In terms of scope 3, obviously these are not our direct decisions, but do we have the ability to influence those decisions? So can we actually work with our partners where it's not a direct business purchase of ours, but say, hey, here's how you're sourcing some of your insulation, for example. You could actually be sourcing something that is either more efficient or something that has come from a greener source, et cetera and so forth. Can we get our ASIC miners to be delivered on cleaner ships, for example, when they're coming over from Asia? And so there's a lot of things that are not in our direct business control, so they easily go to scope 3. But really, we might have the ability to influence and therefore be able to green our supply chain. So that's really what we're looking at, things that are not just in our decision-making path, but if we go to scope 3, like how can we not just say that that's something that we don't have any control over? Like, let's see if there are ways that we can actually influence that.
That's wonderful to hear. And is that something that's within, you know, the realm of possibilities for you all as storage providers? Can you look into your supply chain and your suppliers and try to influence them in making carbon positive decisions?
For us, I don't think it's feasible. The orders we place are not that high that we can make a decision on their fronts. But the thing that we are trying to do, and as a data center, it's of course impossible to go off-grid.
Right.
You need continuity on all machines, of course. Otherwise, you will get slashed. The only thing we can do in the Netherlands, we have wind, but you cannot just randomly place a windmill somewhere in the corner. But what we do have is solar, but at night, of course, we don't. And the battery capabilities are not yet decent enough to use that too. So the only thing we can do is create the same amount of energy we use yearly with solar and prove it on chain. But adding the machines, manufacturing, the shipment, for us, it's a bit too much to do.
Yeah, being an investment firm, it has its pros and cons. And I think the pro here is our next shipment from Hewlett-Packard will come with some conditions. You know, we want the hardware as cheap as possible, but we also want to know the complete supply chain of it. And it pains them when I say that, and I can see them sweat. But, you know, I'm going to stick to my guns and see where we get. Maybe I might not get all the way, but I might get halfway, and the next shipment I might get all the way there, right? So I think it's, you know, for the people that are actually buying a, you know, good chunk of equipment, just really keep the heat on them 24/7 is really kind of our responsibility.
Yeah, wonderful. And it is those incremental gains that we can only ask for, right, in trying to influence some of those suppliers to move us towards a more decarbonized future. So that's great to hear that you're pushing on those levers from your angle. I want to pry into some of this a little bit more and talk specifically about the challenges that you all face with trying to procure renewable energy, maybe in the Dutch grid system, or here in Texas and in the US or wherever it may be. What are some of the challenges that you all have experienced with just trying to account for, mitigate the emissions, and then to source renewable energy to totally minimize the emissions that are generating from your power generation or your power consumption coming from traditional power generation assets?
Yeah, so for us, I mean, it's much easier, again, going back to this kind of smart power bar, to just say what's our specific emissions, or I guess what's our energy usage and touch the emissions. But we do actually pull on the occasional third-party source when it comes to additional resources. Generally, those resources come in the form of additional compute power or sort of memory power, things like that have to come from other data centers, whether it's in the US, whether it's in Europe. Sometimes it comes all the way from India. And then getting sources, even in the US, right? Like we have some compute that we've got from the Midwest, and we have to analyze their energy grid, what's their energy mix, if they have renewables, what are the sources during the day, and just trying to line up all these different factors of saying that our usage is heaviest during, it's pretty consistent, but saying that during the day, if the Midwest uses 40% coal, how do we apply that to us? And then we have to go out and look for a kind of localized renewable energy credit. And then there's a lot of intricacies involved in localized grid analysis, which is not necessarily something that you expect to be doing when you're working with a cutting-edge technology like Filecoin, is saying how much carbon is being used in Midwestern Ohio. Like it's a very different element for us. So you have to bring in the right people, and then once we're able to try to find that, it's the information becomes relatively incomplete. But we try to mix that in with what we have, and then overbuy because it's there is limited information, and we try to kind of put that all together and make that public so that at least people can understand where we are and then integrate our information and our data into their stack and say, okay, at least I've got transparency from this source.
Sure. Yeah, I'd piggyback off of that to saying I didn't expect to be running a Bitcoin mining company and looking into technical solutions of how we can prove the exact energy source of where every electron has been energized from in a grid mix. That didn't seem directly in my wheelhouse. And so it's been really amazing to get the opportunity to meet experts in the energy industry, like some of the gentlemen back there that I've been working with closely at Energy Web and now Zero Labs, who are building out a lot of really amazing technical solutions to this, where we can start to think about how we actually track and trace these grid mixes, because right now we have some public sources of information, as you said, how a local energy grid actually works, what are the reports that come from the local energy authority, and then obviously renewable energy credits and other government incentives that might have some sort of certificates of tracking and traceability of what that power station is actually providing. But getting down to as granular of a level as we would like to is still actually quite an iterative process, and I think there's a lot of people in this room have been working together to try to figure out the best solutions so that we can get over that regulatory struggle that I feel like our entire industry is dealing with, where we're painted with the brush of not being thoughtful in terms of doing our part to achieve climate goals. And I really think that most people that are in this industry because they believe that these technologies will have a positive impact on the world for many different reasons. And so we don't ever want to be that obstacle or that hindrance to climate goals, absolutely not. So really doing our best at the moment to be working together to make sure that we can provide these solutions as soon as possible, not just for our individual companies tracking and traceability and auditing, but for the industry as a whole.
So in Australia, we've got a unique situation. We have lots of land and lots of sun. So really my problem is I really want to connect every piece of hardware that we have at the DC, almost the BIOS settings to some kind of DID. So we have a decentralized identifier that goes straight. So I don't have to do anything software. The BIOS and the software does it. That's really our dream state, because then I don't have to worry about anything. Everything is transparent and verifiable 24/7, 365. And for at the moment, we've got a couple of thousand pieces of hardware, right? But when that gets to a couple of million, it's going to get really, really hard work. So all the kind of data collection and recording needs to be done ASAP for us, really.
Yeah, sure. That's fantastic.
Yeah, well, we don't have that much land, and we don't have that much sun. I'd rather put my panels in Australia, but no, we have an extreme necessity, especially in the Netherlands, to make the usage visible. There's actually, if I quote this correctly, there's actually a stop on new data centers because the net is full. They cannot place any more data centers because we don't have any more power to connect them. It's an extremely dense country, of course. We were also lucky that we were accepted on getting our daily peak usage back to the grid, because also there's a stop on delivering solar energy during the day. But when we can make this visible for them, we can also apply this to other data centers, of course, in the Netherlands, which we have a large data center from Microsoft, and there are more, one from Facebook being built too. But it's really important for us to make the insight visible, where the energy is being used.
That's fantastic, and I can't believe that you're running out of land and power for data centers in the Netherlands. That's insane. So we've talked about some of the challenges in terms of data collection, and also there's been a few mentions of the regulatory uncertainty kind of playing into this in some of your jurisdictions. Can you speak a little bit to that? Is it right now, because of the uncertainty, really limiting some innovation or some opportunities, or is it kind of just, in a strange mix of things? Any takers?
Definitely, I would say regulatory uncertainty makes it more difficult to build. I spent most of my time in this industry working on regulation. I was lucky enough to meet Caitlin Long at the end of 2017, and I moved to Wyoming to work with her there for the past 4 years. I sit on a number of the congressional subcommittees on blockchain, fintech, and digital innovation. have helped write and pass now 22 laws there, which we've used in over 20 different countries and 16 other states as kind of a digital asset legislative framework that we believe is actually conducive to the industry doing well. And now we finally have an executive order in the United States to finally take this seriously and get some federal legislation. And I think as soon as we started passing laws in this industry, which wasn't until 2018, we saw all of a sudden, tens of billions of dollars, now hundreds of billions of dollars of this industry now locating in the US now that there was some kind of certainty. I can only imagine the trillions of dollars that will come once we have a good federal framework. And many other countries that have had a good federal framework for a long time, like Switzerland, for example, have seen the financial benefits of being open to the digital asset industry and working directly with technologists and legislating with them as opposed to legislating against us, right? And so I think it's very important for everyone here that actually, has a company in the industry to have that contact with legislators and regulators, engage with them openly, write them letters, call their office, show up and testify in Congress or in Parliament, depending on what country we're talking about, and openly engage and say, hey, I'm an executive from this company in the blockchain or digital asset industry, and we would love you to vote yes on this bill, or we would love you to vote no on this bill, because it would be good or bad for the industry. Like, make your voice heard, definitely get super involved, because it's the only way that we're going to find a regulatory infrastructure that actually makes sense and allows us to build our businesses and have the positive impact that we intend to have in the world.
Yeah, I could say Canada has been pretty ominously quiet about the whole thing, which doesn't make for a fantastic regulatory environment. The position it seems like the government tends to take is it's not a problem, and if you don't make it a problem, then it's probably okay. And that's how we got, Canada obviously has Bitcoin ETF. We've got public Ethereum vehicles. I know there are some in the States, obviously, there's Grayscale and things like that, but we have like an actual kind of spot ETF, and we've had it for a long time. So when we, talk to and we're a Canadian company, we have operations in the US, but we're governed under the laws of Canada. We do talk to the regulators. We submit, a yearly audit, and we just basically have to suggest and say, hey, this is the closest that this looks like, right? The way that we earn coins, the way that we regulate ourselves looks like this other industry, and therefore we feel like it should be regulated as such. So generally they're pretty reasonable, but those could be famous last words, so who knows?
You mentioned it in the Dutch context, but I wanted to ask further if you have any understanding of the regulatory uncertainty there, or in Europe writ large, that is maybe hindering progress in this space.
It's not my field, so I have no clue, but it was a mess chatting with the government about what are you actually doing. And one of the most important things we needed to make sure of is the creation of Filecoin isn't taxed like when you're selling a product. For us, it was the most important thing because our main income is creating new Filecoins at the moment. Eventually, it will be deals, of course, but for now, it's just making new blocks. And we needed to make sure that there was not added tax on top. So eventually, we have been chatting with the government, and we have been emailing them and sending letters, and it was accepted to make a few separate businesses for the hosting, for the mining, and for the investments. So we've done that, and now it's agreed upon that we do not pay tax on top. But for the rest, I don't know the regulatory things in the Netherlands about this mining structure. We do not have many miners because you might not know, but do you know the electricity prices in the Netherlands? What we pay per bare kilowatt? Take a guess.
I don't know.
8 cents. What do you pay on average? For the 6 cents. Yeah, well, when Corona began, I paid...
Before credits.
Yeah, like the bare kilowatt price. Before, when Corona started in 2020, we paid 3 cents on average that year, because of course all the companies were shut down. Now we pay 25 cents, excluding tax, excluding import per kilowatt. So the solar thing is really important for us financially too, but it's a mess.
Those have to be some of the highest rates in the world.
Yeah, well, welcome to Europe. Also, you were complaining about gas prices of $4 a gallon. We pay about 12. So, yeah.
Also, to just add to that, recently the European Union European Parliament was going to have a particular meeting on the power usage of crypto miners. So that was not Bitcoin specific. That was talking about all crypto mining. All proof of work really is what they were looking to discuss, and that discussion has been delayed. So it was supposed to happen 2 weeks ago, I think, and because of Ukraine, everything was pushed, and so that discussion hasn't happened yet. But it'll be the first main meeting. We obviously had one in U.S. Congress about a month ago, and so Europe is following that. So I'm gonna be looking closely at what they have to say in those discussions. But I really do think that what we're probably going to see is that governments are going to start working to incentivize miners using renewable energy and be able to hopefully track and trace some of those credits directly to the mining company instead of just through the local energy authority, which actually cuts off a lot of people in the crypto industry who are financing a lot of the large-scale renewable and nuclear developments. We're actually not directly getting the credits, and it's a very difficult process to even prove that we're using renewable energy because we don't get the credits from the government. But I've seen state by state in the US that states are considering making specific renewable energy incentives for mining companies and then being able to trace that through their energy usage and credit the company in and of itself. So we're getting there, but we're not there yet.
That's great to hear. And I mean, it's interesting that you talk about the flow of those credits through all the intermediaries. And it seems to be a perfect area in which Web3 native monitoring, reporting, and tracking systems need to be built to facilitate a more streamlined approach to these credits being the formation of them, and then ultimately the delivery of those credits to the appropriate people.
Yeah, I mean, there's a lot of thinking right now on a technical level exactly how we prove that out, and then how, not only how are those credits tracked and traced, but then is there a way of tracking and tracing the green coins that come out of that type of mining? And so will there be a premium on those green coins? Will there be completely different markets for investing in coins that were created with renewable and nuclear energy without much of a carbon footprint? Like, perhaps. I definitely think, we're starting to see green mining ETFs coming out. And so I think there's going to be more of that, where a lot of funds that have an ESG mandate are only going to be able to invest in coins that have tracking and traceability from renewable energy production. So I do think that will go in one direction, whether or not there's a premium, whether or not we want to have a discussion on that threatening the fungibility of certain coins. Like, I think we need to make sure that it doesn't do that. But those markets are already starting to show a preference for green mining specifically. So the more that we can prove that, the better it will be for the industry.
One thing I want to quickly focus on before we finish is we have to remember when the Filecoin virtual machine comes out and you have the Filecoin network, it's going to be vastly more efficient than Web 2, right? Because Filecoin is not a competitor to Amazon, it's a competitor to multiple industries, right? So once that Filecoin virtual machine comes out, right, compliance almost goes away, right? Because it gets written into the contract at the top level, so you don't need lots of people checking, right? So we just have to remember Filecoin only uses, energy consumption on my P&L is 1% of the bottom line, right? Bitcoin's 50%. So it's already energy efficient compared to other consensus mechanisms, but long term it's going to be great for the world, great for energy. We're currently writing an ESG report, so we're kind of getting into this now, but yeah, we're just excited about it.
That's fantastic to hear. I am equally excited. We could spend the next 4 hours talking about
Cheeky
that.
plug.
But in the interest of time, I want to hand it over, see if anybody has any questions. I think a few of you may be teaming to ask these storage providers, these miners, some of their crucial energy consumption questions. Anyone? Please.
I have to talk about your electricity price. So to equate, so everyone kind of understands, when I say 8 cents a kilowatt hour, right, that equates to, when I throw out my guess of 8 cents a kilowatt hour, that equates to $80 a megawatt hour. So what he basically said is I'm paying $250 a megawatt hour for my energy. How do you approach your operations in managing that cost, and how are you guys actively trying to work with the government to decrease your energy prices?
Well, one of the reasons we started out on Filecoin in mid-2020 was because we were owning a solar farm. Me and my solar farm, sorry, an Ethereum farm. But we were using about 100k euros a month on power, even with the 3 to 4 cents we were paying that year. So luckily I sold it, otherwise we would be bankrupt now. The problem now is, of course, with the instability, with the war in Ukraine, the prices will go more and more and more. We actually saw a peak price of about 75 cents for 1 hour a week ago, when the war, or 2 weeks ago, when the war started. So you're paying over $1 per kilowatt then. There is not much we can do. What happened the last 4 or 5 years is all the miners left. They went to locations where the power is cheaper. You have some data center in Belgium, they were still okay, but everything gets more expensive there, and I don't see this being resolved any day soon. And there's not much we can do with the government. We can email them, ask them for a rebate or anything else, but that won't happen. So the only thing we can do is take control in our own hands, and we will try to get every kilowatt we produce more than our own usage during the daytime, we will get back for free at night. So if we just increase the solar capacity, we will have zero energy use. That's our main goal. But for now, it's just it's extremely difficult. And I see the prices going up, the gas price going up, the gasoline prices going up, electricity prices going up. I don't see that ending anytime soon.
High prices is not necessarily a bad thing, right? It kickstarts an innovation cycle, so you have to be more wise on how much GPU power is left there sitting, not working, right? So I just see it's just a natural cycle of crypto markets, of, you know, of how they work. So I think it's a really good thing.
Yeah, and I think it will also spur more companies to become completely vertically integrated, not only looking at off-grid energy sources, but also being able to take direct advantage of government credits, which is the only way that it works right now. And so a lot more people will be investing in building large-scale renewable facilities so that they can get those credits directly, and then that helps manage the energy price. Even in the United States, in many states, that actually means your energy prices are negative and you're being paid to use and create that energy. So in the end, that's why I say I see this entire industry, the mining industry, as one of the most incredible partners that the government should be looking to help finance getting to our climate goals, because we're able to build much more large-scale renewable energy and nuclear facilities because it can be financed through the crypto mining, whereas many other industries are not investing in that. You see a lot of, you know, Facebook, Google, Amazon, large-scale data centers that are just being plugged into a fossil fuel mixed grid, and that's what it is, and they're happy to plug in and just do that. But the development of renewable energy, because of the way that especially Bitcoin mining is incentivized, makes more sense. So we're spending the money on renewable energy facilities and nuclear facilities because the grid and fossil fuels don't make any sense.
You heard it here first. Filecoin storage providers and mining operators are driving the grid to a decarbonized future. With that, we have to close, but thank you all for a great conversation. Thank you to the panelists. Fantastic. And I believe we're taking a 10-minute break? No, just very, like, few quick minutes. 5-minute break.
Hi, everyone. If you guys could come back to your seats, that would be great. I know the break was a bit short, but our next session is about to start. Yes. So if everyone could just start coming back. Slowly but surely, yeah. Yeah, slowly but surely. Everyone, could you please come back to your seats? Yeah. In the middle when you're live streaming. Yeah. Yeah, that's what I realized then. I was like, they don't need to see. Yeah, no, they don't. I mean, we still see you on the camera. Hi, everyone. Could you guys please start coming back to your seats? Yes. You're our first. Yes, yes. Everybody, please start making your way to the front. I can't whistle. That's about it. I can't whistle. One more time, can everyone please start coming back to their seats? Yeah? I promise the next session is interesting, so we want everyone to be able to sit down and hear what our next speaker has to say. Okay, yes. Everybody, can you please sit down so we can start? Yes. Okay. Hi, everyone. So I wanted to introduce you to Beltran Barrocal. I can't roll my R, so I'm sorry for that. And he is the co-founder of Zero Labs, which is an integral part to Filecoin Green, and he'll be talking about everything about Zero Labs. So, Beltran.
Thank you. Nice. I need to roll hands. All right, so thanks for having us today. And we are going to talk about how to fight climate change with non-visual NFTs. I had to add that because a lot of people think we are doing visual NFTs, like art things. And decentralized technology. And we've been working on this for a couple of years, more or less, 1.5 years. We started, it was a project that started at Energy Web, and Wendell will tell you more about Energy Web later. And our co-founder, Doug, that spoke this morning, he also helped put out the Crypto Climate Accord, and together we worked on this project for Filecoin while at Energy Web, and we decided also to spin it out as an official startup to accelerate on some fronts. But it's worth to mention that Energy Web facilitated this project at the beginning in a different way. At the beginning, it was for large market operators, and today we are more focused on crypto. But let's jump onto that. If you're here, you know what the problem is. So I'm just going to paint broad strokes. Like 80% of the global energy still produces the 73% of the greenhouse gases that we put out. And of course, there's nuances to this, but it's a useful simplification. And our mission is to bring those numbers to zero, right? That's why we're called Zero Labs. And what do we do and how do we do it? This is the only slide I will kind of read. We use tokenized renewable energy certificates as NFTs, non-visual NFTs, making them a Web3 building block that powers the programmable decarbonization revolution, enabling businesses and individuals to easily buy renewable energies and transparently prove it. It's a mouthful, so what I will be doing is unpack a lot of these little things. So we tokenize renewable energy certificates. A lot of people in this space, you guys probably all know what a renewable energy certificate, but for the benefit of our larger audience and the posterity, we're going to explain, because people think, yeah, they are kind of carbon offsets. I know carbon offsets, but there's a lot of a misconception about them. So to reiterate also what Doug said this morning, renewable energy certificate for us are the key to changing electricity-related behaviors, okay, green behaviors. And to explain how they work and what they are, so one renewable energy certificate represent that 1 megawatt hour of green energy produced by a renewable power plant has been put into a specific grid, okay? And this is already one of its limitations. The 1 megawatt hour doesn't allow for the granularity that somebody else was speaking earlier on, like the hourly level or the households, etc. Because 1 megawatt hour, just to put it in context, is kind of 1 month of a US household. 3 months of an European, just to balance out, okay? And just to understand, a renewable energy certificate is this, it's a PDF, okay? It's a PDF that proves that a certain amount of energy was produced, and it has different names, and there's different standards across the world. The real name would be Energy Attribute Certificate, but as a company, we want to promote the use of the more readable and understandable name Renewable Energy Certificate, which is the standard the US uses also. But as a general name, we would like to call them, because they are self-explanatory what they are. And so it's a complicated market. These PDFs are created also by these registries. Across the world, there's different registries. And they are the only way to prove that your energy is green. This is a normal misconception. Every time I try to explain it to people, they say, yes, but I don't know, my country is 30% green, that means that I'm 30% green. No, statistics and math, it doesn't work, you know? So only these 3 people or these 3 households can say their energy is really green because they have the proof. And if everybody asks a proof, there will be a moment in which there will be no proofs to give out. So some people will not be able to even say like 30%. You can distribute that, but it will never get to exactly everybody being able to say 30% green. And I like to make the difference with carbon offsets. We've been talking about carbon offsets, and people think and know about carbon offsets. Don't misunderstand me. I think the both instruments, both tools are needed. I see them as brother in arms in the battle against climate change, you know, on different fronts, like the Navy and the infantry. We need both tools, right? We are biased for electricity, is a less known product, but I think it's a tool, or for me, it's interesting because if carbon offsets, maybe people don't know what a carbon offset is, but it's another certificate that proves that a certain amount of greenhouse gases has been reduced or not emitted or captured by an environmental project like a forest somewhere in the world. And that separates the action between the consumer of the electricity, the consumer of the impact, in this case, like a large company, and the activist that produces the benefit for the world. While in renewable energies certificates, they are actually the same person. The consumer is the activist because they are proving that their electricity is green. And that creates incentive to more renewable energy. And that's what the ultimate goal is. There's a sub-problem with the rec industry. It's gated. It has been built up for just the large companies, not their fault. Is like the industry is built around large numbers, large processes. It's slow, like procurement processes takes 6 months, invoices, it's super slow, right? It's disconnected, all live in siloed databases, which makes it difficult to validate, verify transparently. So we're doing the total opposite thing. We are making it easy, fast, digital, liquid, permissionless, and programmable, all the cool things about the crypto space. We are adding on top some proofs that the community can visualize the proofs that are going to be built on the blockchain. And we are enabling permissionless innovation on top of this Web3 building block. We're going to see this. So other part of that mouthful sentence, we tokenize REX and turn them into non-visual NFTs. This is the interesting part. Like a certificate is an NFT. And it's probably one of the most useful examples of what an NFT is. So it's a green NFT that represents that 1 megawatt hour has been put into the grid. It's recorded on the blockchain. As an NFT, you can transfer it off, of course. It is of a standard that you can also fractionalize. So you can go down to the watt-hour level and start accessing or giving access to smaller buyers. You can do a bunch of things like composability, programmability, and it has this special property being a certificate that it can be locked, that only a final buyer will be able to say that sustainability claim, you know? So this is a difference from normal visual NFTs, if you want. That means that NFT will not be transferable anymore. We enable others to transparently prove it. This is what I was saying. We built some tools, for example, to show that the transactions that this NFT has been transferred and claimed to the name of a certain person or individual. And this, for example, is a story of one of the Filecoin storage providers. We've been working with them to decarbonize. In this case, for example, FileStore, Miner, F01, etc., bought 168 megawatt hours up there of iREX, this standard that is international REC for across the world, in China in this case, at a rough $1.1 per megawatt hours. A lot of people don't know the price. The prices vary across the world. They spent a total of 185, and this was for Q1 2021. It's important that there is that trackability across time again. All these data are inserted into this fancy page. That is one of the pages that we have in our site, one of the proof. This is very technical, so we are also building some instrument and tools to enable the radical transparency and auditability. I started my path into crypto fighting against the fact that when you try to look into the transactions, it's really not that transparent if it takes you 3 months to understand stuff. So we want anybody to be able to do it, to verify the information by themselves without having to go down the analyst, data scientist path. Okay, so this is a path from the contract to the certificate to the proof, etc. And we are exploring new ways. We are unveiling today some scrappy things like in the classical lean startup, we are unveiling some scrappy alpha version of a new proof page because that is very technical. We want it to be more human readable so that everybody could show it. And just to explain some parts, it's ugly still, but we need to convert the dry numbers into actual impact so that people understand what they are actually doing in numbers or in things that they might be more familiar with than just megawatt hours. We are going to have some behavioral actions, like if you have a streak, you will get rewards or you are incentivized to keep going on this path of sustainability. You will get more information about the generator because some places you are giving more impact to a specific project. As you see, it's all wireframey, classical startup, just to validate with maybe some of you these ideas. And of course, some call to actions. So less is more, but zero is better. This is kind of our claim, if you want. And we are building these proofs on the blockchain. Some numbers about what we've achieved so far, also thanks to Filecoin. We've tokenized 84,000 REX for 15 miners now. But looking at the pioneering effort of, Stephen Aft was saying this early morning, of blockchains that want to decarbonize the history, Filecoin wants to do that as well. It's a shorter history, but still a very good history. And so we are going to work to tokenize almost 1 terawatt hour of stuff on the network. Other part of the story, easily buy renewable energies, and this is where the Filecoin miners story also comes in. Today, if you want to buy these REC, again, it's very difficult. You need to go through loops and complicated markets. We are making it super easy. It will be digital and on-chain. And there's advantages, for example, for the storage providers. Through building the reputation system, or one of the variables of the reputation system will be how green, how many RECs they bought in proportion to their consumption. They might win more bids. So the end game is, you are green, you get more money, you win more storage bids, okay? That's one of the variables, of course, of the reputation system. It has other variables. And we are working also with other actors to try in this effort of proving other blockchains green. It's a challenge. We're using different methodologies. It's a work in progress. But if you want to decarbonize and prove it, we are working on that, so come and talk to us. And Web3 building block, that's another part, and it's probably my favorite. So the idea here is, what happens once you enable developers to permissionlessly create with this thing, this tool? You unleash that potential innovation, right? So we are creating kind of this protocol to enable anybody to tokenize these RECs and to bring them on-chain, and to use these NFTs for anything. In one of the first cases the other day at the Filecoin Green meetup, somebody showed a connection between using the API to view on a map which miners are how green and stuff like that. And it was awesome just to see that innovation in the Filecoin community. And the part is the programmable decarbonization. This is where once you turn sustainability into an item that is programmable, you enable a lot of different scenarios that we're working on, of course, on how to make it automatic so that you don't have to go through the hoops of taking your electricity bill, devising how much energy you consumed, input it into a form, buying the RECs, getting your proof. No, it should be streamlined. I'm doing this behavior, which could be storage providing or mining Bitcoin or anything else that it's electrified, okay? And you would automatically get it calculated and proven and greenified. So this is the direction where we're working on, and please join us. We want you to fight climate change with us. Thank you. Any questions? Any questions? I probably don't need this. Do I need it? No. Yeah. I don't know. It was handed to me. Questions? Thoughts? Yeah? Thank you. I went super fast, probably.
So with your RECs being transferable, how do you avoid like an ultra-speculative marketplace popping up?
Okay, just for the audience, with the RECs being transferable, how do you avoid a super speculative market popping up? Yes, that's actually a good question. Right now, we are basically claiming for the end user directly in the case of Filecoin miners. So this phase here, we are not yet enabling others to transfer them. But if it's permissionless, in one day you will probably have those players in place. I don't know, you need to avoid it. If there is speculation, it's probably good for the environment because you're capturing these certificates and there will be more demand for them, maybe. That's, of course, to be seen. You still want them to be cheap, but right now, for example, they are too cheap to constitute a real tool for helping the return of investment on small buyers. One thing that I forgot to say is that we are working to enable small sellers, those that has panels on their roofs, and small buyers, those that buy less than 1 megawatt hour or that consume for electric devices, to be able to buy this amount. And so these people need fractions and digital speed, if you want, and automatic. Yeah, I hope I answered. Yeah.
That fractionalization, component, what portion of the industry do you think that represents long term? Not here and now, but if you are able to build these components, what do you think it'll be in 5-10 years?
So our assumption, like startup we need to validate, of course, is that it will be the majority. Like right now, the industry has been set up for large buyers, okay? But the real potential is for the individuals out there that want to decarbonize small fractions of their operations. I want my household, my activities to be green, okay? For each single activity maybe, or for the whole of my impact. And I want a simple, automatic way. I want a sustainability dashboard. And we have that vision also that companies will want that sustainability dashboard. So we believe it will be the majority. Thank you.
There's a note for you. Just make sure you hold the mic up.
Perfect. Thank you. And we're rolling right into our next talk. Coming up on stage next is Wendell Cathcart from Energy Web to talk about advancing crypto ESG reporting with green proofs.
Great. Thank you, everyone. And before I start, thanks again to our great hosts, Protocol Labs, for convening us here today. This has been very heartening to hear from everyone. We all have our hearts in the same place, clearly. And I love to see how our community is so strong that, there's multiple people who've worked together at Energy Web and are now on other teams and in different across this space, and we're all doing such great work. My name is Wendell Cathcart. I lead the delivery of some of our projects at Energy Web that focus on decarbonizing the crypto space. And I'm helping, today I'm excited to talk about Green Proofs, our solution stack for advancing some of the components of the disclosure space today, ESG, and also the proving of these individual credentials as they exist. So just a few sentences on who we are and kind of how we've gotten here. So Energy Web is a global nonprofit company that builds open source software for some of the largest energy companies in the world to help decarbonize. And a key component of the Energy Web stack itself is the public Energy Web blockchain. So that clearly puts us at this nexus between the crypto and the sustainability space that we leaned into very firmly about this time last year with the launch of the CCA. So this is something that Doug, who spoke earlier, was crucial to launching CCA. And there are multiple members of the CCA present today. So it's a really great thing to see everyone get to meet some people in person. CCA is a Paris-style accord from the industry itself to help make crypto more sustainable and go carbon neutral. So there are over 250 supporters of the CCA, and about half of them have signed on as signatories who have pledged to go carbon neutral with their electricity consumption by 2030, which is a really aggressive goal. And we are seeing a lot of opportunities to lead not just the crypto space and going carbon neutral and carbon negative, but also setting an example for how we can, how other energy intensive industries can follow suit and not just lead from the industry on how to go in this direction, but also to prove using some underlying unique technologies and blockchain native approaches. So, this 2030 goal is aggressive, and it's actually, frankly, pretty difficult. So this is crypto specifically is a space where the term and definition for what it means to be sustainable or carbon neutral is actually not as clear cut as you would think, and there aren't necessarily universal standards for what this means. So I'm not trying to pick on the CCA signatories or the crypto space specifically. This is actually a more general challenge. Meeting improving climate progress is tough. And a lot of it has to do with those fundamental definitions for what is sustainable. What does it mean 2022? What does it mean in 2030? What are those kind of pathways? What do they mean? This is prohibitive for many companies because of this ambiguity. There's high costs and complexity to complying with sustainability in the crypto space. And as I mentioned, this goes beyond crypto, so there's a good opportunity for leadership here. And then there's a fundamental information asymmetry that is present in the crypto or the sustainability disclosures that companies make. So, oftentimes these are PDFs on websites that, serve a purpose, they're important to an extent, but then there's, the public is missing fundamental verifiability of what it is, at the base here. What is it that, the process that was undergone by, oftentimes consultants in collaboration with the company to prove and say these things. And so, we think that this is a trust, don't verify process, generally speaking, these days. And, I think you can see where I'm going with this. This is Web3 tech, Web3 mantra, verify, don't trust. And so that's really where we're headed with the green proofs approach at EnergyWeb. So green proofs, generally speaking, is a technology stack that enables industry players, in crypto and in other industries, to be able to prove the sourcing and sustainability of their energy procurement using self-sovereign digital identities. SSI and DIDs are the kind of SSI speak for what I'm describing here, to be able to make claims and prove in a verifiable by the public way their operations. And we see two major approaches to the challenges that I just described. So this is to empower the industry themselves to define sustainability and to have a governance scheme moving forward. So, what does sustainability mean in 2022 for a crypto sector? What does it mean in 5 years? Should this be a dynamic and self-governing approach that allows this certification, for lack of a better term, roll with the punches and change as needed? And is this a way that the industry itself can self-regulate in a verifiable way that has inherent trust and trustworthiness? So these clearer definitions for what it means to be sustainable, lower cost, complexity, can result in broader uptake in an industry and progress in an industry. And then this governance itself can be actually defined at the industry level, but actually can map down to the companies themselves. So individual green proofs about a company's procurement practices will actually map to the industry-wide standard. And then we see crypto as a fantastic incubator for this type of approach. So cryptocurrency miners have hashes, have blocks, have things that are inherently verifiable and tie into energy consumption, as some of the previous speakers have discussed today. There's also these, they're forward-thinking, cutting-edge technology companies, blockchain native, and they actually, are motivated to make changes here. But as I mentioned, the green proofs approach is generic enough to apply to other industries as well. And then back to those verifiable reports, the PDFs in today's paradigm. So we are taking a Web3 approach to the idea and the technology behind disclosures in this space. The public is a key stakeholder. Everything should be verifiable, public key-based signatures, clear governance that should be consumable by the public. And how we get there is with trust primitives. This is, the underlying decentralized self-sovereign identities that are making claims about the company. These could be different business units, they could be employees, they could be devices on the edge, they could be third-party auditors and sources of information. So, we're really trying to meet the industry and the companies where they are. This isn't trying to ask companies to go so far beyond their comfort zone. And what results from this approach is a bottom-up and privacy-compatible way of showing progress for a whole industry. So, if you have multiple companies that are in the mining sector that have proven their sustainability and their adherence to certain standards, then you can actually add that up and show real progress at the industry level. But again, we're not asking for private information that shouldn't be disclosed to be disclosed. So I'll get back into maybe illustrating how Green Proofs works conceptually by talking about trust. And give a really simple example of a trust triangle that some people have actually probably already done today, maybe multiple times today. So this is the latte example. How do you start with a credit card, end up with a latte in your hand? That credit card is issued to you by your bank. It's physical. It goes into your wallet. And you present it to, let's say, a barista at a point of sale. And it doesn't end there. The barista verifies your credit card information using a protocol. And then you receive a good or service. And so there's actually quite a lot of trust that went into this process. And it was transitive. So you received a latte because of your bank issued you a credential. There's so much behind the scenes here that I don't and can't really get into because of just the immensity to it. There's a huge centralized network of organizations, government entities, banking organizations, and then regulations and the court system behind them. But this is all the governance layer that took part in this trust triangle that enabled you to have this very smooth user experience of buying a latte. So I'm going to generalize how disclosures work today, generalization, and how there's a trust gap that emerged because of the fundamental design here. So just starting again on the left, we have a consulting company generally that was hired, commissioned to create a report about a company about their sustainability, the procurement of renewables. And these are done by lots of very smart and talented people in the space. And they essentially are hired to be able to say something credibly about this company. So here's Acme in the center here. And what this company has done is the consultants issued them a credential. The companies actually placed this on their website to be consumed at will by the public. This isn't something that they're having to display, it's just kind of on display. And the public is really left with just that PDF in their hand. They can't go so much beyond verifying the data that went into it, the process. There's a lot of lack of governance in this layer here because the reputational, the reputation of the consultants and the company are really kind of on display. And there's a fair amount of change, potential for impermanence in the actual underlying governance and processes, and even organizations involved here. So this company might be using a different different organization year to year to produce this report. So there's a real problem here. I think that it should be clear, and we have, an approach that that tries to get back to some of the assurances of the previous trust triangle. But it doesn't have to reintroduce those intermediaries, those years and centuries and legacy organizations that is, the banking and credit card network industries. So just starting with the bottom layer here and thinking about governance. So using a public utility layer like the Energy Web Chain in this example, where there's a censorship resistance and just public access by anyone. You can embed self-sovereign digital identities in an identity registry that can then serve as a sort of key store. This is a key store by which the different parties can then validate things that they've said about one another. Who are the issuers in this example? So we have, as I mentioned, those maybe business units, employees, and third-party companies that are involved in the operations of the company, the subject of this credential. They issue information about the company to the company, but it's not just like text or emails. These are signed messages that follow clearly defined credentials that add up to a whole. This whole is greater than the sum of its parts. These things are, you can think of it as a hierarchy of claims that result in the replacement for that PDF, what we're calling a verifiable presentation. That's SSI speak. And what that is to the public is a document that could be, again, published on a website. It could be accompanied by a pretty PDF. There's all sorts of ways we can make this very easily digested by the public, but there's fundamentally just leagues more trustworthiness and verifiability in this type of verifiable presentation that's composed of these smaller claims. And we're not saying that there aren't going to be consultants and third-party data providers and these types of specialists involved. They will be involved, and this is actually going to look different from an industry to industry, even company to company. But again, this similar model with these credential definitions, these different roles and how they add up to a larger presentation, this can actually be standardized across industries and agreed on by a consortia of companies in these different industries. So here's a way where we can actually have more self-governance by industry players in a transparent way, involving NGOs, involving different specialists to lend real credibility here, but without the need for, let's say, public intervention in the case of crypto and all the attention it's getting right now, or a more burdensome or centralized governance process. So I won't get far into exactly what self-sovereign identity means. I encourage everyone to learn about it. It's a really interesting, exciting new space that we have implemented some of the standards of the W3C standards at EnergyWeb by our SSI team. And essentially, we are building everything with SSI at our core. It's in our DNA as a company. It's in all of our products. The green-proof solution that I've described is an implementation of all these technological primitives that I kind of outlined. And here we have, again, the verifiable presentations, which is that kind of sum of the parts deployed for a specific industry, in this case, crypto. So we love to engage with industry players. We would love to work with any one of you. Please do reach out, read up on us, read up on SSI, and let us know how we can work together.
Any questions? Nothing for Wendell. Oh, there we go. Here we go.
Can you talk a little bit more about? Can you talk a little bit more about your timeline for EnergyWeb and for green proofs?
Sure. So we actually have implemented the full DID wallet, but we haven't deployed it yet. It's still kind of in a beta phase now. So from a technological standpoint, we are on our track to, I think, in Q2 to open source that, have essentially all the fundamentals that we need for this use case more broadly. But meanwhile, we have multiple parallel business streams looking at different industries, seeing how we can meet businesses, where they are with these needs. And so, there's a whole lot. I mentioned governance a number of times. That is huge. Like, technology is one thing. It's hard. Governance is really hard. Community building, getting everyone to work together is tough. So, yeah. Hopefully that answers your question.
Anything else? There we go.
Are your SSI or DID things really portable?
Sure, yes. Yeah, so it's actually all role-based. Currently there's on-chain roles that are publicly viewable by anyone, but then there's also stored on IPFS, but we could clearly use Protocol Labs. In fact, we've done a lot of, not Protocol Labs, Filecoin. We've done a lot of thought on how that would work. But IPFS is, the off-chain, more private credentials.
Awesome. Well, thank you, Wendell.
Great.
It's been awesome.
Thanks, everyone.
And we're going to keep on rolling. Up next Oh, we need to get it set up real quick. But up next is going to be Paul Gamble, CEO and founder of Nori, the carbon removal marketplace.
Hi, everybody. My name is Paul Gamble. I'm the CEO and one of the co-founders of Nori. We're a carbon removal marketplace. We've been around since 2017, and we are headquartered in Seattle. And this talk is going to be about how carbon offsets actually work and how they're created, because I think that there are actually quite a few misunderstandings out there about kind of the way that the industry has worked and how it should work going forward. So I want to bring us back to kind of first principles question, which is asking, how do we actually solve climate change? Well, the problem itself is that there is too much carbon in the air. There are too many greenhouse gases, and they've been emitted because of burning fossil fuels. We all know this. But I would suggest that the metric that people often look to is the 1.5 degree or 2 degree temperature targets that the UN is setting. And I think a more useful metric would be measuring the amount of atmospheric carbon concentration. And today that's at about 421 parts per million. When I was born, it was 360. And what we should be trying to do is getting back to 300. 300 ppm was about the level that it was at prior to the start of the Industrial Revolution. So in order to get back to 300 ppm, we have to emit less, decarbonize, and remove the rest. Because even if we were able to magically wave a wand and turn off all sources of carbon emissions tomorrow, there is still far too much carbon in the air. We have to remove it. Now, people have approached this problem in the past with offsets, but I just want to kind of distinguish the different types of offsets that are out there. So there are projects that reduce emissions. There are projects that avoid emissions. And what's unique about these is they are only dealing with future emissions. So they're saying, as a result, is it falling out? Is it flickering? Yeah, okay. As a result of, still going. As a result of doing these projects, there is less carbon going up in the air than would have happened otherwise. And then there are removals, which are projects that actively pull CO2 out of the air and sequester it in the earth somehow. Is it still going? Okay. All right. Hope that works. All right. Well, historically, the vast majority. Okay. All right. We'll pause. To our regularly scheduled programming. So historically, the vast majority of carbon offsets have been reductions and avoidances. Very, very few of those have actually been carbon removals. So in order to actually solve climate change, we have to massively scale up the carbon removal industry in order to get back to 300 parts per million. Fortunately, there are a lot of different ways that we can pull carbon out of the air. There tend to be nature-based solutions, things like planting trees, growing kelp, soil carbon sequestration. And then there are more industrialized applications like direct air capture and carbon-negative cement. And the trade-off is the nature-based solutions are much more scalable and much more affordable today, but they're much more difficult to measure. And the industrialized applications are a lot easier to measure, but they are not ready to scale because they're still extremely expensive. The other good news is there is broad commitment out there from Fortune 500 companies and so on to move beyond reductions and avoidances and moving specifically into carbon removals. And if there's anything that you take away from this talk today, what I really want to land with you is that this is a supply side problem. This is not a demand side problem. There is far more demand out there than there is supply available. So we need to be approaching this from how do we remove barriers to entry on the supply side of carbon removal. So how do we do that? Well, you pay people. That's the simple way that we always know works. You need to create financial incentives for people to pull carbon out of the air. So I want to detail how this has been done in the past. So there are a number of different private nonprofits that are called carbon offset registries, like Verra, Gold Standard, and Climate Action Reserve. You can think of them like certification bodies, and they maintain databases of serial numbers representing different carbon offsets. And in order to create a carbon offset project, first you have to develop a protocol. That can cost a lot of money. You have to get the project validated, so you partner with environmental scientists who can come in and basically create a model that tells you how much carbon is part of your project. And then you go do the project, and you get it verified by another third party, and they're checking to make sure that you're actually doing it. And then at that point, the registry will issue the carbon credits to the project, and most of the time they'll sell those to a broker. And then that broker will go try to find a buyer, and then that might be another broker, and then they might sell to another broker. And so the carbon credits can resell many times over. And then maybe sometimes, it's probably about less than 25% of the time, carbon credits are retired, which means you pull it out of circulation, you say this is no longer available for resale. When I got into this in 2015 and 16, I wanted to understand how big is this market? Like how much are people paying for carbon offsets? And this is a screenshot from a report by a group called Forest Trends. And they put together an annual State of the Voluntary Carbon Markets report. And I was looking at this in 2016, and my first thought when I saw this chart was, they broke this up into primary and secondary sales. What the heck is a secondary sale? And it turns out that's from carbon credits reselling. And the other thing you might notice here is that the secondary market is much larger than the primary market. And that's because of the resale. I don't believe that carbon offsets should be traded. If we're going to be serious about dealing with climate change, we should be designing our systems so that every new dollar spent results in net new carbon that's coming out of the air, not pushing pieces of paper around and enriching middlemen. And then lastly, carbon trading is full of fraud. So this is a screenshot from a case in the EU exchange trading system, but also I think the more notable one is the Chicago Climate Exchange, which about 10 years ago collapsed. It was an attempt to build a market for soil carbon trading in the US. And what would happen is you would have related parties doing off-book swaps with each other. So you say, I'll sell you credits at $1, you sell them back to me at $1.25. And we're going to mark to market as if they were actually bought and sold at the prevailing market price of like $14. And then you get analysts and commodities traders looking at that and saying, look at all this trading volume happening. This is a real investable commodity. It was a farce, and it collapsed underneath itself. So what is the result of this? How does this whole system work? Well, you get a system where project developers are paying a lot of money just to certify their projects. That doesn't include the capital expenses or the operating expenses to actually do whatever it is that they're doing. And carbon removal specifically is often more expensive than carbon avoidance, and they can't get past this barrier to entry. And then credits are sold and resold many times over. And if you look at the total amount of money that is spent on the total lifetime of that carbon credit, very little of it, maybe 10% or less, actually ends up in the hands of the original project developer. And going back to what I was saying earlier, like we need to be creating more financial incentives for the supply side. And right now, all we're doing is enriching middlemen. And then I think even worse is the resale opportunity here means that you can have like oil and gas companies buying up a bunch of cheap carbon credits, making some PR announcement about it, and then when no one's looking, they're holding them on their balance sheet, and then they flip them later on. And then do they really get to take credit for it? Like, of course not. And it doesn't actually do anything for the amount of carbon in the air. And there's no transparency on this. We don't actually know what the carbon price is because all of this happens behind closed doors facilitated by brokers. So that Forest Trends report, it's a self-reported survey, and we're only getting data from the biggest companies in the world because they're publishing environmental reports for their shareholders. We don't have insight into transactions that are happening at small scale or between small businesses and that sort of thing. And the worst part about this is the offset registries have zero incentive to change any of this. One, they're nonprofits, so they don't have the financial incentive to scale up. And two, in a supply-constrained market, they're deriving all of their fees from the supply side. So they charge registration fees, listing fees, transaction fees, and consulting fees. So they're making money off of this. They have no reason to change. So here's what we should do differently. First, carbon removal should be prioritized over carbon avoidance. Market forces are already pushing us in the direction of the emit less part. It's already cheaper to build new renewable energy than it is to maintain existing coal power plants. Second, carbon credits should never be sold more than once. They should be retired immediately upon sale. And the sale should happen in an open, transparent way where we can see everything like who did the removal, when and where it happened, who measured it, and how it was verified, and what the price was paid and at what volume. And then lastly, we still want a tradable commodity asset for price discovery. It's important that we build a global commodities market for carbon, but it should not be the carbon credit itself that is traded. We need to have a secondary asset to represent that for price discovery. So that's what we do at Nori. We are a marketplace that connects suppliers of carbon removal with buyers who want to be carbon negative. We partner with third parties who do the carbon quantification to dramatically reduce that cost. And then third parties come in and do verification to ensure that the carbon removal actually happened and continues to stay out of the air. The product that we sell is called a Nori removal ton, or NRT. One NRT is 1 ton of CO2 that's been sequestered for at least 10 years. It's warranted to the buyer for 10 years. And this is interesting because if you're like a big enterprise company and you're buying carbon offsets, you often actually see this as a liability. Because let's say you buy a bunch of forestry credits and then that forest burns down or gets harvested, you are going to get destroyed in the press. This has happened many times. And so what they do is they put an enormous amount of effort into diligence by hiring a ton of consultants and finding these brokers who can source high quality projects for them. And all this is doing is driving up transaction costs and again, making it more difficult for new market entrants to come into this space. So our solution is to offer a full 10-year warranty. If we discover that carbon has been lost, we will buy new NRTs on your behalf. And all of these have been verified via our peer-reviewed soil carbon methodology. And when the NRTs are sold, they're immediately retired. We actually record these as NFTs, and once they get transferred to the buyer, they're made non-transferable. It's there forever. Now, we are agnostic to the different ways of carbon removal. I want market forces to figure out what is the most efficient and effective way to pull carbon out of the air, but we had to start somewhere, and we focused on regenerative agriculture because of the enormous potential for scaling. All told, around the world, you could remove about 5 billion tons every single year, which is 10% of our global annual carbon emissions. And the way this works is farmers will do things like reduce the amount of tilling. This is called no-till. They plant cover crops, so they're keeping roots in the ground year-round. And they're implementing more complex crop rotations. And in the soil itself, what's happening is they're doing these practices that increase the amount of organic matter that's growing in the soil. And the organic matter is the carbon. And when they adopt these practices, over time, not immediately, but over time, they will increase their crop yields and they will become more resistant to drought and flood. So it's to their benefit to do this, but they need bridge financing to help get them over the hump, and that's the role that paying for carbon storage plays. So this is Trey Hill. He was the first farmer that we worked with. He's in Maryland. He runs a 7,000-acre soy, corn, wheat farm. And he sold about 14,000 tons. He made about $210,000. And he only paid $4,000 for verification, which is about a 90% reduction in cost relative to what he would have had to pay by going through the existing offset registries. Now, I mentioned earlier that we need a secondary trading asset for price discovery, and that's the role that our Nori token plays. So we've been around for almost 5 years now, and we took the approach of let's build the carbon side of the business first, prove the concept that we have the ability to measure and verify the carbon, and then let's finally launch our token for price discovery. And the way this works is one Nori will always be able to purchase 1 ton. The price of Nori will float relative to supply and demand. So in the same way that like if you want to know the price of oil today, you look at Brent crude or West Texas Intermediate, they're reference prices. We want the Nori token to be a reference price for a ton of CO2. So in fact, oftentimes we're compared to other carbon credit companies, and we do that, but this is the purpose. The main goal of Nori is to create a price discovery mechanism for carbon. You can learn more about that at nori.com/token. We're going to be launching this finally in a few months, and I'm really excited about that. Since we launched in 2019, we've accounted for about 76,000 tons of CO2 that have been removed. Buyers have paid a little over $1.4 million to farmers, and we have several thousand customers. And you can think about what we're trying to do long term as being like Stripe, but for carbon removal. So an API that can be integrated into any sort of platform or protocol where carbon removal just becomes invisible and automatic in the background of everyday life. We've lately been partnering with a lot of NFT artists, in entertainment industry, NFT marketplaces. About 25% of our sales are going through crypto and Web3 platforms. And we're seeing more, like there are some play-to-earn games that are putting a portion of their profits towards buying carbon removal. That's how we scale this up. I don't think it's driven by Fortune 500 companies. I think this is much more of like a grassroots, like new economy type of solution. So that's it for my slides. You can find these at go.nori.com/how offsets work. You can go to nori.com yourself, and if you want, you can pay for removing the emissions of the flight that you took to get here to Austin. And you can find me on Twitter at Paul Gamble. Thank you. Yeah.
You said that you give the NFT to
the buyer, yeah.
To the buyer, and it's not transferable anymore.
Correct.
How do you deal with buyers that don't have an NFT, an Ethereum account or a crypto account?
We'll just make one.
And you hold the keys for them?
Yeah. It's actually not really a big deal. Most of the buyers don't even care about that. What they want to see is a dashboard that can display like the certificate of what they want. And so on the certificate, you can go and see like literally the map of the field where the removal took place. You can read the verification report, learn about the farm. That's what's far more useful for our customers because they need to be able to show that to their own consumers.
Okay. Yeah. Mm-hmm. So there's no demand for holding these.
So, some people do that, but if they do that, then they're capable of creating their own wallets.
I have more questions, but I don't know if I should.
Yeah.
I was wondering if you could talk a little bit more about additionality as it relates to ag removals.
Sure. Yeah, so in carbon offsetting, there's this concept of additionality. And there are actually 2 different additionality tests that are applied in the legacy system. So the first is the question of incremental carbon removal, which is relative to a baseline, is carbon being avoided or removed? And so the way that we do that is when we're collecting operating data from farmers, we're looking at what year did they make the practice change switch from heavy tillage to no tillage, or they started planting cover crops, and then that sets the baseline, so we're measuring relative to that. And then also in the legacy system, there is the concept of financial additionality, which is to say, would this carbon offset project have happened if not for the revenue derived from selling the credits? I think that's ridiculous, because that means that only unprofitable projects could ever qualify for carbon credits. And we need to scale this up. So we fundamentally reject the financial additionality test. We don't do that in our market. We think that if people are performing the service of removing carbon from the air, then they should get paid for it. Yeah?
So what do you think of
ClimaDAO? Okay, so ClimaDAO is really exciting because it shows that there's like enormous interest from people in the crypto community to want to use these tools to help solve climate change. However, I think what Klima is doing is causing net harm. Because ultimately, I mean, we have watched the price action and seen that it is not working, it has failed. But ultimately what they're doing is they're purchasing carbon credits coming from these registries that no one ever wanted to buy in the first place. And what it's doing is perpetuating this system. I think that the way these registries are set up is bad. It does not work, and it's preventing us from scaling. And Klima is just perpetuating that problem. So I don't really like the way that it worked, but I do really like the motivations and seeing that there's so much energy behind wanting to use blockchain and crypto to solve climate change.
So you're becoming your own registry?
Effectively, yeah. Yeah.
I guess I'll ask if nobody else has a question. I'm curious about governance.
Mm-hmm.
In the last session, there was a bit of discussion about what kinds of standards should be set from an industry perspective, from a carbon project perspective.
Yeah.
And obviously, you report all your different methodologies, and those I understand are peer-reviewed.
Mm-hmm.
But with nature-based solutions, the science, right, relies on certain assumptions.
Yep.
So how are you able to account for those changes over time? Is there a decentralized governance body that can say, oh, maybe this agricultural type of removal is outdated, or this methodology is outdated? Like, how do you adapt to times?
Yeah, I think, so in the future, we would like to go in that direction. I think there are some incentive alignment problems that we haven't figured out how to solve yet around, like, it's possible to create incentives where people just want to approve all sorts of different methodologies that might not actually have that level of impact. And so we don't want to rush headlong into just like forming a DAO that gets to choose when methodologies are approved. For the soil carbon stuff, we partner with a company called Soil Metrics that does quantification. And Soil Metrics is a spin-out from Colorado State University, and they use a protocol that was developed by the US Department of Agriculture. So this is the federal government's greenhouse gas accounting platform, and that's kind of the best that we can do right now. Yeah?
Are you doing other things right now besides the soil carbon?
No, we're not. Yeah, so we really want to add more, and we've wanted to do that for a long time, but we keep running into different challenges that are kind of out of our control. One is that the more industrialized applications are finding, we're finding that companies like Microsoft and Stripe have basically bought up all the supply over the next 5 to 10 years, and so they're unavailable to create like an actually global open market for that. And then on the nature-based side, like we're really interested in kelp farming and other blue carbon stuff like mangrove restoration and so on. But we've talked to everyone in the space, and no one has, to your question, no one has good enough validated science backing the claims of how measurement and verification would happen, and we don't feel comfortable accounting for that yet. So there needs to be more development in the industry before we can onboard new methodologies.
Could you talk a little bit about how you think, things like a sustainable kind of crypto blockchain, et cetera, fits into kind of a scope 3 SBTI situation, especially, 2030, 2050?
Actually, here, let me share a controversial opinion. I don't think Scope 3 is an effective way of accounting for this stuff, because everybody's Scope 3 emissions are somebody else's Scope 1 emissions. And so that's my short answer. The longer answer is I'm not really concerned about this stuff because everything is already moving in that direction. Like we're going to be deploying, when we finally launch our native token, we're going to be deploying on Polygon, minimal impact. Because of the adoption of renewables and everything that people have been talking about already today, like everything's going in that direction where I just don't think it's going to be that big of a deal long term. Now I do think that on like the carbon side and on the blockchain side, we especially need massive deployment of new nuclear energy. Because I was talking about like direct air capture as an example to remove carbon, and nature-based solutions will not get us all the way. We're going to have to build more industrial stuff. The amount of energy you would need to power that much direct air capture is anywhere from 2 to 10 times the amount of energy that the world produces today already. So that the only possible way that can happen is with massive nuclear deployment.
Thank you, Paul. It's been fantastic, awesome conversation. We are going to move forward with one more conversation with David Dow and Sharfi Adamantane, I believe is how I said last name, from GainForest. We just need 1 second to
Test, test, test. So, hey everyone. We are Shafi and David from GainForest, and super excited to be back in the States to tell you about GainForest, a cryptocurrency to reverse deforestation. So, the natural world is changing in rates unparalleled in human history. This is a quote from the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services of the United Nations. It's a critical statement showing that we have lost half of the world's forests to deforestation since industrial times. This is a humanitarian and ecological disaster. And we want to show you why in the beginning. Deforestation, we talk a lot about afforestation, reforestation, soil carbon, but deforestation is actually one of the major key drivers of the climate crisis. There's no way we can keep up with Paris if we cannot stop deforestation. It's 18% of global anthropogenic emissions through land use change and deforestation. And it's been so bad that the Amazon rainforest last year has become a carbon source instead of a carbon sink due to the deforestation that happens there. And I want to provide you a different perspective on deforestation because we see a lot of the side images, we saw a lot of the pictures of forests and green stuff, but what we care about a lot is the people who live in the forests. 1.2 billion people live in the forest, rely on the forest. Those are the poorest people in the world, in the global south, and they are literally at the forefront of that fight. They die. If you see the news reports of where miners kill indigenous leaders because they want to invade the lands to harvest for gold and resources, this is a humanitarian disaster. Next. So we said we are very glad to be in the States because a couple of our team members spent 2 months in Paraguay. We brought you some pictures to show you what deforestation looks like. On the left side is the national park of Defensores del Chaco, the biggest national park of Paraguay. It's 120,000 hectares of forest. On the right side, Paraguay has sold most of its land, which is not national, to private landowners that
because Paraguay knows only one business model currently, which is the cattle industry, the beef industry. Paraguay is one of the biggest beef exporters in the world, where people don't know about. Much of the land has been deforested. Actually, it has the highest deforestation rate in the world, even before the Amazon rainforest. And you can see here, this small road here separates the national park and the cattle farms, and every day more than 100 of these trucks full of cattle are driving through the streets. These are drone shots we took. Yeah, it's kind of seeing that and realizing the people and the lives at stake. No one's evil here, right? Like, it's a lose-lose game. People who are living in the farms, they earn $100 per month. Minimum wage is $400, but through lobbyism, these farms can negotiate lower prices. It's all because there's literally no ecotourism for these beautiful, pristine forests. There's no way to access them. There's just hardly any options for everyone here involved. So, of course we know that. Of course our governments know that, the Global North knows that, the United Nations know that. So we implemented something called a results-based payment system, which is just a fancy word of saying, when you protect forests and you don't cut it, we pay you, right? Like Paul talked about this. Red Plus, for example, is a fund that initialized $25 billion of money that is reserved for paying conservation of forests. It's beautiful because, like, if you get paid, of course you don't cut the forest, but it's just one problem: it doesn't work. And the reason it doesn't work, yeah, I'm serious, it doesn't work. The reason it doesn't work has only one, there's only one reason for that, which is missing trust. So you see, if you want to get this money, you need to apply for it. You need to self-report how much you conserve, right? And then, of course, someone who self-reports could cheat on the reporting, and people who would pay would be like, wait a second, I'm not very trusting your numbers here. So these funds, usually, you don't get nearly 30% of what you apply, and usually it takes 3 to 5 to 10 years until you receive any of this money. So would anyone quit their job not knowing if their paycheck comes like in 1 month or in 10 years? Obviously not. So this makes these funds inaccessible. So why is it expensive? Paul talked a little bit about this. This monitoring, reporting, verification, because people don't trust people, reporting, monitoring relies strict standards that are so off, like old ages. Basically what you do is, for conserving forest and measuring the carbon, you go into the forest, you measure every tree by the diameter at breast height. So you take a band, you measure the diameter. From the diameter, you estimate the height. So of course, every person is differently tall, so we have uncertainty already in that step. And this whole process costs $35,000. Paul mentioned $100,000. You can imagine, for someone who owns a land and gets a monthly salary of $100, this is their life salary. They cannot afford that. So access to these funds are restricted due to the fact that MRV, monitoring, reporting, verification, is just insanely expensive. So at GainForest, we are AI researchers. We are not necessarily primary crypto. We come from the AI side. And does anyone know who that is, by the way? So we got inspired by reading a book about governing commons. We come from Switzerland, and apparently in Switzerland, even though the nature is shared among others, people are able to still preserve it. Elinor Ostrom, the first woman Nobel Prize winner in economics in 2009, has discovered that trust does not have to come from external sources, but
through the communities.
Yes, trust is a most important resource, and it comes from within the community. But the community needs 2 things for this, and she figured out by studying many, many, many projects, 8 robust design principles. And we can categorize them into simple ideas. We need accountable monitoring. We need monitoring that is trusted by everyone involved. And then we need a system, a governance system that is cooperative, that is sovereign, and that is also legitimate. And we believe that these allow us to combine 2 technologies, even though tangibly, artificial intelligence for monitoring and blockchain technology for the cooperative governance part. And we'll show you in a second why. So there has been an explosion in data coming from the AI side on monitoring in general, remote sensing. We have satellite-based monitoring, we have drone-based monitoring, field-based technology has been advancing. There's even genomic, metagenomic of the soil, analyzing biodiversity and whatever lives inside that soil. And the same technology that tells us that we lost half of the world's forests can be used to estimate the dangers of deforestation globally in the next couple of years and the next couple of months even. We have satellite data currently that is almost on a daily basis. So every 5 days we get a satellite from the European Space Agency with 10 meters per pixel. Every 1 month we get 3 meters per pixel through commercial satellites providers such as Planet Labs. So this data is there. Also, drone-based data has been insanely cheap. This drone costs $500, and it allows us within 10 minutes to map the whole area of here in Paraguay, 1 kilometer by 1 kilometer, with a precision of 10 centimeters per pixel, allowing us to not only estimate the deforestation risk, but understanding the structure of the forest, also estimating the height of the trees. And lastly, we have developed tools in the last 4 years where we also leverage the community-based, field-based data collection. So this is one of the apps we released together with ETH Zurich called Tree App that allows you to take a picture of the app, you hold a credit card in front of it, and instead of taking like a line and measuring the diameter of the tree, we use machine learning to segment the tree bark, the card, and then just do species detection. The same machine learning can be used for detecting animals using wildlife cams. All of that data and all of that technology and machine learning analytics can be used to create an estimate of carbon emissions through deforestation over a monthly basis. Here, this is an annual basis where we show a region. This is the region of the Kayapo we work a lot with. They protect forests twice the size of the UK. So if you would burn down this forest, it would be the annual emissions of the United States. But still, we talk about demand, we talk about supply. They are 10,000 people, they have 11 guard posts, and they still are not able to raise enough funds. Why? Because who would pay 1.6 billion tons of carbon credits, right? It's impossible to verify. So our technology uses artificial intelligence to estimate and show literally how much they are protecting the area compared to the area surrounding it. And we can estimate what we call in carbon science additionality, how much are they actually efficiently performing. And using this AI technology, we can now link it to a financial system that allows us to outperform existing donation systems. And we want to show you how. The video?
The natural world is disappearing fast. Humanity is consciously destroying our planet's life support systems, upon which we all depend, and time is running out. But there is hope. Everywhere, conservationists and local communities are working tirelessly to stop and reverse the damage we're inflicting, but they can't do it alone. So what if we could harness the power of technology to unlock limitless resources for the restoration of nature? GainForest is a cutting-edge decentralized fund. It uses artificial intelligence and blockchain technology to reward sustainable nature stewardship. It works like this. GainForest generates NFTs, unique digital assets that correspond to land areas all over the world. NFTs turn traditional donations into transparent investments. Through smart contracts, anyone can purchase an NFT by pledging a regular donation to protect and restore these areas. The smart contract then safely stores donations in a decentralized fund. GainForest uses satellite imagery, drone technology, and artificial intelligence to monitor the area and tell us whether nature is thriving. As land is protected and preserved for longer and longer, donations will automatically be unlocked and released to the communities that have been responsible for protecting it. Simultaneously, donors are able to trace the impact of donations whilst their NFTs increase in value as habitats are restored. GainForest we'll revolutionise the world of conservation. Together, we can fund the protection and restoration of our natural world, preserving it for us and our children.
Okay, so we've also got a demo up here for you guys. Let me just switch up over here. Everything's still in beta, so things are going to change up a little bit, but this is our project page for Defensores del Chaco in Paraguay, the site that we visited a couple of weeks ago. You see here the land area in question. It corresponds to about 1,000 hectares of pristine rainforest. And you can actually zoom out. This is the what do you call it? The natural part of Paraguay right now. You can see the time. If you zoom out a little bit, this is 2012, and as we keep going, you can see that the deforestation is getting worse and worse over the years, and so we would like to find a way to help the communities on the ground to actually protect these. On the left, you get to see the estimated forest cover. At the bottom here, the estimated forest cover for this area. This is in percentage. At the very top, you see the uncertainties, the high and the bottom of the uncertainty table. And at the red line here shows how much forest cover is necessary for funds to be donated into the communities. So every couple of months, in the case of Paraguay, it is every 90 days, but it depends on each project. So we really try to work with the communities to find out what their needs are. And as long as the tree forest cover is above 75%, we release the funds. As you can see down here, you have the recent wildlife cam. This is we actually planted a wildlife cam inside the rainforest. So you can see all the data is stored in IPFS. So I can take a look at this. And got those tiny little animals.
Yeah, that was just detected 2 weeks ago, so we are very happy.
We're hoping to also increase engagement with the actual rainforest, and so when you actually get to see the animals that are inside this rainforest, you feel it's a form of ecotourism. And you also have the most recent drone image that we found. Everything is stored in IPFS. You've also got the raw data of everything here. It is 30 centimeters per pixel, resolution-wise. And the data is updated every month. You get to see transparently all the funding history that goes inside, and you get to see exactly when the data is released into the communities. If I would like to donate into this project, I could just go here. Click on donate, I need to connect to my wallet. So I click on donate right here, approve my transaction, and transaction successful. So I've donated 1 SOL. If I refresh this, I get to see that 6.683 Solana is locked inside the escrow fund. We've decided to use Solana because of its environmentally friendliness, and all of the funds here will be released after 90 days. These are the funds that have been released, and anything else will be released after we make sure that the estimated forest cover has been, there are no deforestation occurring in this land space. So this way, like I said, the communities know that they will be getting a stable income, every couple of months, and that they would hopefully be earning more money protecting the rainforest than they would if they were to deforest it and make land for cattle farms.
Show the NFTs. I think our time ran out, but I think
true.
that's because our title is Protecting Forests with NFTs. We do want to let you know why this thing becomes now an investment instead of a donation.
So this is an NFT proof of care. Once you donate money into the escrow fund, you'll get an NFT, and the NFT that you get depends on how much money you actually put in. This is the proof of care in February, and you get to see the properties, which are actually updated in real time, how much carbon stock is in there, bird riches, and any other properties that we would want to add. And if you do donate a significant amount of money, then you get a copy of the recent wildlife cam. And you can actually play this, and
yeah, you get subscribed to the newest animal when it detects it's from the wildlife cam. So there's tourism enabled finally in Paraguay.
There you go.
David and Sharfi, your work brings so much hope to me for the future. I could not express my appreciation more for everything you guys are doing. Unfortunately, we don't have time for questions right now, but please, anybody that does have questions or wants to learn more, catch them later on. And big round of applause. And our next speaker is Osho Jha from D-Climate, talking about climate data in the D-Web.
Hello? Oh, there we go. Wow, that sounded kind of weird. All right. Well, thank you to the Protocol Labs team for having us here. Super excited to be here. Hope everyone's been having a great time at South by Southwest and at the Sustainable Blockchain Summit in particular. So my name is Osho. I'm here to talk to you about D-Climate, which is an open ecosystem for creating climate apps. I'm one of the founding partners. And basically, we're looking to solve a lot of problems around climate data. And the reason we think this is important is because in order to build next-gen climate tech products and climate analytics, we need to have better, easier to use data. And so I'm going to tell you a little bit about what we do, how we do it, how we work with Filecoin. But before I go into D-Climate, I'm going to rewind a little bit to tell you how we discovered that this problem even exists. So I helped co-found another company called Arbol. And that's in the parametric insurance space, which is basically just a fancy way of saying data-driven insurance. So instead of filling out a ton of forms, we deal with just data, and we specifically insure climate events. So a company such as a Texas utility company might come to us and say, hey, we're worried about snowfall this year, we're worried about really cold winter this year, so we would like to get covered from January through March for any inclement, like extremely low temperatures that are below the 5, 10, whatever your average they choose. We track that data, and if this event happens, we give them a payout. There's no questions asked, it's all done on data. And so we built this platform using Ethereum smart contracts, and we plug into traditional fiat rails for the clients that want that. We plug into crypto rails for the clients that want to do that. But all of this can be decentralized and is in the process of being decentralized. Now, in order to build these products, we have to have a lot of data. And it's been cool because as we've grown there, we've seen a lot of different industries make use of our products. So originally we started out with weather and agriculture, right? Because there's an intuitive relationship right there. And we found that agribusinesses had a lot of use case for our product. But that same heat data that goes into tracking the progress of a corn harvest, for example, is the same heat data that a power plant wants to track a summer heat wave with, right? So you can see how this extends. And the real key here is that we do it in a hyper-local fashion. So that's where, I'm the chief data scientist there, so that's where we kind of ran into the first problem with climate data, which is it is really hard to work with. And on this slide, we have basically our mandate, which is how are we going to make it easier to work with. And on this next slide here, we have some of the problems that we ran into. So just to keep it really straightforward, you have anything from esoteric file formats. You have data sets that have, no real documentation and or 140 pages of .txt documentation that you're digging through to just find units. What geographic range does it cover? What is the resolution of this data set? That's actually where the domain of climate data does get very interesting. You have so many government agencies across the world collecting this data, as well as nonprofits, as well as academic institutions. But because they're collecting it for their own purposes, everyone follows a different methodology. And you have some data sets that have very high resolution, but only cover like the United States. You have bigger resolution, but they cover the whole world. And then you have some really weird ones that like only deal with ocean or only deal with certain parts of a country, like stuff like that, right? So going back to the product side, we needed to start, consolidating all this data in order to make our product development easier. And we did that for about 3 years, and the product traction grew. We started going into more and more industries and started collecting more data. And what we realized is we are sitting on a treasure trove of climate data, and we should not keep this in-house. This was publicly available data to begin with, and we don't believe in creating moats by charging people for data that was originally free. That's a very, in my opinion, Web 2 mentality. So we decided, let's open source this into dClimate, and let's create an open ecosystem, because if you make the data easy to work with, anyone can start building apps, and anyone can build products that can trace the data over time. And we had a bunch of speakers here today talk about various aspects, such as like reforestation, carbon offsets, tracking miner, carbon footprint. Like, we look at all this and we think it's awesome, and to have the data behind that to track as these things change is very important. So our flagship product, which is currently in a security audit, is the data marketplace, right? So why do we choose a marketplace approach? Well, we work with a lot of free data because it can be agreed upon, and that's helpful for insurance. That's our main kind of business, so that's where our thought process is. But there are a lot of vendors in the space as well. And there's this bigger problem of how do you find the data that you need to work with, right? So I've been a data scientist for 10 plus years. I spent a majority of that time working with large unstructured data sets to basically mine them for alpha to trade various markets. And to be honest with you, working with climate data has been the biggest challenge and the most difficult challenge that I've taken on. It's just really hard. It's kind of hard to even find what data you need. Now, I'm lucky. Like, I work at a tech company where we have the resources to deal with incredible large amounts of data. I also have 2 meteorologists on my team that, if I ask them, like, what's the best data set to track rainfall in Berlin? They know this off the top of their head because they were doing research in this stuff. What's the best data for tracking forecasts on a 15-minute basis in the Midwest in the US? They know where to go, right? But not everyone has access to that. So the reason we decided to start with a marketplace is because it's a way of indexing and organizing the world's climate data, right? So when I say index and organize, the first kind of company that comes to mind is a company like Google, because they're indexing and organizing the world, but or the entire web. But the thing is, the web is a very broad domain. And so in a very specific domain, I actually look to something like iTunes as a great example of how a marketplace is able to index and organize data. In this case, apps. In our case, it's climate data. So we want to make it accessible for anyone to work with. And we are actually focusing on doing this without requiring any particular like crypto payments or anything like that, because the majority of the companies don't want to deal with stuff like that. So we also have a bunch of other projects going on, and a couple of these have been released, and one of them is a sneak peek. The idea here is that we can build all sorts of analytics on top of climate data that can then be monetized, and therefore we don't have to monetize the base data itself, and we can continue to allow it to live for free. So over there on the left, you have a screenshot of a game that we built called Stormbrokers. Stormbrokers is basically like Monopoly, except storms can come break your house, and it uses both historical and simulated hurricane data to do that, right? This is a fun little thing because one of our colleagues is really into indie games, so him and his crew put this together, and it's a great showcase of climate data stuff that's not as grim as the usual subjects around climate data, but it also has an interesting alternative, right? Because we can put a prize pool around there and use this to incentivize and gamify forecasting, right? So some fun things coming from there. On the right-hand side, that's a sneak peek of next-gen carbon offset that's all data-driven that we are hoping to launch in the next month or so. And then front and center is Worksite. So Worksite is a particularly cool example, right? The world's largest construction company came to us to basically ask, how do we assess our construction risk, right? And what we discovered in the process, and this is kind of crazy to me, is that the largest construction projects in the world don't have a way to figure out how many days of missed work they're going to have due to inclement weather. So you have construction managers working on, these skyscrapers or even residential buildings, and they're Googling things like average temperature in July in New York City to understand, how many days are they going to have to shut down their work site. So by taking the available data and giving them a platform where they can then put in the thresholds that they know shut down business, they can see that, okay, I'm going to have 10 missed days during this cycle, or I'm going to have 100 missed days, something like that. So that's a simple example of how analytics are not only helpful on the industrial side, but how the current infrastructure doesn't really have a lot of this tooling available, and people are kind of left in the dark, right? One of the things that we kind of talk about a lot at work is how you can't solve problems unless you can measure them and understand them, right? And I feel like a lot of these simple tools that we build help with that, but on the flip side, it's kind of crazy to me that people are flying blind, if you will. So we have a relatively complicated software stack, and IPFS and Filecoin play a big role in that. So we started, that's right. So we started by managing our own IPFS clusters, and in the future we will be moving to Filecoin Estuary. So we have terabytes and terabytes of data on IPFS, right? And part of this was because if we go back to Arbol, the whole idea was how do we decentralize the whole climate insurance process, right? Well, first step, you have to decentralize the data. But what we learned in developing this IPFS infrastructure is that actually there's a lot of properties to IPFS that make it particularly helpful for climate data. For example, if you have a weather station and they change a sensor on that, they have to go change data in the past. But they don't send you an email telling you that, right? So now you're seeing numbers that change. And that's where the immutability is really helpful. You can go point in time and see what data said at any given time, right? There's also a very important use case around redundancy. So the important thing here is that while our governance runs on Ethereum, it's all open source otherwise and can be implemented by other blockchains and can be implemented by even Web 2. Our API gets about 1 million requests a month and is used by a lot of insurers, a lot of hedge funds, things like that. Anyone who basically wants to work with climate data, and that's been working in stealth mode. So anyone here building climate apps, I invite you to do that. I talked a little bit about the importance of Filecoin in our ecosystem. It's only going to get more and more important. Estuary is an incredibly important tool for what we're building and will help us handle the scale of climate data that we're trying to work with. And then I want to talk a little bit about why blockchain is important in this problem. So blockchains are inherently really good at valuing public goods. It started with open source software. Open source software was originally seen as kind of a hobbyist thing or like a lifelong dedication that you made at the expense of commercial profits. Blockchain kind of turned that on its head. It provided an incentivization layer for open source software that allowed people to engage with protocols and make the development of open source software profitable. We think it can do the same thing with climate data. We think it can do the same thing with climate apps in general. The traceability and verifiability is definitely important. You can track changes over time. This is crucial for any sort of ESG analysis. That's obviously a hot topic for a lot of corporations. So when the Monsantos of the world say that, they're not going to engage in monocropping, how do we track that? When a certain, oil company says that they're not going to drill in a certain area, how do we track that? How do we track deforestation? And then lastly is Blockchain helps us reach a few of our goals, which are around accessibility of data by basically making it easier. That's that marketplace infrastructure, that API infrastructure, aligning all this data. The availability of data, there's a lot of places in the world where there isn't great data collection. This is both the case within the US as well as in other countries. So later this year, we're launching our IoT program, which is in beta mode right now, where users will essentially be incentivized to mine their local weather data. And it's a great way to build essentially the world's largest weather station network. It's a small goal for 2022 for us. And then the last part, and I touched on it with the verifiability, is the accountability aspect, right? Especially with this ESG. If we cannot track the data, then we can never really hold the changes accountable. And that goes back to what I said earlier, which is you cannot solve a problem unless you can measure it and understand it. So that's my little talk here. Got about 2 minutes if anyone wants to ask questions. Thank you. Also, we have these on socks, so very exciting stuff going on, and we'll have some new little climate critters coming out. Any questions? Yeah, go for it. Thanks for not leaving me hanging.
Just sort of wondering, so we have sort of, Web3 storage and measurement. We have the incentive mechanisms, and I mean, sort of an unfair question to levy onto you, but sort of everybody else who's presented and so forth. Like, what are your thoughts around Web3 accountability and making sure that, the shit actually gets done, and like you're not paying for projects which then, the trees get harvested or whatever?
Yeah, so that's a great question. I mean, the accountability comes in two aspects, right? With respect to projects getting done, reforestation, that kind of stuff, that goes back to climate data as a whole. And the way we track our world. So climate data is a very rich domain. NASA's constantly launching satellites, the Japanese Space Agency is launching satellites. We can see how forests are changing over time, and that resolution is only getting better. The general Web3 accountability of, is declimate solving the problem that it set out to solve? I would optimistically like to say yes, and I would optimistically like to say most Web3 companies are. There's a lot of good intentions, a lot of great effort, and a lot of smart people working in this space. So I think things should work out really well. But in the case of declimate, just based on the usage and the traction we've seen from industrial use cases, we think that this is just the beginning of releasing tons of products. And I do think the future of DAOs is very much multi-product rather than a single product. Yeah.
I was wondering, with a lot of the sort of climate blockchain applications, a big concern is the GIGO problem, like sort of garbage in, garbage out when it comes to data. I'm just curious how you guys are thinking about that problem, because obviously a lot of your data inputs are coming from industry. Is that standardized across different sectors, right? They might report differently. Like, how do you account for those? How do you account for that variability?
Yeah, no, that's a great question. So we focus on time series data, and in particular, we look to index data by location and time, which is why we work with a lot of government agency data, like the NOAAs of the world, or BOM, which is the Australian, weather station network. So there, we can be very confident that the input data is good and at least agreed upon, because all industry participants are using that. We tend to stay away from a lot of self-reported data, because the whole goal is to use objective data to track these problems. I think the other way we solve the GIGO problem is, there are kind of companies in this climate space that will do things like clean and fill data, like any missing data from weather stations, but they'll charge you hundreds of thousands of dollars to do that. We give that all out for free. We use AI mechanisms to do all that clean and fill. And by giving this out for free, people can build these better apps. So that's the better input. And the IoT program is another input into that, right? How do we get hyper-localized collection? That only makes it even more direct to communities and locations. Yeah.
The IoT program, do you see like producers being able to monetize, because if the marketplace is there, it's all free for now, but do you see there being like a way for people to sell their own data?
Yeah, we have no problem with charging for data so long as it's unique data. I think it's like unfair to take government data and then we do a lot of work to it, but it's unfair to just like charge people for that. I think we get better outcomes when we allow people to build with that. And it's also a better challenge for us, right? Like, why create a kind of boring artificial moat when we can just create better products? In the case of the IoT program data, this is so localized, and we are essentially paying people to mine their local data, or that's what we're going to be doing, that monetizing that data makes a lot of sense. Yeah.
If no one else has any questions, I have two.
Sure, go ahead.
Real quick. We are setting up for our last conversation.
All right, cool.
We've got a few more. So you talked about all the opportunities, all the applications that can be built. Sounds like that opportunity landscape is very rich.
Yeah.
But I want you to fast forward real quick to 5-10 years out from now. And you all have already achieved everything you've set out to achieve with DClimate, created this unbelievable repository of climate-related data, decentralized. There's tons of applications about it, residing on top of all that data. What is that one opportunity that you are most keen to tackle and seems like the hardest one to tackle?
Yeah, so I guess for me it would be the carbon product. So that was the sneak peek that we have. I think preventing deforestation is an incredibly important part of the climate problem. It's incredibly personal to me as well. One of the reasons I even moved to America as a kid is because my dad was studying sustainable development. How do we basically work with communities to prevent deforestation and essentially teach them that this ultimately harms them? So he came to the US to do his PhD in that, so that's how I ended up here to begin with. So growing up, we always had conversations about deforestation and the environment in general, so for me that's a big one. I think we have a real shot at cracking that problem. And I think blockchain plays a very important role there because you can align incentives and essentially pay people to stop cutting down trees, right? I saw that mentioned in an earlier slide, and it really, it's something we think about a lot as well. So yeah.
Sure. Yeah, that's fantastic. To my second question, closing question, where do I get those socks?
Should hit up Robbie. Okay. Robbie's our head of comms there. Awesome. He actually gave me a sneak peek of a limited edition drop that he's doing with a different climate critter on there. We're thinking of maybe starting to sell merch with all the proceeds going to various kind of environmental foundations and stuff. So he's working on that. We have him working on a ton of stuff. So we'll see when he gets to it. But yeah, hit him up, DM him. He'll send you a pair.
Perfect. Thank you. Thank you, Osho. Fantastic.
Awesome. For sure.
We have just a few moments while we set up for the next talk, but for anybody that can hear me, maybe back in those back rooms, I highly suggest or encourage you all come down, take a seat. This is going to be a fantastic talk. And as we're setting up now, I can go ahead and introduce him. Juan Benet, the founder, CEO of Protocol Labs, is here to talk about impact markets.
Ready to go? Thank you. Super excited to be talking with you today. This is an awesome event. Super cool to see this community gather. Super exciting to see all of the many different projects in trying to make blockchains way more sustainable. It's just super amazing lineup. I'm looking forward to catching up with all of these projects over time as they happen, and I really hope we will have
many of these sustainable blockchain summits to come, because I think gathering this community, talking about these projects, and giving kind of a drumbeat to the whole movement will help us all make sure that we're making significant progress. A huge thank you to the Filecoin Green project in general. It's amazing to see this massive effort to try and estimate the energy that we're using, creating actionable, verifiable ways to offset all of that activity, and get to a point where Filecoin is sustainable, not just sustainable in terms of offsetting the energy use, but becomes actively beneficial to the planet. And so we want to get to a point where having Filecoin operating in a particular nation or in a particular region becomes a beneficial effect in the environment in that area. We have a lot of work to go from where we are now to that. But if we can get there, and then we can kind of create some kind of like multiple of greenness of saying, hey, if you have Filecoin in your environment, in your region, you have like a net positive activity environmentally. Like that would be a fantastic outcome. So thank you to the folks working on this project and to the many other related projects, because I think it's one of the most important things that anybody could be doing, and then especially the blockchain ecosystem could be driving. So what I want to talk about today is a thing called impact markets. And carbon credits and carbon offsets and so on are a special case of a thing called an impact certificate. And I want to talk about these kind of markets more generally because there's a really exciting movement happening now based in great part on all of the successes so far in the green space to extend this activity much further beyond into many other corners of innovation. I like framing this in terms of a chasm in innovation where we have major incentive fields through which we can coordinate a lot of action. These are just two major incentive fields in the world. One is the capital markets that lead to the creation of corporations and business models and business revenue flows and so on which most of the capital economies are based on. And this creates an incentive field for groups to organize, to build products, to sell in a market, and through that solve problems at large scale. There's another incentive field, which is things like the academic credit system, which creates incentives for many scientists and researchers and so on to produce results in the knowledge space, meaning extending the boundaries of what we know and so on. You can think of all of the credit that we give to people for discovering important things as creating long-term incentives for people to work on really critical problems, find solutions, popularize those, and get them diffused into the world. But there's kind of a big problem in the world right now, which is we're missing an effective coordination system or an incentive field in the middle between discovering some really important result or noticing that some important problem needs to be solved and doing the hard work of refining conceptual solutions or really useful knowledge that we have into viable products and viable systems that can go into the market. So the gap here between these two incentive fields is, I think, responsible for many problems in the world. Meaning, if we could somehow create an incentive field that covers this gap, or extend one of these other fields to cover this area, we could get to a much faster pipeline where, as we are discovering new knowledge, as we're discovering new solutions, we can scale them up and apply them worldwide. I'm sure everyone in this room knows a bunch of problem areas where there's some really important, valuable solution, and if only the world did X, it would all be so much better, and things are somehow stuck. Like there's some glue in the environment that prevents those really good ideas, even though a lot of people know about them, from getting implemented and diffused into the market, diffused into the world, and into humans, into our capabilities and so on. And so it's kind of this innovation chasm that is really critical in the sustainability space, and is really critical in many broader groups. And this area is where, if we can create new financial instruments in the middle, then maybe we can sort of extend this kind of capital field over and sort of cover the gap There might be other things, like creating entirely new incentive fields that could be really useful. But impact markets are just one approach to solving this problem, which is to say, let's use financial technology to build mechanisms to extend this capital field over to cover that area. So for example, people noticed, hey, like we could decarbonize the world and sort of like produce these offsets. This is like a really important activity. Who can we sell this product to? Oh, like let's have governments buy these credits. And by governments buying these credits, then the people that are producing these credits then can offset. And the government can get in the middle and say, hey, actually, we want everybody to be sustainable, and there are two approaches. One is either you can like verifiably tell us and show us that your energy use is zero or ideally net green, or you can offset it. And so you now have to go and buy these credits, and so you can create demand for those financial instruments. So impact markets are just kind of a more general version of that same idea. And yeah, I think a lot of people here are super familiar with this story. We've talked a lot about it today. So the certificate of impact story is fairly recent. It's, and of course, this has roots in economics for centuries, probably, maybe millennia. But the idea is that you could create a pretty general instrument where you can write some notion of impact, and if you have a way of selling it to the world, selling it in some market, then you can solve many kinds of coordination problems. More recently, in like the last 10 years, there's been a lot of conversations about these kinds of certificates, about these kinds of instruments and so on. But it sort of reached this very interesting point in the last year where suddenly these conversations that have been going for a while sort of catalyzed a bunch of constructions that could actually be effective in a number of fields. So huge thanks to the EA forum for housing a lot of this conversation. There's an enormous amount of ideation on really great constructions and structures and whatnot through this forum. There's a great talk describing certificates of impact that you can look up. The general idea of a certificate of impact or a benefit market is that you can bottle up some good work, kind of like a carbon credit, and then sell it on a market to somebody else. And similar to how normal money is bottling up some standard utility, right? Like you grow a tomato and you then sell the utility of having a tomato to somebody else. You bottle that utility for yourself in some currency, and now you can go around and spend that currency somewhere else. It's the same idea, just with more generic notions of impact. And so where this is headed, which is, I think, really exciting, is that we're developing a lot of the mechanisms and the theory and the practical implementations for making these markets much broader and on much larger scales. So it's not just kind of like carbon credits or RECs and so on. We're building some very general tools to apply the same kind of thinking to a bunch of other domains and a bunch of other structures. So that's I think, super exciting. And so I encourage you, especially in the sustainability area, think of many other kinds of ways to kind of bridge the gap between some two problems that are not meeting. Think of constructing some financial instrument there that enables parties to profit from doing some good activity. And especially the critical part here is that you can make that verifiable, right? So verifiability, as a lot of people have talked about today, is central to making any of this work. If you have poor verifiability and fraud and so on, then this doesn't work. Like you have broken incentives and whatnot. But if you can make that verifiable, then there's a very general solution to many kinds of problems. There's a recent idea that got published last week called hyper-certificates, which is super exciting, which is a generalization of the structure to kind of create a specific instrument that can sort of reason about the impact of many different kinds of activity sort of mapped within the same space. So you can think of defining a hyper-certificate as establishing a set of rights. The impact has been created by a set of contributors, and so you can map the contributions of the various parties, whether they're individuals or organizations and so on. And that impact sort of covers a specific set of work, so you can identify the work related to achieving that impact, and the time interval over which you mean to, either you did that work, or whether you are going to give credit for that work. So think of it as like you're able to kind of construct a certificate that says, I can grant the impact of having worked on a particular project, and I'm going to create this financial instrument to cover the entirety of all the work that I've ever done from time zero to today. And I want that certificate to cover the credit forever, so like from time now into infinity. And like that's like the base case of something like this. But the moment that you can create that instrument and sell it in a market, you can start doing some pretty interesting things because of these parameters. You can start sort of fractionalizing that time. You can derive some other certificates and say, oh, I want to take this one certificate that covers that entirety of time and then start splitting it up and like subdividing it. Or you can merge other certificates. You can say, I'm going to take this person's certificate over this project and this other person's certificate over this project and merge them into another certificate that kind of covers those two. So that kind of composability and those abstractions are, I think, extremely useful to generalize this whole notion of certificates of impact for many broader things. So it's pretty exciting. The area that's missing is that we don't have good markets outside of the sustainability space. So in the sustainability space already, there are many robust markets with large amounts of money going through them. And if you kind of squint at the problem, you can think of digital art NFTs as kind of like a certificate of impact over creating the art. You're sort of buying, not exactly the credit of building it, but you're buying the credit of having caused this thing to happen. By creating some financial incentive for producing this art, you're encouraging and supporting a lot of people in doing so. And what the NFT markets have done really well is creating extremely good markets for this. They've gotten millions of people around the world very involved in a super diverse space of art. We have 2D digital art, we have 3D digital art, we have entire rooms, we have virtual worlds being created. So it's like a super rich environment. And this NFT world and market has kind of figured out how to make these markets work. So I think like the gap here to close now is how to take whatever we've learned from producing NFT marketplaces and bring that into these impact marketplaces. So one of the things I want to do is like, and if anybody else is interested in doing this, like come and talk to me, is to create a marketplace, kind of like an NFT marketplace, but where we are selling impact certificates. And we can start on some specific areas, like some specific domains where there's like a large community of people that care about that set of things. And we can sort of kickstart the generation of these markets this way. But you could end up in an environment where you can see people's profiles and see all of the impact that they've bought over time. And this way sort of create a notion of like, not exactly leaderboards per se, but sort of profiles of impact. And you can see all of the work that those particular people or organizations have cost retroactively by buying those certificates over time. So I think it's a super interesting area. Hopefully we can use these to sort of close the impact chasm that I showed. Cool. So I will stop here and maybe plug the fact that there's a burgeoning world of public goods funding, both kind of proactive and retroactive. There's many events coming up. In addition to sustainable blockchain work, there's things like funding the commons and Shelling Point. There's the whole green pill movement. So definitely check out a lot of this stuff. Thank you very much.
And now we do have just a few moments for a question or two, if anybody has one burning. David.
Thank you so much for your talk. So today we learned a lot about how difficult it is to estimate actually impact, right? There's a lot of uncertainty factors, a lot of noise. How would you handle that in the hyper-certificate market? Would you allow price discovery to accumulate for the noise, or would you think about other ways to be very transparent?
Yeah, so verifiability is a key piece in any of these impact markets. And I think verifiability is very different per domain, right? So how you go and verify carbon sequestration is extremely different to how you might go verify that somebody saved somebody's life, or that somebody went and donated blood, or that somebody went and discovered a really important scientific principle that then enabled us to do a lot of other work. So I think verifiability is very much dependent upon each field. And you want that activity to also be economically incentivized so that there's a lot of people devoted to working on that. That is a very tricky incentive structure. As we've probably talked about it a lot today, there's all kinds of broken incentives or difficult gaps in each one of these markets. But I also don't think it is intractable. I don't think it's impossible to solve those problems. I think it's just pretty hard and complicated. And if you start with a goal of saying, well, you can get something that's sort of like good enough. There's some threshold of good enough to make the market work. Once you kickstart the market, then a lot of participants get involved in that market. And at that point, they'll start demanding better and better, higher quality verifiability. So just get the verifiability to be good enough, and you can use trust there. You can lean on some amount of honest actors that are helping boot this market up to sort of lend a lot of credibility to the space. And then over time, you'll come up with many different ways of achieving verifiability. But I think like the key is kind of like get the market started, and then all of the participants will be very interested in making sure it's legit, right? So this sort of happened with carbon credits and offsets and so on. There's all kinds of problems today, but if people had waited to have a perfect system, we probably wouldn't have implemented anything up until now. So I very much kind of think we have to be iterative about it.
Yep, one more.
The last question, a lot of pressure. I was curious, kind of an extension on the last question, talking about the different dimensions of sustainability. So we talked a lot today about the digital infrastructure of all these different sustainable blockchain solutions, but I'm also really curious about your thoughts on the social infrastructure that needs to happen. So as an example, there's, the blockchain space is not very diverse from a gender perspective, and obviously because it's predominantly men that are designing these different products and solutions, like there's going to be design bias, we're going to design people out. How do you make sure, and that happens in current impact markets as well, right? If you look at carbon markets or other biodiversity markets, they tend to sort of discriminate against the global south or other sort of historically excluded groups. So how do we, moving forward, build in from like a place of inclusivity as opposed to exclusivity?
Yeah, I mean, I don't think there's a short answer to that. There's like a whole fields of people working on solving these massive problems. I think it starts first and foremost with a lot of principles of people and communities. So in those communities, making sure to open the door at all cases and consider this. I don't know if there's like an impact, like a recursive solution here where like you could use impact certificates in this way, like probably because they're supposed to be general, but I just wouldn't count on it in the short term. I think this is much more a current social problem that needs a lot of action from a lot of people. Yeah, I don't have good answers other than pointing to many other people who have come up with really good answers about how to do it in the space. I think events, broadening the access and understanding of what all of these things does, I think is really useful. So for example, creating a lot of learning materials and opportunities for learning about the technology is really key. So diffusing the understanding of why these things matter, how to use them, and making the entry point really dramatically easier, I think will help a lot. I think creating local communities across the world in a lot of places, diffusing the knowledge there and empowering people there to figure out the knowledge and then let them figure out the components that they want to build, I think is really key. Yeah, I broadly believe in just a lot of knowledge diffusion, just empower a lot of individuals and groups to know why these things matter and let them decide what to do. I think things get really tricky when you start sort of deciding for somebody else what to do, and it's, I think, tends to work better when you sort of diffuse the knowledge. And so I think I don't know, starting projects or working with existing projects to increase access in a lot of places and communities. It's not even like different geographies. Sometimes it's in the same, probably right now here in Austin, there's probably a lot of communities that are totally unaware that a lot of this potential exists. And so broadening access across all of these vectors, I think, will help a lot.
Juan, thank you so much. This has been absolutely amazing.
Thank you.
And we're going to roll right on into our closing fireside. So I want to invite up our two other panelists, Alan Ransell, team lead, project lead for Filecoin Green, and Claire Zhao from the Filecoin Foundation.
Cool, awesome. Well, I'm super excited to be speaking with you today with Clara and Alan, who are working in the Filecoin Foundation and Filecoin Green. I'd love to just kick off by hearing you tell us your stories. Like, how did you get started? How did you get interested in sustainability? What organizations are you working in?
Yeah, happy to start. First off, thank you all of you for being here today. We know there's a lot of events happening at South by, and it means a lot that this is a topic that you all care about in this room. I actually started working in the green movement back in 2008. I wrote to Congress and was really, really angry with what was happening, the lack of action around climate change, and ended up working at the EPA, the Environmental Protection Agency, working on carbon credits. And I saw a lot of failures early on as there was incentives and a new system to really get people to be more environmental. And so what's happening right now in the blockchain space is incredibly important, and I would say you'll hear from us today, incredibly innovative, where there's new mechanisms that blockchain technology allow that did not exist before. Currently, I am the founding officer of the Filecoin Foundation, which was created as an idea since the launch of Filecoin, but has been around for a while. Around a year and a half ago, my co-founder Megan and I, we really put wheels behind it to really build up a team, with a large portion of the team today focused on some of the environmental efforts that you'll hear about. The foundation's goal is really to ensure long-term governance of the Filecoin network, and so we do this through supporting security, funding a lot in grants, a lot of funding mechanisms throughout the Filecoin ecosystem, and then we also look at programs like Filecoin Plus, Filecoin improvement processes. So there's a lot that we're doing and a lot more that we will share later on.
Amazing.
Yeah.
I did not know that was 2008 when you started being involved in these things. I actually also started working in renewable energy in 2008 doing solar cell research. And I did my PhD at MIT in batteries and energy storage. And that led me to sort of really want to understand, right, how do different technologies interact with the power grid? And how can we come up with this really detailed understanding, really good models of what's going into the grid, what's coming out of the grid, and use that knowledge to really shift it in a more sustainable direction. And I started working at Protocol Labs in the research area in 2018 on that problem, on taking this sort of ethos of decentralization and trying to understand at a technical level what it means for power grids that need to start integrating all of these intermittent renewables into a grid that still needs to work as we are undergoing this energy transition and hopefully rapidly decarbonizing the power grid and the rest of our economy. Then the Filecoin network launched, and it started growing really, really fast. I think everyone was really amazed at how quickly it was growing. And people started really asking, how much electricity is this using? What are the environmental impacts? And I started talking especially to Angie about that, and we really hatched this plan to dig really, really deeply into understanding at a super granular level what is the energy consumption, what are the impacts, what tools can we build to be able to first do the research to understand those impacts, then apply that research, build really, really easy to use a dashboard, API, all these things to give people the tools that they need to have a transparent, granular view into how Filecoin is interacting with power grids, and then to take a lot of action to reduce and mitigate that. And ultimately, our goal is to make Filecoin itself, to drop the environmental impacts of Filecoin verifiably below zero is our North Star, right? And so as we're doing this, we're building this up as a team inside of Protocol Labs. We always want to meet new people. Mark just joined from previously at RMI, who had done a lot of work in this space before. Is now on the Filecoin Green team. Orin just joined from Impact Hub, where she's done a ton of tremendous work on building accelerator programs to try to build up entire ecosystems of companies working at solving social problems. And we're really just excited to sort of supercharge that work and apply it to Filecoin and beyond.
Awesome. So just digging into the goals of the project, what does it mean to get measurable impact, right? So this is a pretty hard question and pretty very broad. What are you doing specifically to like figure out how much energy and how we're decarbonizing and so on?
Yeah, right. So first you have to figure out what the impacts are, and then you have to reduce them, and then you have to mitigate them, right? So figuring out what they are, we did a lot of research to really understand, based on on-chain proofs, what are the upper bound, lower bound, and estimate as to the energy use of every single node on the Filecoin network. And just because of the architecture of Filecoin, you can actually see how many resources every node is contributing to the network over time and get really, really granular data on that. So that's all based in the chain. So I think we have really powerful tools there for understanding what those impacts are, at least for electricity. Then moving beyond that, we want to allow storage providers to be able to prove that they are taking action to reduce their impacts. And so we're talking to a lot of storage providers and working on these on-ramps for allowing verifiable actual energy measurements rather than just estimates and building those into our tools. Then thirdly, we're taking all the energy used by Filecoin storage provider nodes and connecting that to renewables. And there were several presentations today about how renewable energy markets work, but we're really building this link between individual nodes and specific renewable generation projects like solar or wind that are powering those nodes.
Yeah, Clara, quick question. So when you look at Filecoin Green from the foundation's perspective, what parts of it are you excited about? What do you wish was working better? Or how do you sort of like look at the project, and what would you, if you could wave a magic wand and have it kind of like grow in some direction, what would it be?
Yeah, so out of the foundation, there's really two pillars we're focused on. Number one is collaboration. We're always looking to collaborate with new organizations. So Alan just mentioned a couple. There's organizations like Decent that we just funded, which are a storage provider that's looking at using solar energy on roofs and mapping that into the work that they're doing on the storage and mining side. So that's really, really interesting, because I don't think there's anything else like that out there right now in the market. So really being able to have these flagship case studies that hopefully we can scale at a broader base. The second area that we're looking at is really transparency. That speaks to a lot of what Alan's saying around transparent dashboards, so that you can really map and see how much energy our 3,000, 4,000 storage providers all around the world, how much they're consuming at any point in time. And if you think about this in the respect of Web 2 and other kinds of industries, there's no one that has started with transparency as the forethought, even before something's launched. Most of the time, people do it because of regulation. We are taking this step to really do this first as we're building. And so I think that's really, really exciting. The area that I am most interested in and excited about that we're about to spearhead is we're trying to get a lot more environmental and public data onto Filecoin. So in 2012, I started working as part of the open data movement in Los Angeles. I started an organization called Hack for LA and was really thinking about what open data means for everyday citizens, because ultimately data like the environment should be accessible to all and should not be manipulated by anyone, right? And it's very easy for companies to hide that today if their numbers are not successful. So I think it's really fascinating because this past December, we worked with the city of New York, and we actually uploaded their open data to Filecoin, to the decentralized web. So it doesn't matter who comes into office, that data will be permanent. And one of the subsets of data we uploaded is air quality data. And so if any kind of government comes in the future, wants to hide that, I know some of that was actually disappeared during the Trump administration, randomly, a lot of we do not know why, but every time that happens, we will have a backup on Filecoin, which is fantastic. And so I think that's really the story about the decentralized web. I think there is no greater cause than something like the environmental data that everyone uses as a public good that we need to have permanent storage for. And so getting more of that data set on, we're gonna be funding a lot more grants around things like ocean data, working with a number of environmental justice groups out of our nonprofit arm, Filecoin Foundation for the Decentralized Web. And so definitely stay tuned for more announcements there.
And I want to pick up on two of those points really quickly. One is what you said about building these transparency tools sort of into the technology at as deep a layer as you possibly can, which is just really something you don't see in Web 2, right? You see a lot of stuff going on and they publish a report and it's harder to. And then the second thing is that, the Filecoin Foundation is now sponsoring grants with a green category, and Orion has been working on this on our team. Please go to our new website, green.filecoin.io, and click on the Open Grants tab, or just go to the Open Grants repo on GitHub. And please do, if you have an idea for a project, please do apply for a grant, because we want to help people build open source tools to do this type of work.
Yeah, let's pick up on that. So what levels of grants are you looking at, and when should people apply? Is it kind of like a entry-level project? Is it like mid-sized projects? Is it large projects?
Yeah, so right now we have 3 available types of grants that I hope all of you guys in this room will click and apply, because there's different ways you can get involved. If you are a storage provider, you're doing something with Filecoin, we have a bug bounty board for storage providers, which can be up to $1,000, $5,000 at most for really quick grants to solve problems that we need on the environmental side. There's the grants that Alan just mentioned. So we launched a category of our developer grants focused on Filecoin Green, where if you're building products or tooling, we can give up to $100,000 under that category. Just submit it. Everything's transparent through GitHub. So we really encourage you to do that. And then the third category of grants, which we're calling the Explorer Awards, just actually was announced last week at our Social Impact Summit for Filecoin Foundation for the Decentralized Web. These are small, rapid grants, up to $10,000 for people exploring what they can do, including the environment, right? So if you want to host a dinner party with environmental justice groups and talk about what the decentralized web can mean for you, we can fund that. If you want to write a white paper, if you want to explore and just spend a month looking at really interesting issues no one's thought about, we can fund that. And so these are really great ways for, no matter what level you're at, you can get involved, and everyone should definitely find a way to.
So, Alan, what are the sort of things that you would encourage, what are the projects that you're seeing that you would encourage to apply for some of these grants, or things that you would like to see happen in the ecosystem?
Yeah, I think part of what we are doing internally in the Filecoin Green team is really building the basis, so the basic infrastructure to make data available so people can start getting transparency, right, into what these impacts are in the context of their particular project, right? So we're building the infrastructure to let you know how much energy is being used, where renewable energy is coming from, if it's being bought, all of that. And so we really want to see what the community is able to do to push that forward. So specific ideas are things like looking at marginal emissions factors from grids, or just average emissions factors. Your grid carbon intensity varies based on where you are in the world, right? And so we want to see how people take this location data and this energy use data and translate that into different projects, right? Where you can, see if I do this thing in Web3, right, in my project, and that ultimately traces back to actions happening on Filecoin, how is my environmental footprint affected by that, right? And we really want to build Web3 into the space that you need to be working in if you're doing environmental accounting, because we think the potential for these tools is just so comprehensive and so powerful to be able to take input data from whoever my supplier is or whoever I'm connecting with, right? Then figure out what my impact is in my project, and then pass that data along to whoever's building on top of my stack, right? And so we think that anyone who wants to build pieces of that, we want to talk to you, and we want to support you in building all of that in a super transparent and verifiable way.
Okay, same question. What are the sort of projects that you would be excited to see happening at a larger scale? Like maybe say somebody goes and gets an Explorer grant and they discover some problem space, or somebody would like to go do that, they just might not know which area to go to. Towards what kind of problems would you point them to?
Yeah, I think there's so much. I think today there's so much innovation that is happening in blockchain that the public doesn't even think about. I think there's so much negative press on blockchain and the environment. I think a project just exploring what can we do that's innovative in the blockchain space for the environment that no other technology has been able to do in the past. And that's a really interesting narrative, because I think a lot of people are still wrapping their head around what is blockchain, what is the purpose. They get lost in the world of NFTs and some of the crazy stories in NFT world that they don't really think about the underlying technology, which is built off transparency, verifiability. There's a lot of companies today that are even exploring with carbon credits that the government is giving out, right? How to even verify that those are that companies are doing what they're saying with measuring carbon removal. And so I think there's so much that we haven't even scratched the surface of that we can highlight with what is happening with how quickly blockchain is being developed. And then second, there's a ton of events happening that is nearly monthly. Alan runs a monthly Filecoin Green meetup that if you guys want to continue this conversation, you should attend. Biden just passed an executive order on crypto that I'm sure many of us in this room are all familiar with. One of the things he calls out is making sure that we are doing what we can in innovating, but also thinking about climate mitigation at the same time. And so we're going to be talking also about some of our work. Some we can't share yet, but we will share at places like Davos in May. And so I think it'll be really interesting to really carry the conversation in front of not just an audience like this that is already familiar, but also with policymakers and executives that may not necessarily wrap their head around what is so exciting right now in this space.
Yeah, so super important. So digging into that, right now there are a lot of bad memes around blockchains and energy use and so on. What do we have to, how can we change that, that narrative and those memes? What are the kinds of things that have already happened that we can point to as really great indicators? Or maybe what are the things that you would like to see happen in the near term so that we can then point to that and say, like, look, like this is a way more greener computing platform than the current ones.
Yeah, I mean, I think the way you change the memes is by doing a really good job at being verifiably and transparently sustainable. And so, you know, I think establishing these tools, right, is a really important step to like let people make it not something that is just, you know, an impression people have out in the internet, right, but is actually grounded in real data, right, and like that is something that Web3 excels at. That is, you know, the thing Web3 excels at, right, is taking all of these claims and making them extremely transparent and verifiable. And so I think that, you know, that's part of it is building that tech stack in a way that enables really solid claims. Then I think another part of it is pushing to do things like make sure that when we make a claim, we don't just leave it at that and say we're done, right? We're really searching for what are all of the different ways that we as an ecosystem can catalyze the renewable energy transition and catalyze in more broadly a sustainable relationship between the economy and natural systems, right? And so, you know, we are connecting the network to renewable energy. We're also building more solar, right? So Protocol Labs just put $35 million into a fund that's going to be building more solar in the US. Things like that it's not just about, you know, checking a box, but it's about really digging in and doing a better job than the legacy economy is equipped to do at substantiating these claims and pushing our sustainability agenda farther than you can push it in just Web 2.
So one part is building the tools and the measurement to make it all verifiable and legitimate. Great, so we can do all of that, and then what if we fail on communicating the story? So what, maybe where to go from that? How do we tell the story to the world and point out what is already happening that's really good, that or what's coming?
Yeah, so I would love to share a new initiative we just announced last week called the Decentralized Futures Council. This is something where we're trying to tell policymakers and the general public about how the work that we're doing around infrastructure for the web is slightly different from some of the innovation happening on the DeFi side. And so I think that constant education and storytelling is more critical now than ever because most people don't quite understand the infrastructure level. It's not sexy, it's not interesting, it's not cute like some NFTs, but it's the most important thing that is out there to really think about the next structure of the web that all governments and the public eventually will have to deal with. And so I think investing in places like this, we're a huge advocate of the Blockchain Association that does a lot of this translation to policymakers on a constant basis. And so constant education. I think all of you guys in this room, everyone plays a critical role in also co-telling that story with us, right? And so bring people along this journey. I know there's so many different groups popping up. During ETH Denver, we met with an ESG DAO that's bringing together a number of environmental activist groups and really thinking about renewables in a different way, right? And so there's so many structures in blockchain that make it so much easier to bring people, even those that are not technologists or builders, to the table to really start this conversation. And I think it's not just up to us here, but the entire ecosystem and everyone else involved to also carry the conversation forward.
100%, yeah. And I think taking that and sort of extending it, right? There's so much potential. I think a lot of times in this space we focus on the tech, but there is so much potential to take everything that's going on in governance and in DAOs and in impact markets and public goods, this whole sort of movement within crypto more generally, and apply that to environmental problems, right? So I'm thinking of systems that don't just decide what your footprint is or whether your offset is good or not, but decides who decides, right? How do we take groups of people throughout the world and empower them to make decisions and then discuss and have discourse about how we want to govern these systems and translate that into action? And I think just there's so many directions to go with that, and that's something we want to help build. All of these primitives and apply them to these sorts of problems.
Since we're in the NFT house and there's a lot of NFT art happening now, I think art can be tremendously impactful in conveying messages and communicating how what things matter. Maybe we should just start buying a lot of NFTs that show and tell the story of this kind of thing, right? So I wonder if there's a way. Maybe there's something missing in the space. Could you run an auction for basically commit some capital ahead and say, we will buy this many NFTs that tell this story in the most compelling way possible, and just let people generate really amazing things and buy the best ones.
Yeah, I was going to say, I think in 2007, 2008, when an inconvenient truth hit the wide market, it woke up the world to what was happening in the environmental crisis. And most people forget that NFTs are not just JPEGs, they're all kinds of content forms. And so, there could be another version of the inconvenient truth, or some artist or some filmmaker that creates that. We could do that through the Explorer grant. We can do that through, again, one of our funding mechanisms. But I think there is so much that is out there that we can do in this space as a community.
Yeah, I'm reminded that the Mona team, who's in the audience, wants to run a builds for green spaces. And so maybe doing something like that in the future would be really cool. Great, so I would love to wrap up with some calls to action for the audience, both the people here, the people watching this, the people discussing this talk later on. I personally want to call everyone to take decarbonizing the world extremely seriously and lean into the super powerful tools that blockchain systems give us. They're a way of programming the world, and think of more ways of doing that, or lean into the ones that exist. And maybe, so I would love to kind of turn it to you. What calls to action would you have for the people in the audience, for the people here in this talk, whether storage providers or developers or communicators?
Yeah, 100%. On the storage provider side, I am incredibly inspired by all the work that SPs are doing to take all of this data and, not just data on or take data on what they are doing to become more sustainable and make that public and verifiable and sort of blaze the trail in allowing a lot of projects and distributed networks to do the same, right? And so I think if you're an SP, definitely take a look at the dashboard, look at what it says and compare it to your actual energy use, and help us build on-ramps to put actual measurements in the dashboard and in other places, right? Store actual power measurements online and start basing decisions based on a measurement, not an estimate. It's really powerful, and we are figuring out how to do that now and are working on that. So please, be involved in that. If you are building a project or involved in a project, please apply for a grant or talk to us about what your project is and how we can support you in doing that.
Yeah, and then third, we are always looking for new talent in our ecosystem, whether that's something that we can fund, whether that's a job, whether that's working for Filecoin Green. We have a ton of jobs at the foundation as well. A lot of our storage providers are also hiring. And so definitely let us know if you want to work with us if you don't already, because we are always hiring and we want the smartest people to solve these hard problems that no one has simple answers to, but is a very fun journey to problem solve together.
Thank you. Well, get involved, spread the word, take the link to this talk and spread it out, and join us at the next Sustainable Blockchain Summit. Thank you.
Awesome. And once more, a round of applause for Juan, Clara, and Alan. All right, everyone, it's over. No. As Juan said, we are going to do another Sustainable Blockchain Summit, but we're taking it to my side of the pond, and it's going to take place in Paris in July 2022. So keep an eye on the Filecoin Green Twitter. It's at Filecoin Green. To learn more, we're going to have an open CFP, so if you didn't get the opportunity to speak today, we want to hear your voices. We want to hear about your projects. Now, on behalf of the Filecoin Green team, we'd love you to join us for a drink or two. Next door, we have a bar set up. We have some lovely canopies. Thank you so much again for joining us. Thank you so much to our speakers. And we'll see you in July. Take care. Thank you.